claiming that that value is a constant.
Okay, so you're saying light has a variable speed in a vacuum.
No, dude, for fuck's sake.
It's either
I'm telling
constant or
you.
it's variable. It's
No,
like
dude.
that's like a zero.
I'm telling
one
you
thing.
what that statement is expressing. That statement is expressing that time in a vacuum travels at that speed. And that speed that it travels at, that value is a universal constant called C. That's what the thing is saying.
Okay, listen.
Yeah, it is.
Listen, does light in a vacuum travel at a constant speed, or does it travel at a variable speed?
Well, if it's not impeded by anything, it travels at the speed. It travels at C, the maximum speed. It has no mass.
Is it being
so
impeded in anything in a vacuum?
Well, I said if it's not impeded by anything, then it will travel at C, the speed of light.
Is there anything to impede it?
I'm not sure. I'm not sure if there's I'm not sure what's going on in this vacuum. But however, if it's not being impeded by anything, it will travel at C, the speed of light.
The constant speed of C.
A universal constant. That's right.
So not variable, a constant. Okay.
That value is not a variable. Is not a variable that changes. It's a constant variable.
It's a constant. It's a constant variable.
Yeah, dude.
Come on, bro.
Listen, dude. In programming, in math, that's what these things are called, man. Okay. You like to Google definitions half the time, but not all the time. I'll tell you. Okay, so I'm gonna read something for you. Difference between constants and variables. Okay, constant variables does not change its value over time. A variable, on the other hand, changes its value dependent on the equation. Constants are usually written in numbers, usually. But if they, like pi, the universal constant, a Planck's constant, what's that one?
Pi is a constant with 3.14, just like the speed of light in a vacuum. Pi is another constant, always the same number. It doesn't vary.
Yeah, exactly. Those numbers do not vary.
Always the same.
Pi, yes.
Always the same. Yeah. So what are we arguing about here?
You tell me. I'm just letting you know that whenever, because somebody said, as he said, you guys are changing it. You guys say light is a constant speed, and I'm saying, well, no. People may have spoken loosely before, but in this community, oftentimes somebody, usually a rat bastard, will stick onto a point so long that you have to be so careful on how you say things to make sure that it doesn't get dishonestly used against you just because of the wording that you used. But so I'm just being clear when I say that it's the upper limit to the speed of light, not the constant speed.
And also the
light.
We made him change the saying. You heard it. It's an upper limit now.
It's not that the saying has changed.
Really good.
C is not the upper limit. It's the constant speed light travels in a vacuum. That's why they called it C. That's just the speed light goes in a vacuum constantly.
Yeah, anything that has no mass, that's unimpeded, will travel at that speed. C.
It's not true. That's not even true. Well,
it is true. Okay, well, how is that not true?
Do you remember the papers we went over back in the day with the group velocity and all that?
Yeah, I'm not sure that you understand what those means though. Group velocity versus phase velocity.
I don't understand what those means.
Listen, dude, don't. You get me flustered, dude. English is not my first language.
What is it?
It's a different language, dude. But
is it Swahili? Because your mom used to suck boogers out of elephant tusks.
My God, dude. What is it with you and tusks, dude? Why not the fucking what's it called? The trunk.
What's up?
Tusk is a bone.
I know, that's why it's so impressive.
Oh my God. All right. Anyways, dude. Yeah, you want to get back into that phase velocity, group velocity thing because that's you got that wrong still, dude.
No, dude. I want you to concede that the people on the train will experience going from one stake in the ground to the other stake in the ground. Do not concede that point, that they will experience going from physical stake to physical stake that's now in the ground.
Dude, it's invalid for you to describe two components of two different reference frames as if they are one reference frame. That's an invalid description, and that's where that's where the flaw is.
Are the people on the train experiencing going from one physical stake in the ground to the next physical stake in the ground? Do they experience that?
In their reference frame, yes. So you need to use their coordinate system to describe it.
We're gonna use their what?
You need to use their coordinate system to describe it.
Yeah, in their coordinate system, they went from the stake in the ground to the stake in the ground. Yes.
Yeah. So in that same time, the train went in that. The light went in that distance. So the light goes in that distance.
Breaks your speed of light.
Yeah, but here's the problem: is they're not at that
problem.
stake.
Dude, this is not here's the problem. Yes, here's the problem. This is your problem. You're about to explain it. Go ahead.
Yeah. So anyways, they're not at that stake at the time that the people outside the train have. An example of the 259 million meters per second. The people outside the train experience 2 seconds, while the people on the train experience 1. So that means that when you're referencing the stakes in the train, you reference their coordinate system. That's fine. That's the correct distance and the correct speed. You reference it off the train, it's a longer distance in half the speed, or in half the time, or twice the time, so half the speed of what you're claiming it would be. Yeah. So it's a longer distance, almost double the distance, but definitely half the time. So it's a longer distance, so it's twice the time, so it's half the speed.
For the people on the train, they got a clock. They shoot the stakes in the ground. One set of stakes gives them the speed of light. The ones on the train, the stakes they put in the train. The other speed, since it's a longer distance, is going to be faster than the speed of light. And they experienced everything going through that distance in their reference frame. Don't try to play. The reference frames are not going to save you.
You ever seen Wedding Singer?
Reference frame thing, bro. This ain't a reference frame thing, dude.
You ever seen Wedding Singer?
This isn't a Lorentz contraction thing, a time dilation thing, nothing. I've seen a Wedding Singer, yes.
What are you talking about?
You remind me of that song, dude. You sound like a broken fucking record. Now I'm thinking of that song.
Dude, you know who makes the best motherfucking meatballs? My grandmother. Let's go.
Your wife? Oh, your grandma's is pretty good too, yeah.
So listen, the reference frame thing is not helping you.
You know what you should do? That. Maybe one day, I can go over reference frames with you until you fucking get it. So maybe a year, 2 years, 10 years, and then you can do a reverse demonstration of you making meatballs. You said your grandma makes the best meatballs, but I mean, I'm sure you picked up her recipe, no? Did you not?
Yeah, I don't know. He probably
listen to me. Yeah, reverse psychology.
I guess that's a tough thing for him. You didn't pick up your grandma's recipe.
Dude, reverse psychology doesn't work on me, all right? Reverse cowgirl, that usually works, but
get me interested in the meatballs. I'm not very good at making meatballs. I made some meatballs. They were actually okay. I wasn't the happiest with them, but I read a lot of recipes whenever I make something. I read like 5 or 6 different recipes, so I can get different
the best version
perspectives. Of the meat. Yeah, exactly. I pull from different people's methods and get like what works best. But I make them okay. But I like to hear people. There's really only one good thing about Italians. Okay, there's some good Sicilians out there, but Italians in general are greasy people. But they make decent pastas and meatballs and stuff. So it's good to get the recipes.
Yeah,
I'm actually interested. You should go over your meatballs sometime. I'd be interested.
I actually want to go over the hairy testicle theory or whatever you guys were talking about the other day.
I know you do. I can hear your mouth salivating.
Is that a real thing? Or I still don't even know if that's a real thing or not. I mean,
it's absolutely a real thing.
What?
It's topology. In topology, there's a theorem called the hairy ball theorem. And
okay, yeah, I know what you're talking about. Okay. It sounds so trollish, but it's a legitimate thing, though. Isn't the
hairy
idea
ball theorem?
Yeah, no, because I think it's like you can't fit like the hairs like properly. I don't know, some weird shit where it's like if you try to do it, like
it's about combing it. It's about simulating combing the hair. So on different surfaces, you can comb So it's all about the vectors of where those hairs eventually end up, basically. But it's like if you were imagine a ball, if you're on a ball and you combed all of the ball, all the hair on the ball,
Yeah.
how many poles basically it's like how many poles would you end up with? Because eventually you'd have to brush it all the way around and all the way around. You'd end up at a point. You pull it up and it would all circle around a point.
Yeah.
2 points really on a sphere. And so different surfaces have different amounts of these poles things.
Can't believe it's actually called that though. But I've seen that though. It's funny.
Well, Jeremy's enamored with it. He loves hairball theorem. So
Wow, what did I come into? Hey, just so you know, Kosha, I found a place that's pretty fire, bro. You can find tons of papers on this.
what do you mean? So it's like a place where they wait, but so it's papers that because there's a lot of papers that are like newer and stuff like that, but it's got even like it's got papers that other places will have paywalls on.
Yeah. It doesn't. I'm not gonna say it has everything, but I've found some of the papers that I couldn't previously get. Yeah, it's like, yeah, like what they
I
say.
guess for
is like,
older papers. Yeah.
Even scientists are pirates, is what it says.
Oh, well,
That's
Shouldn't,
pretty
that's
shouldn't
cool.
all
That's
this
cool.
science,
That's
shouldn't all
cool.
this science, if you wanted to advance humanity and progress, shouldn't all this science just be wide open, free to everyone to view? I mean, why would we do this? Isn't it all already paid for with grants and shit?
I was gonna really fucking get at you, Jeremy, because you've been pissing me off lately in this conversation. But I'm just gonna say I said this yesterday to Witsit and whoever else was in the conversation that I'm pretty sure that this is one of those circumstances. It's just like Netflix, dude. They want to feel like they can make money off owning the rights to it, and you have to subscribe to their thing, so they make money off it. It's really just a money making thing.
I mean, no, is it science or is it a money making thing? What are we doing here?
Well,
Are we doing science or are we trying to make money?
they tend to give it for free to scientists if you're part of a university. And
Everyone's a scientist. Ask the extremist if I'm a scientist.
Anyway, this is pretty cool. Sci-Hub.
Yeah. Yeah, because a lot of these papers that have shown. So I had read a couple of these back in the day about thunderstorms and lightning storms changing downward acceleration rate in a gravimeter, and they're like hard to find now. But I found a few using this. So, like, I mean, I had the name of the papers, but anyway, so many people
that
like
one
were accusing me of
building
making that up. So, what's up, Jeremy?
No, there's that building they do. They're just constantly. Me and Kosha went over it a couple years ago. The building they're just constantly doing gravity testing, and they said that when clouds go by or the wind blows. Yeah, like if the wind blows or clouds go by or birds start chirping, it changes the acceleration rate.
Anything they can claim changes the distribution of mass, they're going to try to integrate that into their just gravity. I'm concerned with the change of like electrical variables.
Yeah, I'd love to see the real time data for that. If there's a lightning strikes happen or something crazy, yeah, that'd be fucking dope, bro. That'd be the best time to start dropping shit and lightning storms, whatever. Yeah. Planes go over anything. Just constantly having all this data. I mean, where's that data? How often are they dropping shit? Isn't that all they do there?
What's this place called? It doesn't have a lot of them, man.
I always forget the fucking name, but it's in. I want to say it's in Greenwich, but I'm pretty sure it's in UK. I know it's in UK. I'm pretty sure it's in England, but I always forget what the fuck it's called. But basically, this place has a gravimeter, and they use this place to study the changes of gravity. And the only place I can lead you to is that one documentary show called Spark. There was an episode they did about gravity, and he visits that place. So I could probably pull that up and try to find out what it was called. But
oh wow, they're upgrading Wiley Online Library right now. What a joke.
I mean, shouldn't we have like the Library of Alexandria thing going with all this science and knowledge in it and stuff that's just free for everyone on Earth to go browse?
Why would a rich man teach you how to make money? Why would a governing body teach you how to take over control? Don't be
I
silly.
mean, the internet is a very it's much better than Library of Alexandria, although it doesn't have Alexandria didn't have all the trash, so you got to sift through the trash. But we have a lot more information available.
No, you can't
Like I
just
said,
go do it. You got to pay for it. I can
no,
just
no,
go
that
walk
yeah,
into
but
the
that's
library.
specific.
Listen to me. I can go walk in the Library of Alexandria. There's all the science books there, right? I don't have to buy anything. I don't have to pay anything. Witsit is trying to get these science things, and he's got to pay money. I mean, what the fuck, man?
Imagine the institutions that you pay, right, to create knowledge, and there's a lot of taxpayer funding money going in there. Somebody has to pay to get the knowledge. That's
What?
that's unbelievable.
No, that's not the case. So when people go to publish journals, they'll publish it in a journal that is respectable. So that journal then has the control over who is going to be able to read that, and they give it to free. They give it freely to universities and probably science places or whatever. But to the public, they make them subscribe to their journals to get access to it. And it's just that's just them, trying to squeeze money out of people for their what they provide.
Yeah,
But I agree.
shouldn't
I
be.
agree that it should. I agree. It should. I agree. It'd be nice if it was free, but it'd be nice if everything was free. I don't know what to tell you.
Well,
No,
it
not
seems like a
everything.
lot of times it's the stuff that we really want that kind of questions the current narrative. They're almost always behind a paywall. But it's not just that stuff, but
I'm gonna test it out now. I'm gonna find something that I've been wanting to get into, and is currently behind a paywall. I'm gonna type into this website and see if it's available.
yeah, I mean, it's not actually pulling up a lot of them for me, unfortunately. But I do have I have a lot of people on my Telegram trying to help me out, so we'll figure it out.
I'm sure there's at least one flat earther who's still like a student somewhere.
No, of course, I already have people, but it's not even. Some of them don't even have access to that. So still behind a
Oh yeah, it
paywall.
depends. Yeah, some of them.
There's all kinds of people that are flat earthers with college degrees, my brother.
Well, I mean, currently students though is what I'm saying, because
Yeah.
most of the time, some places you can get in with just a college email, but some places, yeah, you have to actually it has to be available to your university.
I do have a good paper right now about the downward acceleration measurements changing because of thunderstorms.
I'm gonna find out more about this website though. I want to see how they see
I had much
I want
higher
to see
hopes
how
towards
they
it.
how they I want to see how they get their because it looks like they need help, like they're on a mission to get all the papers.
I mean, dude, what you're saying is so crazy. You're saying because I'm on a moving object, and I'm not in the reference frame of the ground. I'm not experiencing moving that distance.
Yeah, I hear you whispering, Jeremy.
My wife's laughing at me because that shit sounded crazy, right, babe? Yeah. Yeah, that sounded crazy. I know. My wife don't even know about reference frame. She knows that's crazy. Your goose is cooked, sir. That's literally your argument for why the light's not going faster than the speed of light. The stakes in the ground blew it wide open.
No, it did not. You lie. I kind of want to do a graphic now on like Blender. You know how I usually do those Blender models? I kind of want to do a Blender model on this. That'd be interesting.
Try to put in constant variable. It's going to be one of my new favorite words now.
Well, I mean, it would be an animation, so there wouldn't really be any variables. It would just.
What would a constant variable look like? Something continuously changing?
No, I think a constant variable is that it's constant. It stays the same.
A constant. Listen to the words carefully. Say them separately.
Yeah, but we're talking about like coding though. Like when you're doing coding, like you got. I guess we really call it a variable. I guess it would just be a constant because I know in coding, you have variables. I know in some programs, you don't really. I mean, I guess you could call them variables, but it's like a coding thing. Like that's what it's called. This one I've seen anyway. I've called them variables. I get what you're getting at though. Variables are supposed to, in the name it varies, whatever, but it's a coding thing.
So not an actual thing, a made up thing.
Well, no, hold on. Let me look up real fast. Let me look this up because I know with coding it's named that. It might just be a naming convention. Let me see. Variables that you manage to keep constant controls over, right? That's a control variable, so not to keep there. Yeah, I'm getting a few things for constant variables, but let me see. So C plus, what is this? I mean, yeah, I guess you can call them constant variables, but I think they're usually just called constants, though. Constant is a name data, while variables are name data with close. Language JavaScript,
Because to me, you could either have a constant or you can have a variable.
All right, then it's just a semantics thing.
Constant
I mean, it's
variable?
all right. Then I guess it's just a silly naming convention. Then I wouldn't really worry about it. Researchers could change control variables, but they're keeping constant. Yeah.
Yeah, it's very simple, dude. Like when normally in math, the constants, like if you're talking about a constant versus a variable, you have x, y, the variables 8, 9, 10, 11, 12. Those are constants in the equation. But sometimes you have numbers that have symbols that are not variable, and those are constants, like pi, g, h, c. Those are physical constants. The latter three. So yeah, those are just. I'm just letting you know that they're constant and they have symbols. Okay.
Yeah.
That's what's meant when I
Yeah,
say
but
they have
we were
constants.
talking about light. Osho, we were talking about light.
Okay.
Not math.
Yeah, well, when they say universal constant, they're referring to that. They're not referring to it as some They're not. They don't mean it in the way that you're using it. Like they mean it in a way that the number doesn't change. The C is a number that it doesn't change. That's what's meant. Not that light travels at a constant speed. It's just that C is a constant. Big G is a constant, but gravity, it has nothing to do with speed.
Is the speed of light constant or variable?
It's variable.
Okay. This is what a day today has been.
You guys,
Wow.
is C variable? C is a constant. C is a constant. The other day, somebody pulled up a paper.
How many times did Jeremy read that thing out to you, bro?
A lot of times, 10 times, and each time it said light travels through a vacuum at. Although it says the speed that light travels through a vacuum is known as a universal constant. That's right. That universal the value that it travels is a universal constant. That universal constant is C.
But light is variable. I just want to get it straight. I don't want you changing the story tomorrow.
Yeah.
The speed of light is.
Have you ever noticed light to go at a slower speed? Have you ever noticed that refraction takes place? Refraction takes place. Light travels at different speeds and different mediums. There you go.
Yeah, of course. But that's not the question I asked you. The speed of light in a vacuum, is it variable or is it constant?
That goes at one speed. If there's nothing impeding it, and it's anything that has no mass in the vacuum will go at that speed. That's the upper limit.
So constant speed.
That's not what this says.
Is that what says?
It says no matter how you measure it, the speed of light is always the same. Einstein's crucial. Yeah. Einstein's crucial breakthrough about the nature of light. No matter how you measure it.
Right. They're talking about from which reference frame. But yeah, no matter how you measure, no matter how you measure light in a vacuum, yeah, it will be going at the speed of light.
Doesn't say vacuum.
I know, but it's leaving that part out.
Yeah, that's weird.
It's leaving that part out. Okay.
Of light is constant. Even like Harvard and all them say the speed of light is constant. It just travels a different distance, right?
They don't
But
say
the
that.
speed is the same. Yeah, they are. So they're changing the distance of the light traveled. That's why they can slow it down.
Yeah, but that idea of how light slows down in a medium is just it's an interpretation it's not the correct interpretation, but it's one that is expressed sometimes by even educators, but it's not the correct interpretation. Because the interpretation, the interpretation of what's actually happening has to do with the light and the what's it called? Superposition path. So it's a superposition of all the paths it's taking, and the electrons that are the field that's created by the electrons in the material. They all combine, and all the waves, deconstructive and constructive, add up and equal a speed that is slower than the speed of the of light through a vacuum. That's the speed that's experienced. And I'm not saying this because I came up with this. This is what's been somebody else came up with.
The other day. The speed is the same. It doesn't change. It's just the path that it takes is different.
I used to say this a few years ago, but a couple years ago I learned a couple years ago that that's not the correct interpretation.
Now you're saying it's variable today. This was the
other day. It is variable.
That's not what you said the other day. You said it was constant. The path.
I corrected Zanuck when he said that. Zanuck had said that, and I said, "Well, by the way, because I heard a couple people said it today, Zanuck. It turns out that it's not. It doesn't. That's not exactly what it does." And then Jace wrote out in the chat. He wrote out what it actually does, and we all agreed, like, okay, now we're on the same page.
Can I ask you a question, Kosho? In your model, would there be a difference in distance and speed of a single candle compared to like the sun, where obviously the intensity is much greater?
About a candle, like if the light from a candle or a candle itself. I'm guessing you mean the light from the candle.
Well, obviously, yeah, a single candle light, versus the sun. Is there going to be a difference in distance and the speed at which it arrives to that said distance?
Well, first of all, a candle is going to have a lot less luminosity, so a lot less photons. So it may or may not have photons that like end up at that location. So it might not be seen depending on what distance you're talking about. Like they'll spread out, and it'll have so few, such few. The energy will be so few, and the sphere will be so big after a certain distance that an observation at that distance may or may not receive the light. So, but let's say that it's at a position that will receive a photon and it can be detected. Then the photons from the sun or the candle will be received at the same time.
Okay, so the speed doesn't change, only the distance that it reaches.
They both travel. They both travel, infinitely. They don't stop traveling. It's just the candlelight is going to spread out. They're both going to spread out at the same rate, and there's so much less energy from the candle that at a certain distance it's going to have spread out beyond the range of the observer. So it'll go like around the observer. He's probably not going to see a photon at all, let alone multiple photons.
But yet there's going to be some photons, right, going the same distance and speed is what you're saying.
Yeah, the photons from both objects will travel the same distance at the same time, yes. Why do you ask, Mr. Dyson?
I was just curious. I got my wife talking to me right now. Hold on.
Everyone's wife talking to them about getting their wives involved in this now.
Yeah, we're all married, dude. So which one is more?
Which one's what? Say?
Variable.
Which one's more variable?
If you had the sunlight and the candlelight and the same things that are making it variable, like change speeds, would one change more than the other?
What do you mean? I don't understand why they change speeds.
Variable speeds now.
No, yeah, through a medium. So a medium will be one reason why the speed will change. Yeah.
Okay, so you send a candlelight through the medium and the sunlight through the medium. Does it travel? Does it vary differently?
No.
Huh. So the speed of light through water slows down.
Yes.
And when it goes out of that water, it speeds back up.
Oh no. So the light itself, like the photon, that's called the photon, the wave that the light is that is a photon, right? That's going to be going at the same speed, but those waves interfere with each other when it's going through the medium. So like
single photon can pull it down for a concrete layer. So single photon comes out of a light source, hits water. Does that photon slow down?
No, but a single photon will still have the same behavior in the medium.
Does it slow down?
Yeah, it slows down. It interferes with
when that single photon exits the water, does it speed back up?
It does. I mean, the speed will be increased. Yes.
So it does speed back up.
Yes, but it's not, like I said, it's the way that you're saying it is like the photon doesn't like actually slow down, but it will be experienced at a slower speed. That's probably a better way to say it.
So you said it varies. The speed varies. You're saying the speed of light varies going through the water. It slows down.
Yeah, I know, but I don't feel comfortable saying that it slows down because it's not necessarily slowing down. It's just that
So just the way you see it varies, not the photon itself slowing down. So now
what it appears to be doing is it appears to be slowing down. Yes, but it's really just it's a consequence of the wave nature and the superposition of its path, along with the electrons that are emitting photons. That are emitting electron fields in the material.
Let's A to B, right? Photon traveling A to B with no medium. You measure it at the speed of light. When you put a medium, let's say halfway, you put a medium that's water that's about half the distance. Does the time change? that light travels from A to B now? You see where I'm going? I mean, I'm
That's my
dumb,
point. That's
man.
my point. That's my point, though, man. Is that that's why it's said that way. But when you actually ask what's actually happening, it's not the case that it's staying the same speed and just going to a different longer length. It's not the case that it's slowing down. It's a weird, like I said, superposition and
I agree.
wave combination. Yeah, so it's just
You're saying the light is variable though because of the medium. You're giving me a specific example that the medium change. Let's say water slows the light down. So when you go from A to B with no water, it's one speed. And when you put water from A to B, it's a different speed.
you're gonna experience a different speed. Yes.
So slows it down.
Yeah, from what it appears, it slows it down.
All right, buddy.
Like I said, there's a way to say this so that it can sound confusing, and there's a way to understand this, and it's probably best to try and. I'm not the best person to get the understanding from, okay, but it's probably best to try. It's probably best to try to gain the understanding that's actually expressed in our paradigm. And like I said, for a long time I was sharing it. Oh, look who fucking joins the fucking party, dude! This motherfucker. Dude. Go ahead, Bacon. I'm done.
I was gonna ask you a question.
Ask your question, dude. To them.
Right. No, it's to you. I'm trying to understand how this thing works. I mean, I've seen explanations for it, and I had this question that I'm not sure what the answer is. Maybe you do.
I saw you and Ruhif yesterday, man.
Yeah, that was a good debate. You guys, that's really good.
It was awesome. Y'all must have been.
Thank you.
Why don't you guys shut the fuck up?
I think it's who you chose not to involve, which made the debate even better.
My God.
What is it?
I don't know.
Didn't really catch it though, Bacon. So
the question is.
Yeah, go ahead.
Okay, the understanding I have of like why photons are slower in a medium is that when you send a radio wave through that medium, that radio wave interfere with the electrons in the atoms, and that creates a second wave, and the combination of the two waves makes slower photons. Does that sound correct?
That sounds correct.
Right. But then I'm like I can't not picture that you still have those two waves traveling the speed of light. Would that also be correct if you be able to see them separately? Would they be still traveling the speed of light?
I think the problem is in that statement, and also because of like this how waves travel in general. Because I'm posting this thing now again about the phase velocity versus the group velocity, and so like when you look at how the waves that are moving, the way they interact with each other, it's going to be like the troughs and the peaks and all that kind of stuff. But the way that you experience light, okay.
I'm lost because there are 6 different things going on there.
Yeah, well, it's showing you it's showing you the distinction between what phase velocity is and what group velocity is, and group velocity is basically how the peaks of the wave, how those are moving, right? Whereas the phase velocity is more of a description of how the wave is changing, how the changing wave is moving. If that makes sense. I don't know how best to describe that.
Oh, I think I have to parse it for a while.
Yeah. So if you. Yeah. Okay. So
I have to make sense of this GIF first.
Okay. So check this out. If you can either imagine the highest peak and how it's moving across the path. So the highest peak, just follow it the whole way it travels, or you can imagine one point on the graph, and as that number goes above and below the sine wave, just keep that point fixed. Like those are just two ways of viewing how the wave is moving. One's the phase velocity, one's the group velocity.
Yeah, I couldn't follow that. I'll try to understand what those two are in my own time. Once I'm done that, I'll back to.
Okay, fair enough.
This It's a bit complicated for me.
It is slightly complicated, but this is also why Jeremy had a observation of how they experienced photons going slower than the speed of light in a vacuum, and this is the reason. It's because of the what was it? The group. The group velocity of the photon was going slower, but the phase velocity was what actually is how it's measured, or that might be the other way around.
Okay, yeah, I gotta make sense of those terms first to make sense of the rest of it.
As I told them earlier, I'll say it to you. I'm not the best person to get this information from, dude. So take it for what you will. I mean, you already knew that, Bacon. That's why you and Ruhif had your fucking date together on modern day debates. It's not like you wanted people to listen to me. Fucking, I taught you guys some of the stuff you know about fucking celestial navigation. That's not entirely true. I said that before, but I also corrected myself. I mean, you asked me a question once, I think, but you honestly learned it from scratch. It was actually really annoying because we were making our models at the same time, and I was using equations that exist already, and Bacon was learning. He was making up his own equations based on learning about it, like if he was inventing it.
Oh wow.
Yeah, I did everything using Euclidean because that's all I knew. Didn't learn the equations.
That's impressive.
I didn't use any spherical geometry. I did everything in Euclidean. That's
Wow.
probably why the way I do it's much more complicated than it has to be. But it works just the same.
Sure, you and Ruhif had a great. You guys went to an after party, and it's fun, man. I mean, I was busy yesterday anyway, so.
Did you want to be on the show, Kosho?
By busy means he was here getting destroyed by Jeremy on a train.
Hey, why don't you shut your mouth for you? Don't say stuff like that.
Speed of light is variable on Kosho. You're gonna take a ripping for this one, buddy. Maybe you should just come out tomorrow and say, like, change the word variable. Maybe.
It's what's difficult. Is we use words because we want to share, we want to share information with each other, right? And so sometimes we can use words in a way that, even though they're not exactly the correct way to use those words, we can get across the meaning to them. And sometimes people don't want to understand what you're saying. They try really hard not to understand what you're saying. And so when you do that, they're going to hold it against you. And so it becomes a very difficult task to share information when you're using the correct version of the phrasings, and then now they're accusing you of changing the way you're saying something. And it's just.
I don't think anybody uses variable.
Light speed changes. It changes if it's in a medium. This is just the truth. It's not a constant speed. That's just the truth, okay? The number is a constant. The speed is a constant.
Is the change? Is it okay? Maybe I'm wrong on that too. But my understanding is that
it changes.
My understanding is that.
Oh, go ahead.
Okay. My understanding is that a radio wave is just an oscillation in the electromagnetic field. Does that sound right? Oh, I might have bad connection.
No, you're seeing some shit.
Oh, I'm seeing a red signal here.
Oh.
It says I have 600 milliseconds delay.
Yeah, you sound great, Bacon, and you look good. Yeah, you look good last night. I saw you in the debate. You guys dressed up for it and everything, and
I was with a soccer shirt.
Well, whatever, man. Both your opponents were both wearing baseball hats, and that confused some people. So
you look like I cheated off of in college, and I wanted to thank you.
Oh, who look like what?
You look like the guy in physics and chemistry that I cheated off of in college, and I never thanked you, so I wanted to thank you.
Oh, you're welcome. Didn't you cheat in physics too?
Well, yeah, didn't everybody? I mean, I used to say the speed of light was constant, and I got it right on the test. If I would have wrote variable, you think I would have got it right, or I think I would have got it wrong?
I did cheat on calculus though. That's why I don't know calculus. Bad choice.
Let's go XRP.
It's pumping.
Well, it's up like 17%, over the course of a week. But yeah, I mean, it's got no choice but to pump. I mean,
What
the
happened with
bricks
the
is
lawsuit?
well, it hasn't been settled yet, but it's coming to a head here real soon. I mean, there's only so much longer this fucking thing can go on, and if you look at what what the something Torres, Jessica Torres, or whoever the judge is, if you look at her track record and stuff, she's kind of got like a rhythm she follows when she eventually does come to like some sort of like formal judgment. And yeah, so from the analyzation of that, it's perceived that she's going to be coming to a ruling soon.
Yeah, it's been going on for years. That lawsuit.
It's like 834 days or something like that, 35 days. So yeah, it's about time. But now the SEC's got their attention on other targets, like they're going after Coinbase, and I think they're going to be going after Ethereum, from what it sounds like, next. So as Ripple's going to be gaining.
Does that have to do with like staking? Because the SEC mad at they don't like that whole staking thing, perhaps.
Well, they're just trying to go after anything they can get their hands on, really, and yeah. So as Ripple's going to be gaining summary judgment, everything else is going to be, a target and dragged into court, which is going to create FUD. So yeah, basically, Ripple's like going to be the only one that's going to be given some formal regulatory clarity, and Coinbase is, probably going to be able to only offer XRP legally. So it's just funny how the tides have turned. Being the first crypto to get delisted, and now coming to be the only crypto to be relisted. It's just kind of another too big to fail bank failed. Not too sure which one it is, but yeah, and I think there's from what I heard, 186 others that are on the brink of failure. So it's not good.
Yeah, Credit Suisse got bought, right? And I think by UBS. And I think there was FUD with Deutsche Bank. Another one that might fall next. But that could just be rumors.
Well, I don't know, man. I know that the this liquidity crisis was predicted by one of the leading global experts, and like a couple years ago. And what he predicted was that, you know, these would be like the beginning telltale signs of like a major collapse. That
But you think the Fed and Treasury would just let
and he
him?
said that it was going to make 1920. I don't know, am I breaking up or something?
Yeah, you broke up for a little bit.
Am I any better or no?
Yeah. For now.
What was your question? Yeah. What was your question?
Well, I was gonna say I don't know if the Fed will let these banks, especially the big ones, to fall if it
Well,
reaches that. But
yeah, I mean, they definitely don't want that obviously to happen. But like, what other choices do they have? Like, I mean, what are they just going to keep bailing them out? I mean, I don't know. You know, what are the implications of that? You know,
yeah, what are the implications also of all the like a shit ton of people losing, billions or in like those big banks too, right? So
well, yeah, I mean, the traditional banking system it hasn't been revitalized for a long time, really. So,
it would
I
probably
mean,
cause
this,
a domino effect, honestly, if one of those big boys fail.
yeah, like SVB, uh, that was the sixth largest bank in the United States. So, yeah, that's definitely going to have a trickle effect.
Yeah, got a question for flat earthers. How accurate do you guys think stellarium is? Think it matches reality?
Uh, I don't know, man.
In which way does it match? Which way does it match reality?
No, I'm asking if you think there are discrepancies between what stellarium tells you should see and what you actually see. Or I think it's a pretty accurate description of positions of celestial bodies in the sky.
I've never played with it. Is it possible to go into space and into stellarium, like off the Earth?
No.
So all of the visuals that you get from stellarium is Earth based, is it?
I mean, you can change your elevation, I think, but I'm not sure how high you can go. It's not. It's meant for you to get observation from the surface.
Okay, so it's all observation from the Earth.
Yeah, I think so. Yeah.
I was going to say if it's anything other than observation from the Earth, then it wouldn't be accurate.
I'm doing some stuff here. It kind of relies on stellarium being accurate. So, I'd like to know your guys' opinion on it.
Well, try doing a what do they call that thing? Oculus or whatever. See if you can link those two together. That'd be kind of neat, maybe.
Do what?
Link together Oculus with Galarium.
Oh, you mean like the headset, like the virtual VR
I
Oculus?
didn't
Yeah.
catch that.
He's saying link like a VR headset with a Stellarium. So you could like look around, I guess, 360 or some shit in Stellarium.
There
yeah.
probably is already something like that.
Mm-hmm. If I had to guess, yeah, it probably exists.
Because I always heard like that well, some flat earthers say that the problem with doing navigation on flat earth is that we don't have the right map, right? And it would be extremely complicated to get the right map. I actually don't think so. I think it should be quite easy. Because we already have coordinates for points on the surface. Whether or not we can trust that those coordinates are spherical, it's something like separate. At least we already can identify points on the surface with two numbers that is unique to each point. So we already have that. I mean, there are no two people that live in different locations that have the same coordinate. Each person has a unique coordinate, and any pair of coordinates lead to exactly one place. So there's that. And second of all, based on the coordinates, you can get the elevation and azimuth of any celestial body. There are equations for that, and that's the ones Stellarium use. So if Stellarium works, then we have an equation that you can apply to those coordinates that would tell you where the celestial bodies would look like, exactly in what direction. So I mean, you have everything. You just have to, say how light works for you and where the position or where those latitude and longitude have to be to match those observations. Shouldn't be difficult. What I'm doing here is creating an algorithm to find that out. Try to find the true shape of the Earth, giving a light behavior. You tell me how light works, you figure out what best matches that, given the observations that you would get from Stellarium, for example.
Well, I mean, that's the thing. I mean, this is not me being rude, but I don't think they know how light works. Because the whole argument, I think, is that we don't, know a lot of things. So I guess you would kind of have to.
I got someone saying that light doesn't physically bend. Just look like it bends, but it doesn't physically bend. So if it doesn't bend, it's quite easy to determine where things would look, where you have to be for things to look like the way they look like.
Can you bend something that's non-physical to begin with?
Oh, it's the path of light bends.
Well, right.
Like if I take a turn with my car,
then it's only apparently bending, not physically bending. If you say it's just the path.
No, it's not whether or not it's apparent. Like if I take a turn with my car, I'm bending the path of my car. It's not something apparent. It's just the path of the car is bent, not the car itself. The car itself, it's not bent, but it took a turn, so the path isn't straight anymore. That's what we call bent, not straight.
That's fair.
No
right?
word games. Yeah.
It's not like throwing a ball.
Yeah.
You throw a ball, you're throwing a ball in a straight line, but it takes an arc path, but it's not like you threw it in an arc.
Yeah.
By the way, Bacon, I don't know if what you were saying earlier is related to this, but have you presented that 6-point thing yet? The 6 points.
Oh, not really. Yeah, you still have to find them. The problem with finding that is that stars are not like very well spread. The bright ones kind of randomly spread, so you don't have them exactly where you need to make those points, unless you allow for more stars than only the ones you get from the almanac. Yeah, I did that. Like you have to, for example, like it's not gonna be perfect. They're not gonna get exactly down to an arc second, the same angle everywhere. But you can stipulate a margin that would be acceptable. The bigger your margin, the easier it is to find those 6 points.
All right.
Also, the more stars you have available, the easiest that is too. Does that make sense?
But what's 6 points?
Oh yeah, makes sense. I didn't explain that. So you know the 4 points, 4-point things.
Jeremy's
get
4
the
corners.
diagonals. Yeah. That only works if you assume 6 nautical miles per degree. That's what's not possible. On flat Earth, if you assume the 6 nautical miles per degree, that 4 points debunk that. But then there's the claim that it's not 6 nautical miles per degree. The function is actually a different one. That could account for those diagonals. There's actually a debunk for that too. There's a way to debunk that.
Wait, why is that even being claimed?
I have no idea, but
I'll take Brian.
Oh, I know. I know why. I think it's because they're not worried about great circles. They're worried about like latitudes, something like that. Just go ahead.
No, I think it's because they understand that the 6 nautical miles per degree can't work on flat Earth.
Fair enough.
So you need a different function. That's what Brian uses. Remember, he has like a function for refraction.
Yeah, I remember his function.
Right. All right. So that's debunkable too. You can debunk that idea too. But you need 6 points for that. You can debunk. You can refute any equation for distance versus angle. Any possible equation for distance versus angle with 6 points. Doesn't matter which function it is. It can be debunked with 6 points.
Go on. Are you talking about some sort of tetrahedron? Or or not more like a... No, it'd be like a,
yeah.
Like a... Okay, so you have 1 point in the center.
Tetrahedron?
You have 5 points around.
Yeah.
If you do that on a flat surface, the sides are going to be bigger than the radius. It doesn't matter how much you scale, the ratio between the sides and the radius is the same. So there's a constant ratio between those two.
Right.
However, on a sphere, as you make the radius bigger, the circumference doesn't grow as fast as the radius. So you get... So if you make the radius big enough, you reach a point in which the sides are the same as the radius.
Yeah.
So if you
it's
get
like
those
a
6
pentagram.
points, exactly. Yes. So if you get those 6 points, every time you're observing 1 point from the other one that is adjacent, they're always going to get the same angle to each other. If there's any relationship between angle and distance, that would mean all those distances are the same. That can't be true on a plane. That can only be true if the middle point is not on the same plane as the other 5.
Right. All right, fair enough.
Yeah.
Look at you,
There were an
dude.
algorithm to
Look
find
at
those
you.
points. What do you mean?
You know, my favorite fucking shape is a pentagram, dude. So, congratulations using that, dude. You can have that too.
Thank you. It's not that easy to find. Like the 4 points are very, very easy to find. But those 6 points are much more complicated.
I can find them. Pretty easy, actually. But, you know,
Oh,
you wouldn't know that, so. Ask Ruhif, man. He probably knows it.
Well, if you find it, I'll be grateful. It would save me a lot
Yeah,
of work.
but I imagine, dude. I'd be grateful if we were the other way around, right? Listen, I'm sorry.
Oh, you
Man.
said it's easy.
I'm sorry.
I don't think it's easy. So it's fair. That
Well, it's not that easy. I was gonna end up working hard just to do it, just to spite you, and it's like I don't want to do this work just to spite you. I'm sorry, dude.
Yeah, that's a
What a
horrible way
nice
to do
fella.
things.
That's a good friend right there.
Yep.
Talking about that, I remember someone said that it would make me a sextant model on Blender. I don't remember who it was. Though.
It was me. I'm
It
still.
was a guy called Brandon.
Yeah. There you go.
Yeah, I was being ironic.
Yeah, I mean, I still got to do. I'm still gonna do it. It's just, I don't know. I've been busy, stuff. But
Don't do it. I'm probably not even gonna put there.
can I still do the arm at least? Because that's like pretty easy.
I mean, you can do it if you want to. I won't guarantee I'm gonna use it because my hype on that project is very much lower now. So it takes me weeks to add something new.
Yeah, it would
Oh,
be
by
like
the way,
that.
Kosho, I did apply your suggestion of making the brighter stars even more bright.
That's shocking, man. Really shocking.
It looked better. You're right. Yeah.
Well, I mean, that's what I'm.
It looked much better.
I'm always going to give you suggestions that are good. So that's surprising that you would forget about me when you're going to debate it. You know, but whatever.
Yeah, let me ask you, Bacon. You're pretty reasonable. Bacon. If I'm traveling in something, right? Doesn't matter what it is, really. A bicycle, a car.
Oh boy.
Whatever.
Tell them what it
pick
is,
something.
man.
I could be walking, whatever.
Motorcycle,
A unicycle, whatever you want.
Use the goddamn train, dude.
If I'm traveling in something, right? And I throw a stake down in the ground when I start, and then I throw a stake in the ground when I stop. Do I experience moving that distance that's in between those stakes?
If you experience moving,
do I experience? Have I now experienced? Or you on your unicycle? Have you experienced traveling that distance in between those two stakes?
I don't see why not.
I wouldn't see why not either. You'd have to be some kind of sick maniac to doubt that you would experience traveling in between those stakes.
I'll guess that's kosher.
Listen to me, Bacon. Just says a sick maniac doesn't mean you have to assume it's me. God damn it, I was just fucking forgiving you and shit. No, listen, dude. He's a liar, Bacon. The guy that he's talking about isn't on a bike. He's on a train. He's on a unicycle.
Yeah.
He's on a fucking train. And this guy on this fucking train.
Did you drop the push to talk button?
It doesn't really matter what you're on, Bacon. You could be on rollerblades from the 90s, a unicycle, a car, whatever you're in moving, right? Whatever you're in, you've experienced moving the distance in between those stakes.
Mm-hmm.
Yeah, so Jeremy has this whole little thing, hypothetical, where like, okay, we have a train moving 1,000 miles an hour, right? But it's a really long and big train, right? And within this train that's traveling 1,000 miles an hour, there's a slightly smaller train in it that's also traveling 1,000 miles an hour relative to the bigger train. All right? Obviously, the slightly smaller train that's inside the bigger train would be traveling a total speed of 2,000 miles an hour, right? Because it's traveling its 1,000 miles an hour plus the 1,000 miles an hour that the bigger train is traveling, right? Because it's inside that.
Not according to relativity, but let's not go to relativity if it's not necessary.
So it'd be traveling
Unless this is
2,000.
about relativity.
Well, it kind of is, but it's traveling. Okay, you will admit though, it's traveling 2,000 miles an hour relative to the ground, though, right?
I think not according to relativity.
But it's really close though in relativity, right?
In
Wouldn't
Newtonian mechanics,
Use the reality frame.
just
You
add
got
up.
to use.
Well, hold on. Hold on.
Ask Kosho about the reality frame.
Well, hold on, Jeremy. Hold on. So Bacon. So in relativity, though, it would be close, though, right? Close to 2,000, like really, really close, but like
Yeah,
never
it will
exactly.
be a bit less, but it will be close to 2,000. Yeah.
See, I fucking knew it. See, Jeremy, I think I said this earlier too. I think I said like
Fair enough.
it'd be like a slight.
What do you mean? See?
It'd be slightly off. Like it would never truly. But like I was like, okay, yeah. Anyway,
I think
okay.
you know how to calculate that.
But yeah, but basically the
Doesn't
hypothetical.
matter.
It's not that. It's actually quite easy.
Yeah, but hold on.
It
Bacon,
doesn't matter. Bacon already agreed that we would experience on the unicycle or whatever we're moving in, traveling the distance between the stakes.
Okay, but hold on,
Yeah,
Bacon, real fast
because-
before you calculate that, and before Coach comes in too, right? Basically the little thought experiment pretty much has it where you keep throwing in more tinier trains going their 1,000 miles an hour, and you keep adding the 1,000 miles an hour until you get to the speed of light and surpassing it. All right.
Yeah, but-
obviously that doesn't happen, but that's what Jeremy thinks is going to happen.
That's train scenario number 4, but he's already on train scenario number 5. It's a different
How many
scenario.
fucking scenarios are there? Why is it like a bajillion?
He's got 4 now, at least. Okay, and
Yeah,
on train scenario number 4.
I bottled up
it's with
all
stakes.
these trains. Okay, listen, I've tried to stay away from trains this whole time throughout my whole flat Earth career, and now I'm embracing it. I figured out how to destroy them with trains, so now we're all up on trains. I got trains inside trains inside trains.
You ain't destroying shit.
Yeah, in relativity, your speed changes your experience of time.
Jeremy expressed it in a
So it's
dishonest way, dude. The guy in the bike. Sorry.
Oh, go ahead. I think I have a delay.
My bad, Bacon. But Jeremy
I
said
bet
that
you
the guy, he's on a.
Oh, Joe, this is your second
hold
warning
on,
today.
dude.
No interrupting, please.
I wasn't interrupting, dude. What? But no, the guy's not on a motorcycle. He's on a train, okay? And he throws the stakes down, okay? He throws the stakes down on the ground outside the train, okay? He keeps the watch on the train with him, but he is using the coordinate system of the ground outside the train to describe when he says, "Oh, is he moving? He put sticks down in the bicycle. Is he? Did he move the distance? He says he moved in the bicycle with the stakes."
Don't you guys have
well-
very similar voices? How come why are you doing an impression? I mean,
Yeah,
Because he sounds
you
like
just
a
have to talk
lowlife right
normal.
now.
All you have
He sounds
to
like
do
a
is talk in your normal voice, and we have the same voice. So.
He sounds like a lowlife right now, dude. Doesn't matter. And
I prefer if you do a different voice, so I know it's not you.
yeah, there you
fair
go.
enough.
Perfect.
Okay, yeah.
Anyways, the point is that he's described. He asked you, did he really move that distance or whatever? Because you know as well as I do, Bacon, as well as Arma, and almost as well as Damon, that
Hi, Becca.
Wait,
What's up, Damon?
you actually included me?
But we all know that
Thank
the
you.
reference frame being implied in the statement Jeremy made was the reference frame of the ground outside of the bicycle or the train or whatever, not the reference frame of the train or the bicycle. So, so he's not describing
whatever we're moving in, right? If we throw stakes down, we've experienced moving. Does it matter if it's a unicycle or rollerblades or a train or a plane? If we throw stakes down on the ground, we have experienced moving the distance between the stakes, right?
Wow.
Yeah,
You're right,
that's
Bacon.
pretty much how anyone would describe their experience if they did that.
Can I just say that the steaks that I cooked tonight were delicious? Very well cooked.
Good for you. I hope you enjoyed them. Yep.
Sorry. I was really proud because it was the first grill of the season. I got my grill out and everything, got, re-seasoned the grate a little bit and got it nice and warm. And seasoned my steaks, had them setting out just the right amount, tenderized them a little bit.
Yeah,
Fucking shit was
wow.
good.
Is it you
What
and
is
We're
he
all
your
having
fast?
family?
barbecues. We're all having barbecues. You made some steaks. Kosho's getting barbecued right here live.
Right. Can't you smell the skin burning?
I
Are you
seriously
making for
doubt
your
that.
family?
Hey, just Jeremy, just because you don't understand something doesn't mean that Kosho's losing.
That's true too.
Oh, I don't
Thanks, David.
understand. Yeah, I understand that if I start moving and throw a stake down, then I stop moving and throw a stake down. I've experienced moving in between those stakes. That's what I understand.
That's
Because
right.
I,
That's right. In
Damon,
that
did you
reference
Yeah.
cook?
frame.
Damon, did you cook for your friends, family, or yourself?
Family.
Yes.
Family, cool. All right, good for you. That's all. Thank you.
Interesting. That was okay. That happened. All right. Yeah. Anyway, so the stakes, right? So you drop the stakes and whatnot.
Steaks.
So Kosho's argument was we can't use the people that's moving on the train thing
Wait,
because the stakes are a different are now in a different reference frame.
Stakes
No,
are high.
no. We're talking.
Are they
There's don't
all
type
the
people. He's using clocks. There's clocks and there's positions on the ground.
One clock.
And he's
one
using
clock.
the clock on the train,
Guy on a
and
train.
the
Guy on a
positions on the
train's got a
ground
clock.
outside the train.
Yep, the guy on the train has a clock.
is the
and
clock
we're
in the
going to see
reference
how much
frame that you're
distance.
measuring the thing from?
The
No.
guy on the train has a clock, but we're going to see the distance he traveled by using two stakes in the ground.
Oh. Well, if the
What do
clock
you
is
mean?
outside of that reference frame that you're putting the stakes in, like on the train or wherever you're at, then yeah, you're gonna have some sort of difference because relativity.
Okay, but the people on the train are going to have a time, and they're going to have a distance with those two stakes that they definitely experience traveling through, right?
Yeah, in the train, yes, absolutely.
Yes, in the train. Okay, see, you're done, Kosho, because if you measure the speed of light in the train, and you were to throw the stakes on the floor of the train, you'd find that
In the train, measure from the train. You do the thing from the train. Everything's kosher.
Yeah, and
Everything is kosher.
If you compare that with somebody standing outside the train, not kosher.
He wants to compare it. He wants to compare it to the coordinate system outside the train.
Man.
He wants to throw the stakes down and describe the distance in the coordinate system outside the train.
Stop. If we were to throw the stakes down inside the train, the floor of the train, the moving train, 1,000 miles an hour train, you'd get the speed of light. It's traveling through a vacuum from the back of the train to the front of the train. You'd get the speed of light using the clock on the train. Okay? So, but the people on the train, they have experience moving the distance through those stakes. And if you throw the stakes down when the photon starts and when the photon stops, they've experienced the photon. They've seen the photon travel that whole distance in between those two stakes. You now have a longer distance than if you were to use the floor of the train. The stakes on the ground outside are going to be a larger distance than the stakes that are on the floor of the train.
What?
Can you say that again?
That's so contrived. I don't even know what you're saying.
No. Can you say that again, Drew?
You're going to shoot a photon in a vacuum through the back of the train to the front of the train. If you were to throw the stakes on the floor from where the photon started, as soon as the photon starts going, you shoot it. As soon as the photons start moving, you shoot a stake on the floor of the train and on the ground outside the train. So it's permanently in the non-moving ground, and there's one on the floor of the train.
Oh,
then when the photon stops, dude, you're never going to understand if you don't shut up and listen.
Damn.
I'm just saying, I finally got it. Like, keep going, God.
Oh, all right.
Yeah,
You're just mumbling the whole way through me. I'm sorry, my bad. Then you shoot another set of stakes, one on the floor of the train and one on the ground outside the train when the photon stops. If you use the time of the person inside the train, and you measure how fast it traveled the distance in between the stakes on the floor of the train, you're going to get the speed of light.
Well, I have to draw that. It's too complex of a scenario for me.
Yeah, I would have to have a visual. I can't seem to put that together in my head.
It's pretty easy though, dude. I already did all the numbers and everything. But what happens?
Yeah, but he's saying like shooting a stake down on the train. You realize the train's moving, so the stake's gonna move with the train, right?
It becomes easier when you try to do what I tried to do with him earlier that he denied doing. But we're we're now going to describe this using coordinate systems. We're going to make explicit coordinate systems where we're describing this movement, right?
Okay.
So the coordinate system of the ground outside this train, that's one coordinate system. The coordinate system attached to the train, that's another coordinate system. So when we describe light from the coordinate system of the train, it travels, let's say, 300 million meters over the course of 1 second. Okay, so we notice that from the train. Of course, that same distance on the coordinate system outside the train is much longer because that train is traveling. So that distance is greater. So what happens, they have two different experiences of that length of that second. So for them, a second is a little bit longer than the people who are on the train. So the stakes being thrown down are in the reference frame of the people who have a different experience of time. So for that reason, it's invalid to use a time from one reference frame and the spatial coordinate system from a different reference frame. That's an invalid way to do it. And you're going to come up with the paradox or whatever you call this, Jeremy. But it's not. It's just an invalid way of making the measurement. You take the time and you take the time from the same coordinate system that you're measuring the distance from.
Yeah, you always have to maintain the same reference frame when doing that sort of thing. Otherwise, yeah, you're gonna fuck it up. Just like
I've only
Kosher
told
was
it to
saying.
you 10 times today, or I mean probably 25.
Yeah. Actually, probably is 25.
Probably more.
Okay, no, I think that's going a little crazy. I think 25 is a good number. I think any more is kind of a little crazy.
I hate trains.
You what?
I like trains.
Oh, he hates trains. I thought he said I ate trains.
I ate them.
He
Like,
ate
yeah.
8 trains.
Yeah. Like exactly.
Okay, so there's another one. Like, if we were to do this experiment, but only on a track that goes down your throat, so that you're like eating them, then what we have? We have like 3 reference frames.
Damn.
Hey, real quick, how much of that did you guys hear?
About what?
I gave you the explanation a second ago.
Oh, I don't think. What? I don't know.
What?
I don't think.
I heard all of it. Sorry, I don't think they did though. They just popped in.
I blanked out. I was just here to talk shit. That's it.
Yeah.
My internet fucked up, so I just was making. I don't know what you guys heard. I hope we're all.
I think they heard it all. Yeah, I think they came in late to the conversation while you were describing it.
No, I've heard 20 of the 25 explanations.
Yeah, that are all the same. Yeah, he's been doing this since yesterday, at least, because I was in here yesterday. He had the same thing.
This is day 4. You need to keep up. This is the 4th day.
But this is
Jeremy,
also scenario. This is
like
scenario
at a certain
4.
point. Shouldn't you think that the problem's you? Like, if you keep going on a date and you keep getting rejected for the same reason, like, eventually you have to stop blaming your dates and start looking in the mirror.
No, I'm keep rejecting Kosho's nonsensical rebuttals to this very real distance that we have. That the people have experienced.
He hasn't
traveling.
quite reached the it's my fault sort of part of the dating scene yet.
Dude, they've tried everything. They've tried the Lorentz contraction, time dilation, reference frames, literally everything you could think of.
It's hard to convince somebody of something when they refuse to sort of like accept anything. You know what I mean? Like, you're just gonna hold on to the idea no matter what. I mean, what's the point? You're just wasting everybody's time, Jeremy.
Yeah, Jeremy.
Everyone agrees with me, though.
No.
Everyone agrees with me.
I don't.
People on the train.
Kosher
the people on the
doesn't.
train. The people on the train experience traveling through those stakes that are on the ground.
Yeah, wow. That's a fucking dumb thing to say.
Jeremy. There's a time thing, man. You don't realize it's a time thing. There's no absolute, like, reference of time thing, right?
In
That
This is
relativity.
the 112th
Relativity.
excuse reference time frame thing.
Wait, in relativity. Wait, hold on. Does that mean? How does that work though? So outside of
We all
relativity,
agree with Jeremy, man. Everybody but y'all two. We all agree with Jeremy.
Oh yeah.
In
Well,
quantum mechanics, time is
I mean,
universal.
Oh.
I mean, there are a lot of stupid
Forces
people
are
on the
instant.
earth.
Hey, can I have a word with Brian here?
Brian.
Oh
Didn't
yeah,
you have a
Brian.
debate with
Brian.
him just recently, Bacon?
That's why he wants a word with him.
Yeah, but yesterday he
yes.
was very excited to tell me something.
You guys are best
But now
friends
You
it's
now.
guys got kind of
the
thrashed in
opportunity.
that debate, by the way. I'm sorry. Sorry. You should do
Be
better.
nice, Brian.
Yeah, I got something I got an idea, man, to run by you because I'm sitting here and when I told you like trying to apply my equation to the AE map couldn't possibly work because that makes everything 69 miles per degree. So I got to thinking, okay, so after we get the GP to the I started to do it the sun because I could do that easier with that. But I was like, well, it'll take me a day, take you probably 5 fucking minutes. But I was wanting to run this by you. I thought of a couple ideas. One that I don't really want you to try because I'm still thinking about it is getting like the angles to Polaris and the star. But just going off the information we got, like say we take and we make the circle say wherever the GP winds up being, we take and based on the equator being 60 nautical miles per degree, then we just whatever latitude we just use the sign of the latitude where the GP is. Say so and make the size of the circle different. So if it's beyond the equator, in fact, I wanted to test this on the south, on the other side of the equator on an AE map. And so if it's like say 20 latitude south, then instead of making the circle the 60 nautical miles, we figure it out. So it would be let's see, we'd just divide.
Yo.
We'd have, hold on. We divide the 60 nautical miles, and then we just use pi. Just basically use pi to get this new size of the circle. We do it by latitude, right?
Let's make sure I'm following. Let me just make sure I'm following. So you're talking about making the relationship vary based on the GP of the star? If the star is further south, the relationship would change?
Yeah, so we stretch the circle based on the circumference at that latitude, right? You see what I'm saying? So in other words, if we're at 45 south, then we've got to we could just use pi to get the new size of the circle. In other words, all the circles ain't gonna be the same size. They're gonna be GP dependent. So they're gonna be location dependent. So the further south you go, the bigger the circle is gonna get. But they're all three gonna be different. You feel me?
Dude, there's a different.
Oh, I get it.
I solved this problem already, dude, because I was trying to do the same thing. It's a different equation. You need ellipses.
Oh shit!
And I have to have.
That's what I thought.
Yeah, you need ellipses.
I don't think that's going to work, but I can try that.
You don't. Of course you don't.
Yeah. So you don't mind trying that?
Yeah, they're not.
I
By the
don't
way,
mind trying.
they're not perfect ellipses. You need like a
That's
two.
okay. If I see what
you need like two, like a weird two. The way I did it is I had these ellipses in both
so
directions.
what you're saying, Kosho, is that you need to get the azimuthal projection of the circles of equal altitude on the sphere.
Yes, exactly.
Okay, so that's,
Wow.
then you're no longer using the map, right?
Right. Anyway, even if it is,
Yeah,
if it's
that's
off,
all
I
advice.
want to see. If it's off, you know, if you could do it and it doesn't work, if you could try it one more time, and let me look at both of them and see. But I think it'll work.
Using spheres will
Right.
never work.
There's got it. Listen, there's a way to do it, dude. And I got a couple other ideas. There's got to be a
the
way.
way I described it with the way I described it with the two-headed ellipse. That's what I call it. Yeah, that works.
Yeah, here's the thing. You get the circle of equal altitude on the sphere. You project the azimuthal projection of it on the map. You draw the circle you want to. The only places where it's going to work is where those two shapes intersect. Both the projection and the circle that you're trying to use. Where they intersect, that's where it's going to work. where they are far apart from each other, that's where it's going to fail.
Well, that's just it, Kosho. That's just it, Bacon. So, if we're adjusting for latitudes, we're gonna have bigger circles. So I just wanted to see the intersection. But anyway, even if it doesn't work, that gives me a starting point. Because look, we have to use you'd agree that we have to do something. We have to use the AE map. We can't just use 60 nautical miles per degree to make the circles of equal altitude. That couldn't possibly work. That's why
I made
I was
a,
just
I made a
seeing
very
what it
clear
would do.
presentation.
When you did that day, when we did that, when you were trying my formula on an AE map, I mean, I knew it wasn't going to work, but I wanted to see what it gave me so I could go from there. And it couldn't possibly work though, because that's 60 miles per degree. So anyway, and even if this doesn't work, this gives me a starting point on what equation to use. You know, that's why I was going to see if you apply it to two different things. And please don't try to not make it work. You know what I'm saying? Like, don't use some crazy spots. Just use your normal ass spots.
Yeah, I think I'm going to create some randomly generated
Fair enough.
positions,
Bacon,
stars in it,
Bacon,
so
can I
you
give
can,
you-
you can get a new one every time you want.
So here it is. So if you're let's say you're at the very edge, then and you're right underneath it, that circle is going to cover the whole entire AE map. Okay, because you're going to adjust the latitude. So if you're right on the edge and you're looking straight up, then then you adjust your circle to the latitude. Then your circle of equal altitude is going to cover the whole AE map.
Oh, I missed that. Sorry, say that again.
No, wait a minute. We can't go past 63. So that's another issue I might need to address. But just go with your regular spots, bro, for now.
Right. Okay, so
Bacon, I can give you a huge.
if I'm citing Polaris, then
No,
the
not
function
Polaris.
has to pretty much be. No,
I want to do it. I want to do it in the south, though.
Just think about it. Let's try to find a single function that works for the whole Earth.
Okay.
So if you start with Polaris and you use the 6 nautical miles per degree, that's going to work on the AE map. That works for Polaris on the AE map, because each 6 miles is going to get go 1 degree further south in the latitude. So that works for Polaris.
I'm talking about the altitudes that are measured.
Yeah, I get you. I get you. What I'm saying, you can use on the AE map the linear relationship for Polaris. That's the only one that works. Now, as you pick a southern, like a less northern star, let's say you get one from the Big Dipper, you have to adjust the function a little bit. The circles are gonna get a little bit bigger, right? So the further you go away from the North Pole, the bigger you adjust your circle. Is that it?
Right. So instead of resetting to 0 when you get to 10, just keep going. So in other words, so if it's 60 miles per degree, so say 60 times 60 times whatever the degree is, then divide it by the latitude, right? So in other words, so 60 times just base everything off the equator, basically. So if we're at the equator, obviously it's going to remain 60 miles, okay? But if we're say at if we're at latitude 60, then we want to adjust the circle of equal altitude. You know what I'm saying? We got to adjust it.
Mm-hmm. I get it.
Because
it will work.
Not as big.
It will work. Right. It will work better east and west. If you're east or west of the GP, it's going to work better. But if you're north and south, if it will start to make it bigger than 6 nautical miles per degree, you're going to get inside of the circle. The circle is going to grow away, outside of you.
That's okay. We just use the part. That's fine. I figured you'd come up with that when I told you that if you put it on the edge, you'd close the whole map. But basically, we'll just use the part that's on the map. You know what I'm saying? Because they only go down to 63 anyway. So that was just I don't even know why I said that. But hold on. Give me 1 second.
Mm-hmm. All right. Yeah, I can do that, but it's not gonna be quick. It's not gonna take me. Right. For one thing, I'm working with something else now.
Oh yeah, I bet
And
you are, huh?
yeah, another reason is that I'm at my girlfriend's house, so I'm not gonna be as much time here and doing this kind of stuff as I usually do for the next 2 months.
Look at the big man on campus, dude. Look at the big dude. You know what? I'm out of here, dude. Have fun, Bacon. You got your new project. You got your girlfriend. You got Ruhif. You got Brian Bleaky. Take it all, dude. Take the pentagram, too. It's my favorite shape. Take that. Solve Jeremy's train problems while you're at it.
Oh, that's really
What the hell?
sweet.
You're gonna start crying now or something? What's going on?
I'm allowed to cry if I want to, dude.
Look,
Have
you
you
gotta
seen
make
the
way for the
debate?
young blood. Bacon is the young blood now, Kosho. You gotta realize
Yeah,
that.
there will be blood, all right.
Oh no.
I was
Have you seen the debate, Essie? My debate with Nathan Thompson.
I seen it. Oh wait, I was in it. At the beginning,
I w-
dude, I thought I was gonna have to say something to him, bro. Like he was just like we were all just listening to Nathan, dude. He was but
I was
it got better.
I was a bit bitter.
Oh,
so I
you're
never
much
watched
better
it.
than
Nathan.
you're
Yeah,
much
Nathan.
better than Thompson.
Nathan started out talking about his fucking YouTube channel. Like,
Yeah.
dude, there's not a debate about your YouTube channel, man.
Wait, real fast, Brian. You're like exactly how I thought you would look, like, except for the fact that I thought you had like facial hair. Like I thought you would have like a beard or something, but like you look exactly how I thought you would. So that's just fucking crazy. Like you sound how
I
you
heard
look.
that from Left Lane. That I looked how he thought it was.
Yeah, it's crazy.
Yeah, Bacon. Yeah, Bacon was because Bacon don't ever go on camera in it, but he put himself on camera when me and him was talking, and I was like, bro, don't even worry about that. You look exactly how you sound, bro. You know what I'm saying? You look good, man. You should go on camera more often, bud.
All right.
You guys all fucking suck.
All right.
You guys
But
suck.
here's the thing. So we just take in so if we're trying to figure out the circumference, you could use. I mean, there's a couple ways you could do it. Just figure out the circumference of the Earth and divide it by the latitude or the sine of latitude, or just do this. Just use pi. Just do like if we're at 30 latitude, then just do 30 times 540. I mean times pi, or times 50. I mean times 60. Duh. 30 times 60 times 2 times pi. Whatever. Maybe
I'll see. I'll the same as I did before. I'm gonna just put a box where you can play with the equation, and or I can play with the equation. Like if you want me to change something, I can just change in
Yeah.
that box and it would update.
I like the way he does
just
it.
like
And Bacon takes it one step further, guys. Instead of doing the equation like I'm sitting here spitting an idea at him, instead of doing that, he does it where he takes it one step beyond. He makes it where he'll enter where it does the equation, and you could just put down different shit. So he's like one step even beyond the shit that we're
Jesus
talking
Christ.
to him about. He finds a way to input it to where it solves it for every location. He'll take that equation and apply it to all. So it's convenient.
Jesus.
Kosher, you
don't
can
make
probably do that
Ghost
too,
that
right?
bad.
Yeah, dude.
Can you do that, Kosher?
Yeah, dude. Just shut the hell up, Brian.
Just show him how to do it, Bacon. That's all.
Right.
Obviously, Kosho doesn't know how
I'll
to
do
do
that.
it.
Just don't expect me to do that so soon, but I'll do that. Just like I said, I would do the other one, and I did. I'll do this one too. It's not a problem.
Or just get the percentage, use the percentage of the latitude that you're at compared to the equator. So if it's north of the equator, it's going to be a little bit smaller of a circle. And if it's, I imagine there's multiple ways to do it, but you know what I'm saying, right, Bacon?
All of that, yeah, but all of that can be adjusted within that equation box. Just the thing you just described, you could just play inside of that equation box.
Dude, no
Um,
matter what, it's got to help. Okay, whether it needs additional work or whatever, it's got to help because because what are we lacking in the South? We're lacking those bigger circles. In the North, we're too big of circles, so that's going to adjust them.
They're not circles. I'm telling you.
Mhm.
Yeah, they're not circles. The equation's a little bit sophisticated.
Well, if I could see what it is, though, then I could see where to go with it, man. No idea is a bad idea, Kosho. No idea is a bad idea, pal.
well, there was a topic in yesterday's debate that I didn't get to address. The conversation kind of diverged. Maybe we could talk about it now, which was that Nathan brought a point that like if you're 6 months apart, you should see entirely different constellations. But
oh yeah, I
we
wanted
ended
to
up
butt in
seeing
there
most of
too.
the same.
I wanted to butt in there
Right.
too
You
because
mentioned
remember that guy sent a super chat and saying the sun. So it's got to me, it's got to be one or the other. And I understand the explanation, but it's got to be either the day and night flip flop, or with the sidereal day, then we're looking at a different part of the sky. So, I mean, I do agree with that. I understand y'all's explanation that north stays the same no matter how far we go around the solar system, but we do see Orion too long, and it's over the equator.
That's what I want to address. So when the sun, like, if the sun is not over Orion, it's a bit to the left or to the right, then you'll be able to see Orion just before the sunset or just after the sun rises, and that's the most extreme.
No. Yeah, that would give you about 7 to 8 months max, though, right?
No.
Well, 6. Okay, it would be. Listen, if
No.
your universe wasn't so big, it would give you 6, right?
No,
In other words,
the sun doesn't. This okay. So the sun is in the sky half of the day, and when it's in the sky, you don't see any stars. That might give you the impression you should see only the other half of the stars. It's actually not true. When you're in the when the sun just sets, you have a portion of the sky. As the Earth rotates, you get to see the other half while the Earth is spinning, just up to the point where it's rising again. So you almost see all of the stars. The only stars you don't see are the ones that are very next to the sun. So those 2 months where you don't see Orion is where the sun is at Orion. So
no. All right, now think with me real quick. Think with me. I see what you're saying. Okay, but think with me. So now, let's just say hypothetically, your universe is not so big. Okay, now we're in a room that represents your solar system, and the sun is in the middle of that room. Now we're facing away from the sun, representing midnight or whatever exactly, your latest time, that time of year. Okay, now
that's midnight.
6 months later, you are looking right at another wall. So now, if your solar system wasn't so big, so in other words, in your world, no matter where I go around the sun, Polaris stays right above my head, which is still a problem because a star, a constellation right at the equator, like you can buy 23 degrees worth of tilt and a little bit worth of refraction. That's it. That's all you're allowed. So I'm keeping Polaris directly over my head. I'm accounting for the tilt, which buys you, a little more, and then I even give you a little bit for refraction, and that's about 8 months, bro. That's all you're gonna get.
Well, why 8 months? I don't get it. Like Polaris? You're talking about Polaris?
No. To see Orion. That's an equatorial constellation.
I don't get why 8 months. Like,
because, man, 6 months.
The star is at the celestial equator. So if you're at the poles, it's right to the horizon. If you're anywhere else, it's above the horizon. So it's always somewhere in the sky. You only don't see it when the sun is out. So if the sun is in the same sidereal or angle of the star, you'll be together with the star, and you won't see that star because the sun is in front of it. the star is only out when the sun is only also out, so you can't see it. As the sun drifts away from the stars, you're gonna see the star either before the sunrise or after the sunset.
Yeah,
Why
but if
would
it's
that
in the
last for
direction
more
of
than
the
2
sun,
months?
wait. If it's in the direction of the sun, think about that. If it's in the direction of the sun, then you're not going to see it because that's daytime. So picture this. So you would
But
agree
that's
from
only for
horizon
one.
from horizon to horizon is 180 degrees, right? It's 180 degrees of our sky.
Mm-hmm. Yeah, but
Okay, now
it's only in the same direction of the sun for a short period. It doesn't stay in the direction of the sun for 4 months.
right, it's exactly opposite. So, but if you take Orion, that's lined up with the sun. It's perfectly within the freaking the tropics,
Ecliptic?
perfectly, in the ecliptic. Perfect.
Right.
The sun will travel the entire ecliptic over the course of a year.
Right, and Orion pretty much covers that, so that's why we picked that, because it's pretty well lines up, decent, as good as any. Okay, so now if
But
I'm looking the
Orion-
opposite, what? Go ahead, Kosher.
They're saying Orion stays in the same spot over the course of a year, and the sun makes a full path over the course of a year. Then it's not going to be impeding it for most of the year, right?
Right, and you could say at 6 months of it, it'll be daylight where I see Orion. It'll be daytime at the equator. It'll be daytime.
No, not
So-
for 6 months. More than 6 months. Well, why just
That's
6
why I
months?
said 8. That's why I said 8. I'm giving you the tilt and refraction. I give you 8 months. bro.
You don't need a refraction for 8 to get to 8 months. That's the whole. Let's say there's no refraction. Let's make it easier. No refraction, no tilt. If the Orion is 90 degrees from the sun, so when the sun is high up in the sky, Orion is rising. When the sun is setting, Orion is high in the sky. Now Orion's gonna set, and we're still gonna have I don't know, 6 hours of night before the sunrise. That's when the Orion is rising after the sun, right? If you wait for 6 months, Orion will be 180 degrees from that in the other side. We're still gonna see it during the night, but it's now just going to be. I'm not very. I don't think I'm explaining this clearly, right?
No, that is correct.
No, you don't.
Oh, no, that was
Not
that was
really.
correct.
Just think about this. The sun,
No,
the sun
I think I'm
represents
not being fair.
180 degrees, right? The daylight represents 180 degrees, bro. So if the daylight represents 180 degrees of your sky, then how in the F can Orion account for more than 180? Like I said, I give you a little bit for tilt, and I give you some for refraction, but beyond that, bro,
You just said
you're
it.
looking toward the sun. You're looking toward the sun.
No.
Otherwise,
Yeah, no. Let's say. Okay, so let's say the sun is right at Orion, right on front of Orion. So of course we can't see it, right? 1 month later than that, the sun will have traveled. Let me see, 360.
let's say the sun at noon. Let's say the sun at
30
noon.
degrees.
Let's start with this, Bacon. I'm following you, but start with the sun at noon. So Orion lines up with the sun at noon. Okay.
Sure.
Now
sure.
go from
I know.
there.
All right. Right.
Midday.
So, okay, 30 days. So 1 month later. 1 month later, or the sun will have moved by 30 degrees, right?
Right. It'll move from
compared
12
to Orion.
o'clock. Move from 12 o'clock on the clock to 1 o'clock. So now it's no longer lined up with the sun. It's instead of 12 o'clock of the clock, it's 1 o'clock. And then the next month it's going to be 2 o'clock.
Right. Yeah. So a second. So now if you go back to like the sun is rising with Orion, right? 1 month later.
Wait. That would be 6 o'clock, bro. If it's rising with the sun, you just jump 5 more months, bro.
No.
What are you talking? Slow down.
Wait. No. If Orion's with the sun at noon, it's also with the sun at sunset, and it's also with the sun at sunrise. The sun and the celestial sphere moves together.
We're not talking about the rotation, dude. We're talking about the fucking the orbit, dude.
So he's talking about a
I'm
single
aware.
day. A single
You-
day is a
yeah,
rotation.
yeah, we're in the first day yet.
Okay.
You said that Orion was aligned with the sun at noon. Well, if you go to the next morning or to the previous morning, it would still going to be aligned with Orion.
What are
It
you
would only have
doing
drift.
now? That's not the argument, Bacon. Maybe you don't understand it. The argument is the
I know,
orbit.
but yeah, but I'm not. I don't
If
I
the
don't
sun,
understand why you're saying that.
let's say this, because I'm trying to use the clock, and a full rotation would cover all 12 hours. Okay, so if we're going to use a clock, then if the sun is with Orion, if it's with Orion, then yes, it stays with Orion. Basically, it's as we move around the sun, it changes. So as we move 1 month, then it's going to be 1 o'clock, and then we move another month, it's going to be 2 o'clock.
Right.
So it's going to be
But you
away from
understand?
so the sun's still going to be at 12, and the sun's still going to be at 12, and Orion's going to be at 2. So now we go 6 months, and Orion is
Wait.
at 6 o'clock.
Yeah, but what about the rest of the day? Like,
Yeah.
just go back in time a little bit before the sun rises.
Oh, Orion rises with the sun at 9 o'clock. Orion rises with the sun at 9 o'clock, and then
Dude, you got to
and then
listen to
sets
him,
at, like,
Brian.
at 3 o'clock. Well, you asked a question, bro. He said, "What if?" And I'm saying, if, then it's Orion rises with the sun at 9 o'clock and sets with the sun at 3 o'clock.
What about next month?
Yeah, there might have been something to follow that. What if?
If the sun
Next month, hold on. Next month is 10 o'clock to 4 o'clock. Next month would be 10 o'clock.
wait. Slow down. So we have the sun with Orion. They're both at noon at midday, right? So when it's 12 o'clock, they're high up in the sky, both the sun and Orion. Right? So
Okay.
far, so good? Okay.
Yeah.
1 month from now, Orion would be 1 hour in advance compared to the sun. So even though the sun is at high noon, Orion would going to be 1 hour later than the sun. So it's going to be... Right, exactly. But now, that same day in which the sun is high up and Orion is tilted by 30 degrees? No. Yeah, 30 degrees.
30 degrees.
If you see the morning of that day, Orion
No,
will
30
have...
degrees was 1 o'clock, bro. 30 degrees was 1 o'clock. We're using 12
Exactly.
hours, dude. So 30 degrees
Sure,
is 1.
1
Now you just
o'clock.
jump to 2,
Fucking
and so it'd
hell,
be
man.
60 degrees. It'd be 60
Wait,
degrees,
before
right?
we get to 2, before we get to 2, it's still talking about 1. So just 1 month passed, and Orion is at 1 o'clock, right? So Orion is 1 hour on front of ahead of the sun, which means that it's going to rise from the horizon 1 hour before the sun. That's when you can see it.
Keep going, bro. We're talking 6 months
That's all
later,
you
not 1
need.
month, bro.
That's all you need. That's it.
You're not
Even
talking,
if
you're not
it's
counting
just
that.
1 hour.
Hold on, you're not counting hours before 12, bro. You're thinking that that's a gotcha. You're not considering 9, 10, and 11.
But I mean, all we're saying is that there's some part of the day in which you're going to see it, and that's exactly after Orion rises, before the sun rises. That small amount of time is enough for you to see it, and that's going to get larger and larger with time. And it's
So that represents
you're going
180
to have...
degrees, though, right? The sun represents
what do you mean?
180 degrees of our sky, from sunrise to sunset. We're not talking about Venus, bro.
Just be clear on what the point that's being made here is that it sounds like you're almost making a different point now, but Bacon
Yeah,
I think is arguing the point
that might be the case.
Well, Bacon's arguing the point that Orion is visible, even though it's behind the sun at one point. It's visible most of the year at some point in the night. Most of the year
Always
is visible at some point in the night.
I never
That's
said it's
because of
behind
the
the sun.
orbit.
I said it's in the daytime sky. For it's really like 4.5 months, bro.
Yeah,
I'm giving you half a month.
That's true for part of the day. For part of the day, it's in the nighttime sky.
Right. So if it's opposite the sun, let's say it's opposite the sun, okay? Then from sunrise at 9 on the clock till sunset 3, we're not going to see it. That's 6 hours, bro. 6 hours. But I'm giving you 10, and 2.
Opposite the sun.
Oh,
It's
yeah,
opposite
you're
the
looking
sun.
the
It's
opposite
visible.
direction, right?
No, it's visible.
Wait, so I'm not looking the opposite direction 6 months later than what I was 6 months previous?
I thought you were saying when it's opposite the sun, like when Orion and the sun are on opposite sides. You can see
No,
the
when
whole
I'm
line.
opposite. I'm saying, dude, quit moving them. They don't, in your world, they don't move, bro. I mean, we're the one that's
know.
moving, bro.
I know, but in reference to the Earth, in reference to us viewing them, they're on opposite sides. Is what I'm saying. So the sun is not on the same side as
We put them
Orion.
together for sake of explanation. We put them together, and it doesn't matter how you do it, as long as they stay, as long as they don't move and just our orbit moves during the month. So if the sun at noon it's 12 o'clock, then a month later we're going to be facing 1 o'clock. Okay, let's start at sunrise. Let's say they're together at sunrise at 9 o'clock on the clock. So then a month later it's going to be 10 o'clock. Then a month later, or no, let's do 6. I'm sorry, 6, because that could be AM, PM. Okay, so 6 AM is they're lined up, and then we go the next month. It's going to be 7. The next month 8. The next month 9. And that would be noon. That'd be midday. I know you don't want to hear this, bro, but just please follow me through it. So 9 would be midday. They'd be high overhead. I mean, and then 10, and then 11, and then 12. Okay, so now they're both directly behind me, basically. So think about that. So when you spread them back out, think of it like that. Think of them being completely behind me.
Okay, but Bacon's point was pretty like it's like if you follow them together, like let's say the sun rises and sets every day at 6 o'clock. Let's just say it does it every day. So the sun does that every day at 6 o'clock, but every month, Orion is going to change when it sets. So if they set and rise together one day, then next month Orion sets and rises at 7 and 7, which means that there's going to be an hour during that day that Orion's visible, and most of the rest of the day, the daytime, or most of the rest of the day is just not visible. And then the next month it'll be 2 hours that it's visible, and then the next month it'll be 3 hours that it's visible. But it's still going to be visible for most at some point for most of the year.
Keep going.
Well,
so now
you just keep going. You keep going until you get to half the year, and it's visible the entire night. And then you go back down; it's visible only 11 hours. That's visible only 10 hours. That's it.
See, you're missing the morning hours, bro. When you start at noon, you're forgetting about the morning hours. All right.
Yeah, I'm just giving. Yeah, no. I there's 24 months in my years.
Right.
No, but yeah, but regardless, you see what I'm saying? Though it's the same pattern. Like the pattern. Okay, yeah, that's right. I should have been subtracted 2 hours. So it's visible 12 hours, and then it's visible 10 hours, and then 8 hours, and then 6 and 4, like that.
Yeah,
that's it.
That's what I'm saying.
That's what you're saying it's visible most of the year. I thought you were saying that.
I got it. I got 10 months that I found where they showed pictures of it. Let me post that for you so you can take a look at it. And
that makes sense.
Well, it claims that it's like 8, 7.5 if you want to get technical to me. But you start adding refraction and all that shit. Then but
no, but that's what I'm saying. By what I just described, it should be visible 11 months out of the year, even. I mean,
I'll tell you what. This is a pretty short video. I'll post it and just give it a glance and we'll see if we could sync our arguments. I understand the point you're making. I'll think about that.
What's your argument though? Because if we agree with each other and you agree with Bacon, then
no, I don't agree with him, man. I think y'all were excluding. So let's move Orion this time instead of us. So
let's keep ourselves.
Let's keep ourselves at 6 o'clock in the morning, and let's just move Orion just to get an idea. So 1 month later, if we're at 6 o'clock, it's the sun is rising and Orion's rising. Okay, at a month later, 7 o'clock, we're still looking at 6, but now Orion's at 7. A month later, and the sun's at 6. Now a month later, Orion's at 8. Now a month later, 3 months, Orion's at 9. A month later, Orion's at 10. A month later, Orion's at 11. And then 6 months later, Orion is at 12. So the sun's at 6 and Orion's at 12 and it's noon. Okay. Now go from there and explain it. So if it's noon and the sun's directly over my head and Orion
that's not 6 months later.
Antipodal. Yeah, it is. What are you talking, dude?
No, because 6 months later, the Orion rises when the sun. If they were, oh no, you're right. You're right. Sorry, you're right. I was thinking about it differently. No, you're right. That the sun's at noon when the moon's, or the
So,
sun's at noon. I mean, Orion's at noon when the sun's rising.
here's my conclusion. So 10, 11, 12, and 1, we wouldn't see Orion. And really, to me, it
Why?
should be more like about 9:30 and
Wait, hold on.
and
Why? What's your reasoning for that?
because it's 270 degrees opposite, bro.
No, but you're talking about when they rise. You're talking about when they rise. You just denoted the time of the day that they both rise. You didn't say
Well, I was
the time of
explaining
the
this
day.
both ways, bro. I was
Yeah, I know,
explaining
no,
it
no,
both
but
ways because
okay.
you switched it, and now you're switching it back.
No,
Kind
no,
of.
no, no, no. I'll use your
Just
way.
look at what I post, bro, and let me think about that.
I'll
for a
use
minute.
your way. I'll use your way. Okay, the way you described it. I'm just saying that the way that you described it, you're acting as if you can only make observations during when it's rising, but you're forgetting that there's the entire rest of the day. So whenever when the sun rises at 6 and Orion rises at 12, the sun sets at 6 and Orion's going to be up for 6 more hours before it sets. So
That's why I gave you. That's why I gave you 9 and 10, and
yeah, but
1 and 2. I gave you. Hold on. I gave you 4 hours extra. Wait, I mean no. I meant to give you 2 hours extra. That's why I give you. Let's say I'll give you 10, and I'll give you 3. I mean 4. I'll give you 10 and 4, or 10 and 2. I'll give you 10 and 2 on the clock as extra for daylight, just for twilight and shit like that. I'll give you 2 extra months.
wait,
But then
what's your claim exactly?
my claim
What
is
are you
that
claiming?
Orion shouldn't be seen no more than 7.5 months out of the year, maybe 8.
Okay. Well, I claim based on the logic you've just given and the logic I've just given, regardless of how many hours it's visible or how many days, how many months it's visible, based on our logic that we've all given, it should be visible 11 months out of the year.
Now, if you use
Right?
geometry, it should be 6, bro. If we're using strict
No.
geometry and we're not moving shit light years away, you know what I'm saying?
No.
Then
Light
if
years.
we're using Euclidean geometry, it's
You don't.
6. If we're using a room with a
Brian.
wall, then it's 6.
Hold on, Kosho. Hold on. Okay, can we do some Blender stuff, Brian? We can do that on Blender. There's no refraction on Blender, so we can forget about that and do.
Bro, if you
a
watch my
Blender.
video, then you'll know exactly what I'm saying, because I literally put the clock in the video, and that represents our azimuthal view. I recommend before you blend it, at least glance at this video real quick. I'm gonna post it in live chat. At least give it a fucking 20-second glance, so you cover all the bases, bro, because you're not covering all the bases.
Okay, fair enough. I'll watch. If it's not that long.
Bacon, you know what's funny is the moon cycle is a direct analogy. The moon cycle, there's only one thing, a couple days, one day basically when it's not visible, and the rest of the month it's visible. Right? It's the same. It's the same. It's basically the same thing, except for one's in front of the other. But regardless, it's the same concept.
Yeah.
I don't even mean just visible. I mean visible at nighttime. So
good point.
Most of the month, the moon is visible at nighttime at some point during the day. At some point during the night.
Yeah. Yeah. The word day has double meaning.
Yeah, consider that, Brian.
I didn't drop the video, Brian. Alright. I got you. Okay, I'll mute myself and then I'll watch it. Be right back.
Just when you thought you heard it all, check out the video I just posted. Our buddy Neil You're not gonna believe this one.
You got a buddy called Neil?
Neil deGrasse. He calculated the weight of Thor's hammer.
Oh, okay. He's a science communicator, so he does shit like that. Yeah, okay.
Yeah.
Trying to appeal to the masses and make them interested in science. That's what he does. Make fun of him for it. Yeah, Brian, did you hear what I said about the moon? I think it was great.
Yeah, and the moon is not visible in the night like you say it is, bro. I was pulling up that video, but no, it ain't.
I promise to guys.
It's not visible every night.
I know. Not every night. That's not what I said. There's 30 days in average throughout the year, each month.
How many days is it visible in the daytime? Right, 15.
It doesn't. No, hold on. The question is not how many days is it visible during the daytime. It's how many days is it visible during the nighttime. And it's visible during the nighttime almost
15.
every day. Almost every day, except for maybe 1 to 3 days.
It's 15. Give a few extra days for twilight.
No. It's visible every day of the month at nighttime at some point, except for like 3 days.
Plus, the moon's moving around us, bro.
Yeah, but again, it's the same
principle.
Extra day. It's like the moon and the sun will rise at the exact same time on one day. Every other day, the moon will either be in the sky before or after the sun. For some duration, for some amount of time, but it's almost every day.
If Orion is exactly opposite the sun, and we're spinning, we're orbiting. Don't just throw out the rotation, bro. Just for 1 second. We'll talk about it if you want to add it in, but just think about just the orbit, okay? If I'm looking at the sun, Polaris is still exactly to my right, 90 degrees, and then Aurora or whatever, the Australis fucking is whatever is to the left if I'm at the equator, right? So now every star behind me represents 180 degrees. Every star. So that's what I'm saying. So now, even if you want to use the twilight hours and take an hour from each hand of the clock, say if you want to take an hour 1 month and then a month the opposite way to say you could see beyond the daylight hours, then that's 2 entire months I just blessed you with, and that still leaves 4 months. You're looking in the wrong direction. It's got to add up to 360. Otherwise, it crossed Polaris.
Hold on, try to explain this to me because I just kind of came back from cooking some food. Oh wait, hold on. Why's my mic low? Hold on. Hello.
Yeah, I hear you loud and clear, but you should probably check out the video because it's supported with the astronomy picture of the day. And I had to go way the fuck back, but I got 10 months with Orion for the picture of the day, and it should be only visible for 6. And give you 2 extra months just for argument's sake. That's still only 8. Because from Polaris to the South Pole represents 180 degrees. That represents 180. So if Orion's antipodal, then and at some point, just if it is antipodal, then you got basically to drop it down from 180. It'd have to literally cover more than 180 degrees to go past 7.5 months.
I might have to try to blender this. I want to see that.
Well, hold on. Wait on Bacon because he's going to blender it with you. But he's
really?
checking out the video. I asked him to give it a glance, so maybe speed through it.
I gave it a glance. I didn't reach all of it, but I gave it a glance.
Did you see the part with the clock?
Well, I saw all the way up to your when you were explaining with the drawing.
Spheres.
Yeah, yeah. I should have started you there, actually, but
1,
that's
2,
okay.
3, 4, 5, 6, 7, 8.
Uh,
Oh, so hold on. 1, 2,
where is
3,
it?
4, 5, 6, 7. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 10. Is that 12? Let me see. 1, 2, 3, 4, 5, 6, 7.
12.
Yeah. Okay. Oh, yeah. Because it's 1, 2, 3. Yeah.
I'll
It's
save you
12 here.
the word.
What's going on here? Woo.
Let's make an arrow.
I see.
Arrow.
It's kind of a stubby. Okay, there we go.
So if the sun represents 12 o'clock, we're certainly not seeing any constellations at 10, 11, 12, 1, or 2, right? 2 hours on each side of the sun. So we're definitely not seeing the sun 2 hours before or 2 hours after noon, right? That represents a month.
Well, okay. One second. So here, let me see if I get this right. So there's the thing in the middle is the sun, right? You seen that, Brian?
Bro, your brain's not going to let you grasp this, bro. You got to think of another way to argue with this.
Your brain
not going to let you get it. I'm telling you, your brain's going to block it completely because it's solid.
Branga.
Oh, can you see the? Are you not in the live stream? Try on the live stream.
Live stream. Dun dun. Yeah, I'm just trying to.
Arma, would you agree that if the sun represents 12 o'clock on the clock, then we most certainly are not going to see any constellations 2 hours before high noon or 2 hours after, right?
2 hours before high noon. 2 hours.
What about some other time during the night?
Well, I'm gonna hold on. If
All
it's 12 o'clock. I'm a little.
Who?
I think I'm a little lost.
Oh shit!
12 o'clock. The sun's.
Yeah, if the sun's at sorry about that, hot mic. If the sun's at 12 o'clock, then we're not going to see any constellations. If the sun's 12 noon, high noon, we're not going to see any constellations at from 10, 11, which is 2 hours before high noon, or 1 and 2, which is 2 hours after high noon, right? We're most certainly not going to see any constellations in them months, right? Them 4 months or 5 months.
I guess you're saying it. Wait, maybe I'm getting this wrong. Are you saying in the daytime? Is that what you mean by high noon? Like it's like, or are you talking about?
I'm just equating the hours to months because there's 12 hours on a clock and there's 12 months in a year. So if the sun has got to fill up some of our view. So like I said, if we put it antipodal and we call the sun 12 noon, then we're not going to see any constellations for that part of the sky for 10, 11, and 1 and 2.
Oh, okay. I think I'm starting to see what you mean. Okay, then yeah, I guess not. Yeah, I guess.
Brian, can you join the live stream, please?
Yeah, it took me a second to kind of understand, but I think I get it now. Yeah.
Okay. Okay, let's use just request use 1 time a day, bro, if you don't mind, so we don't start confusing rotation with orbit. Just use 1 time a day, whatever time you choose. Just choose 1 time a day, so we're just moving one thing at first.
Different time because you're not going to see Orion at the same time. There's always some point in the year, some point of the day where you are going to see Orion. So, okay, this arrow here. Oh, I accidentally made it blue. Okay, so this arrow here points to where Orion is. Say Orion is in that direction.
Oh, I see.
So far, so good.
Yeah. So what are you gonna move? Are you gonna move Orion? Or what are you gonna
Let
tell
him
me
do
what
it.
you're gonna move real quick, so I don't stop you.
Just
tell me what.
let
you're
him
gonna
do
move.
it.
I gotta know what the fuck he's moving, Howard. Stay out of it, man.
I'm not staying out of it. I'm trying to follow too, but you keep cutting him off, and he can't progress in what he's trying to do.
We got to chill here, guys. All right.
Right. This is a top view. of the Earth in each month of the orbit. So you have 12 Earths here, one for each month. And this thing in the middle is the sun. Not up to scale, but doesn't really matter. And the arrow just points at Orion. So Orion's in that direction. And you have each Earth here around the sun.
Orion? For my sake, will you mark Orion? With anything?
It's in that direction. The arrow points to Orion.
I want to make sure you don't move it. Just mark it. Put a dot
I'm not
there.
gonna move it. I'm not gonna move anything. I mean, Orion's in that red line, so you can be sure if the arrow is always pointing to the red line. Okay. So of course, if you're here, then you have Orion right overhead at midnight, right? And it's pretty clear that for half of the month, where we have those 6 instances here. I mean, not 6, 7, because yeah, I have those 2. Anyway, so here, of course, you can see Orion. If you're like midnight again, which is here, you can see Orion at the horizon, but you can be somewhere here or here or here, and you can always see Orion. If you're here, the sun is about to rise or set, but you can still see Orion in that direction. Now, for this other half of the year, you can still see Orion. You just have to be like here, because Orion is in that direction. It's to the right. For all those Earths,
what you're showing,
Orion
you're
is-
showing the sun. Hold on. The sun represents daytime, bro. The sun's right in your face, and you're saying you can see it. Look at the sun angle, bro. On your other side, it's daytime, bro.
Okay, half the Earth. No, the half of the Earth that is pointing at the sun is lit up.
Yeah.
This points at the sun, right? And this is nighttime. Sun time. Sorry,
right back.
daylight and nighttime.
Right. So nighttime's away from you, right? Right there, what you're showing. Nighttime is
Yeah, but
away
like if you have
from you. Well, that's where Orion's at, bro. That's why I asked you to mark Orion. I knew you were going to do this.
I can help.
Well, okay. I'm not sure how to make it more.
That yellow represents daytime, Bacon, right? The yellow facing you represents daytime. So you're trying to say we see it with the daytime glaring right in your
facing
in the
the
face,
sun.
but
No.
true.
Okay, if you're anywhere here on this circle, across a day you're going to make a full rotation here on the Earth because the Earth is spinning. So you're gonna go through all those points. It doesn't matter where you are on Earth.
You're moving the Earth and the orbit, bro, dude. Oh God, Bacon, just stop and think about it. Look what you're even saying, bro. You're just mark Orion and just draw. Listen, draw half of the screen one color and half the screen the other to represent both. That represents 360 degrees.
Brian, I'm following him exactly what he's pointing at. I'm seeing what he's doing, and I understand it. I don't understand why you don't get what he's doing there.
He's proving my point, pal. He's proving my point. Y'all are brain locked, bro. He's literally got the daylight facing toward him.
Me? No, the daylight is facing the sun.
Look at where you're facing right now. Where's the sun? It's opposite. I mean, it's opposite you, or facing you.
I'm not here. I don't get it.
Where your line is at? Okay, where's the sun? It's facing you, right? I mean, it's opposite you or facing you.
Sun's in the middle.
This sun's here. This is the sun.
Okay, now that's why I said draw Orion. Just draw a dot, bro. It ain't gonna kill you.
Orion will be to your right of the display. It's always to the right, at 90 degrees to the right.
Yeah,
what you got to do to do this
arrow.
What you got to do to do this fair is draw half the screen one color, yellow, to represent daytime, and then half of the screen, let's say blue, to represent nighttime. Then draw the sun. Then draw Orion.
That's what I did with the Earth. You have the nighttime painted blue, and daylight painted yellow. Right.
Okay, so right where you
can see Orion.
Okay, where is it daytime? Can you shade in the daytime side? Let's not spin the Earth because that's cheating.
I'm not spinning the Earth. The daylight is the yellow part.
You did too, spin the Earth at the end.
No, he didn't.
I'm just zooming in.
You see where that line's at? You see where that line's at in the middle, going up and down?
Line going up and down.
That line. How many months of the year? Okay, if you just would draw Orion and daylight, you see what I'm talking about. I'm giving you. Look, your point does buy you 2 extra months, bro. I'm giving you that. Okay, the point what you're showing with the angled Earth that buys you. Let's say that buys you freaking 4 o'clock, and it buys you 10 o'clock. But that still leaves 11, 12, 1, and 2. So I'm actually giving you 3 o'clock and 10 o'clock based on what you're showing me, bro. I got no argument with that.
I'm not following.
That still leaves 4 months where it's not visible. You just made my point for me, bro.
I think we have to leave this to another time. I will, yeah. Like I'm not getting what you're trying to say.
Bacon? Would you agree with this? Would you agree if we're just forget the sun for a second, and if we're going off just 180 field of view, okay? If we're going off just that, then you'd see Orion 6 months out of the year, and 6 months you wouldn't. Let's start there. I know that ain't the case, but let's start there. If we're going to use just pure Euclidean geometry and not do light years and all that, if we're going to bring it home, then we'd see it 6 months and not the other 6 months without the sun, just forgetting the sun. Just because the Earth's going to be in the way, right?
Yeah, but it's spinning. Then you're going to see the whole year.
But I'm just saying, don't think about it spinning. Just think about the orbit. Just think of the same time every day. The same time every day, representing one spot. And then think of so the Earth would be in the way 6 months out of the year, right? Without the sun, we're entering all one at a time.
Okay, so the Earth, the part that faces the sun, even if the sun isn't there, I know you're saying the sun isn't there, but if the part that faces the Earth, the sun is always facing the sun, then yes, you'd see Orion half the year only. Is that what you're saying?
Okay. Yeah, because the Earth's in the way, right?
Mm-hmm.
Okay, now go from there. So now you got 6 months to work with, and then go from there. So now you're going to include the sun.
The Earth spins. No,
yeah, it spins.
You include the Earth. All right. So now you can see the whole year. When you put the sun, now you can't see when the sun is in front of you.
Right. The sun represents the 6 hours that you can't see it. That's why if you just draw an Orion antipodal, bro, I mean, this will clear it all up.
There's only a 6 hours that you can see it when the Earth is not spinning. If the Earth is spinning, then you no longer have only 6 hours. You can see through the whole year. If you put the sun, you don't go back to 6 hours.
So
because
how much
you can
of
see
so the
when you're
sun
here,
doesn't. Yeah, go ahead.
You can also see when you're here. You don't have to wait until you get to the other side.
Oh, why won't you draw Orion?
Orion's to your right, Ryan.
Where would it
At
draw?
3, it's
I
at 3
already put
o'clock
an
on the
arrow.
screen. It's always at 3 o'clock on the screen.
Right. I'm just asking why he won't draw it, Mr. Sir Lancelot.
Because it would be too close. It's going to confuse the
Who cares, bro?
perspective
We're
of
only
the-
going by angles, man. We're only going by angles. I don't care how close it is. We can back it up.
Oh, if
We
we're
can
gonna
back
put-
it up with an angle. We can back it up to infinity.
If you're going to go with angles, we can just put an arrow in each Earth point where Orion's visible. Like this. Oops, that's not good. The arrow is so make it smaller.
Oh my goodness gracious, dude. What are you doing, man?
I'm putting the direction of Orion for each Earth. So here,
Okay,
of
well,
course
put
you're
the
going to see
direction of
Orion
the sun.
coming from this
Do
part.
the sun the same way. Do the sun the same way.
What do you mean do the sun the same way?
You got to keep the sun
I'm
in
just
the middle.
fucking with you. I'm just fucking with you, man. I'm just fucking with him. Okay, now the sun's in the middle. Okay, sun's in the middle.
I'm
You got
already
Orion.
confused. Don't mess with me.
Okay, I know you are, bro. I'm trying to. Now, okay, sun. Okay, now, so we're looking exactly where are we starting? Where are we looking? Are we starting looking? I don't know why you did all that, bro. I really don't. I was just asking
Me
you to draw
neither.
a line.
Let me remove it then. It's making it really ugly. Yeah, where do you want me to draw Orion?
I'm not going to cheat
Here.
your angle, dude. I'm trying to make a point, but I'm trying to start from scratch. I'm not going to cheat your angle. I know that it's not going to be the angle with it up close. I realize
Well, no,
that.
all you gotta do to imagine this is Orion's always to the right of the screen. It's always to the right. At the, I mean, that's
So you
where
vote
it's at.
that he won't draw it
You
for
have
me. You just
Orion
hope
there.
he won't draw it.
No, I draw it.
Is that what you're saying
I
now?
drew it. It's there. Is that what you wanted?
Okay, where's Orion now?
There.
Okay, so we're looking right at it. Okay, now go 6 months. Okay, now we're looking straight at it and it's midnight. Now go 6 months from now. Draw the line 6 months from now. Just go on around.
Like here?
No, it's got to. Yeah, no, don't move the line and without turning it. To turn it in the orbit, and you can rotate it all you want after this. But now go 6 months later. So turn the line where it's because we were just looking at it. Shut up, Howard.
Like
We were
this?
just looking at Orion. Now we're looking directly opposite. So and we'll start
At
from
the
there.
at the 9
Yeah,
o'clock
but
position.
you mean like this?
That would be 3 months. Now go 3 more months. Okay. Now that's 6 months later. Now we're looking. Now Orion's at our back. Okay. Now spin the Earth any way you want, and no Orion. So now if you shade half the screen as yellow, then you'll see that geometrically it'll only give you 6 months. But with the universe vast size and the Earth's rotation, all that, I'm gladly give you 2 extra months to compensate for that.
I think that's actually not the case. I went downstairs to make some.
Yeah, I didn't get. I don't think I'm following your reasoning. But
I thought
I'll
the
have to
same
leave
thing,
that.
but it's not the
Yeah,
case.
I have to leave that for another day. Because I gotta go. It's getting late here.
All right, I'll take over. Don't worry, Bacon. I got this.
All right, Bacon.
All
All
right,
right,
you
man.
do on a
Hey,
Blender model?
get
or-
with me tomorrow, Bacon. Get with him tomorrow on the AE map shit when you get us. Just a second.
I can't guarantee that.
Well,
Again,
whenever you
I'm
get
on
the
my
next
own
day or
model.
after that, when you
Alright,
get a minute, Bacon, we'll argue about it.
Fair enough.
I'll see you later, bro.
So, yeah, good night, bro.
Good night, Bacon.
Good night, bro.
All right, my mic might be a little bit lower than usual, but because I have to move it away from my face, 'cause I'm about to eat. But I won't be eating on the mic because that's just rude. But yeah, I figured it out. I went downstairs. I was like finishing up my food, making it. I was like, oh shit, wait a minute. You don't even need any Blender models. You could just think about how the sun sets, right? So when the sun sets, right? I granted, I think it takes a little bit more time, like after it actually sets below the horizon for the sky to be fully dark. But let's just say, all right, let's just say once the sun sets, right? We're going to give me the benefit of the doubt for now, and then I'll give you the benefit of the doubt. But let's give me the benefit of the doubt. Let's say once the sun sets, right? It's below the horizon and the sky is dark. That means the constellations around the sun or next to the sun are now suddenly visible. All right. If you think about it that way, then the only constellation we're really losing is the constellations behind, like directly behind the sun. And the sun only takes about 0.5 degrees of angular size, so we're not really losing a whole lot of sky, really. Now that I think about it, you following me? Because think about it. I get your argument that you would think that because the sun is out, it would only be like half the sky you could ever really see. But if you really think about it, though, once the sun sets, everything around the sun is suddenly visible now, right?
Yeah, or an eclipse even. But what I was talking about is I'm good with all that. I understand that you could see it for more than 6 months. That's what I was trying to agree with him. But what I'm saying is that if the sun represents high noon on the clock and the sun, so the sun is 12 and it represents high noon, we're most certainly not going to see any constellations 2 hours on either side of noon. So 10 and 11 and then 1 and 2. no matter what, we're not going to see any constellations 2 hours before noon or 2 hours after, right? So you got to think of the night sky as 360 degree, but then you can cut it in half since we're only seeing 180 degrees. And then you can't take more than 180 degrees. So if, like I said, the sun represents noon, then you're never going to see constellations 10, 11, 1 or 2. And it's certainly not noon.
See, okay, I thought I understood what you meant by 10, 11, and 1 and 2, but like, I'm a little like, okay, so that represents like if we're treating the sun's position as like the numbers on a clock, right? Is that what you're getting at? Like, the sun would be
that represents the best. That represents the best angle you could possibly get to your back, like spinning around toward 6 or midnight. Actually, midnight would be 12. See, that's probably why they did that shit. It made the 2 12-hour days to confuse us because that's a whole lap. But so in other words, that represents the best possible angle you could get looking towards Orion. It would be, you could pretty much bypass 10 and 11 and 1 and 2 and high noon, no matter what.
Yeah, I might have to model this because I think I might be just a tad bit lost. But yeah, I mean, maybe I'll model this. Just not right now though, because I do want to eat. But interesting.
They they claim, if you look it up, they'll claim that you can't see it for all these months and shit. But I just looked at the astronomy pictures of the day and whatnot, and I had to comb back a ways, and look at other sites and shit, and was able to confirm it. I mean, validate it, then confirm it. That so there's got to be a couple months. There would have to me there would have to be like 7.5, man, based on the math. Maybe y'all are going to show me something that I'm failing to understand, but I wish y'all would use the clock and isolate the motions, do them individually instead of trying to jumble them up, man. I think we're not on the same page. So in other words, when he drew us and Orion was right at our back, the sun represents 180 degrees behind us. So if he goes to 1 o'clock or 2 o'clock, he's most certainly not going to see it, no matter what he does. He doesn't have the angle. The sun's covering up that part of the 180 degrees. And then if he goes backwards, like previous months, to 11 and 10, he's still not going to see it. Now, then when he gets down to 9, I could still argue that he can't, but then he could cut the corner and show me, he could cut the corner and I can give him, like I said, the extra month on either side. That's why I just gave him 8 months. I don't know. Food for thought.
Did you guys see that that conspiracy music guru? He makes the music. You see that he did a podcast with Jim Brewer. Yeah, I mean Jim Brewer, like I don't know if he's like A-list celebrity or B-list or whatever, but he was on Saturday Night Live and he does comedy and stuff. And basically, like Jim, Jim Brewer was saying he wants to set up like a huge concert and basically have like. Yeah, dude, have like also like Tom McDonald, maybe get Tom McDonald involved. So yeah,
man,
could be big.
That is awesome, dude. I knew I liked that guy, man. He's the guy in Half Baked, the man, the stoner dude. He's so fucking funny. He's a comedian. But dude, is there any way you could link us to his to their discussion?
Yeah, it's on like Conspiracy Music Guru's YouTube channel, and then like Jim Brewer, he does a podcast called the Bruniverse. It's like Bruniverse, Jim. It's like universe, but with his name Brewer, so like Bruniverse. So yeah, it's I can link it, but yeah, it's on Jim.
That's right. I can go to. I think we all are familiar with Conspiracy Music Guru. I mean, you can if you want, but yeah, that's that guy to be right where I need to go. Thank you, brother. That's awesome, dude. I did not know that.
Yeah, it just happened like a day ago, and Because dude, Jim Brewer's been talking out about the whole scamdemic stuff, and like he's been dropping it like in a lot of interviews and stuff. He basically got like he said that he was doing shows during the pandemic thing, and then he basically said that all these venues that he was doing that required people get the jab. He just said that that he refuses to play any venues that are going to require people to get the jab. And then he said like he just got dropped by like a bunch of different venues. Like he basically they just like blackballed him basically. So like he couldn't even do shows because of that. So I think that like sparked him to do even more shows and interviews and stuff talking about it. So I mean, dude, he seems pretty hip to everything, dude. Like I don't know if he completely like thinks the Earth is not a globe and all that. He actually uses a globe like that Brunaverse. It's got a globe in the logo thing. So I mean, obviously he's probably still somewhat on the fence or whatever, but he's pretty on board with like everything, dude. And he's like a huge fan of Conspiracy Music Guru, and that guy's doing music videos about NASA, no pictures of Earth, space is fake, all that stuff. So he's definitely he's in tune with it. And yeah, from what I heard in that interview, he's saying he wants to set up like a huge concert, whether it's going to be like on TV or Netflix or a special, or I guess we don't know what it's going to be yet. But yeah, he wants to get a bunch of like, truth musicians together and stuff. So he was saying in that thing, he's like, I'm going to make it happen, man. He's like, I'm calling my agents. We're going to do it. So yeah, it could be interesting.
Goat Boy. That's what Jim Brewer's famous character is.
Yeah. Yeah. It makes that noise. Oh, yeah. Dude, when he goes off about the masks and shit, it is hilarious. He's like, trust the science, trust the science. Like, oh, man, he's hilarious when he does it.
Yeah, that's pretty good news. I mean, I guess he already got kicked out of mainstream, so it doesn't bother him.
Yeah, I don't know like exactly to what point, but yeah, that's what he was saying, that like they all just dropped him once he was not willing to play venues that required the jab.
Alex is supposed to be doing some children's books too. Like he took all his songs and basically made them into a picture book format.
Oh, nice. They're like translated from his songs?
Uh-huh.
That's cool. Yeah, I think I'd heard something about that. Yeah, yeah. Is that out yet, or?
I think so. He's also got a whole nother project about frequency and certain music recorded at a certain frequency for your mind, for your brain stuff.
Yeah, like the 432 hertz.
It's something slightly different than that. It's something slightly different than that, I think. Not sure.
There's like the 440 versus 432.
Yeah, it's something like that. For some reason, I thought it was 500, but I don't know why. I met this DJ guy last weekend, and he was all into this word 5G. I guess that was the word he was using, representing front, rear, and center speakers. So, like, meaning in his world, everything should have that much dimension. And, like what we used to call surround sound. And I was thinking that if we go forward, the downfall of our imagination is going to be needing a screen, whether we're looking at our phone or looking at our computer. When we get the glasses or the goggles right, we'll be able to see stuff left and right. Even the way these rooms look, you'll be able to look left and right and see Jeremy, and see me or something like that. And when we're used to having an inner space view with multi-cams around us, they'll start making everything, television, movies, everything's going to be from the perspective of being everything all around you. So therefore, remastering everything into full surround is going to be a big part of that experience. Because otherwise you won't know where to look unless you hear it. You know, like when you hear something behind you, you'll be able to turn and look. So I think things are going to change so much visually because you'll be immersed in everything, more like a video game. You'll be the center of it. There'll be no reason to look at a screen. There'll be no reason to make it that way anymore with just front projection.
Yeah, that is interesting. I've seen some of those new like glasses basically that put like a screen right on the glasses, so you can like it looks like a huge. I forget, they say it looks like a 100-inch projector screen or something when you're looking at it. But yeah, I do wonder where the next stages are going with the whole phone thing. Whether they're going to be moving to like a glasses or contacts or
implant. It'll be an implant soon, right? It'll be your chip. It'll be your chip. It'll be your car key. It'll be your bank card.
Or instead of an implant, it's just everything that's in the city has cameras and just scans your face and body, and the implant or the phone or the computer is actually surrounding you and in all the appliances around you and all the street lights and shit.
Shoplifting is getting really bad. Pretty soon they'll be able to scan you to see if you have money on the way in. If you don't have anything in your account, the door won't open. And they can scan you on the way out.
Shop? What if I just want to see what's in the store so I can come back later to buy it? Like,
yeah, I don't know. My nephew is a like a street level what do you call it? Shoplifter, like his whole life. And it's really easy to steal meat, like down your pant leg or something at the market. So when you're used to stealing meat, your next step is to steal a barbecue off of somebody's porch. So the poor fucker talks about like trying to give away meat because he's cooking it all on a barbecue on some street corner because he's madly out of his mind on fucking speed. So imagine anybody can steal at the supermarket, but you got to figure out how to cook it next. He's been a thief his whole life. It's really sad. Really stupid. Well, Gio, if we're lucky, if we ever get back to a normal again, maybe it's going to be more underground, grassroots stuff in terms of entertainment. Kind of like the Prince story, you know, why he stopped using his name. Because he was just completely owned by the contract he signed. And couldn't even use his own name or face. Or name, anyway. Couldn't use it on other projects. So, yeah, I'm not sure where YouTube's going to be standing at that point, and who's going to eventually come along to compete, because it doesn't seem like any of these other platforms are going to get anywhere near up to big numbers.
yeah, where social media is headed. Well, it would be crazy if they did like a financial reset and then connected that with like a new kind of digital social media platform. It's kind of what I sense they're going to do. It seems like would make sense to kind of have something happen with the fiat dollar that, you know, doesn't really maintain, or there's already all these banks, you know, claiming to be failing or whatever and going under. So, you know, could there be some kind of pulling the rug out in that sense, and then try to usher in like some more of like a controlled version of an internet where, you know, your money is linked all through your phone app and through, you know, the whole network. And then your jab protocol and your media and everything comes through that. I mean, that it's kind of like almost a 1984 type direction to go, but it does seem like we're like there's some just feeling. I just have just a general sense that like we're somewhat kind of nearing the end of like this current social media cycle that we're in. It doesn't mean that just like tomorrow I think it's all gonna be over or anything, but it seems like yeah, like there's no other platforms that are going to like take over these ones now, like we can see in the immediate future. And then even the ones now, it seems like they may, shift into something different.
Yeah, I hate to say it. It's only going to take one thing similar to like TV Guide, an internet guide, where everyone's not going to Google to figure it out or to YouTube to figure it out. They'll go to another .com and everything will be menued there. In other words, that's really why we enjoyed YouTube, because of the menuing. There's really no other thing it had going for it, to tell you the truth, because you could find stuff. So it's really about finding stuff, because obviously there's shit out there, between Darknet and Onion and every.com. I mean, there's all kinds of stuff out there. It's just, can we find it?
Yeah, and with all these new like AI language protocol things, they're definitely going hard with that. It's like Google has all that. Bing is developing theirs as well. So seems like they're trying to move it towards this like streamlined search system, that is all run through whatever their language models. It's kind of crazy to think how much that could control information. Like I met someone the other day who was we were talking about the shape of the earth, and she was interested in asking questions and stuff. So I was talking about it with her, and I was like telling her, I was like, if you wanted to just research this on your own, like it's very unlikely you're going to find any real information. That's just frightening. It's crazy to think that somebody who just hears about it, like, oh, I want to look into that, literally, will not even be able to find one good video, one good ODD video, or, any good, even just introduction. Like it's crazy to think of that. So I guess that's kind of what they're doing, to kind of suppress things.
I was going to read you something. There was a dude, he went by the name Roll the Boulder for a while.
Yeah,
rolling my boulder. Yeah, his name's Eggshells Are Flat Now.
Are you sure?
No, that's not the same guy.
No,
yeah,
it's not the same guy.
I think it is the same guy, but maybe
no, it's not. No, it's not. Walking on Eggshells is a different dude. He's now going by Yano Guert, Guerte, whatever that means. And he posted this the other day, and it's really an interesting short story. It's just like 5 lines or something. Let me read it. He goes, here's the story. I say the Netflix quote behind the curve, or whatever it was, I felt skeptical. Surely the people in it must have been taken in the worst possible light. I searched. I found a real flat earth on Reddit, I thought. I got banned on Reddit. I searched YouTube. I found Professor Dave, but I didn't want Professor Dave. I searched harder. I found 24/7. I made a Discord. It was named Sisyphus because I love the story, guy pushing a rock forever, but I never winning. But then 24/7 banned me because my account was new. Truth Prevails fought for me and got me back on a new account. She suggested my Roll the Boulder as homage to Sisyphus. In the early days, I was kind, made honest arguments, and tried to simulate honest dialogue. But Indio, Helio, Jerry, Geo, GE, Larry, Bandsaw in Montreal, etc. And I guess I realized that flat earthers don't care. It isn't about the truth. And I soured, and now I just troll. But this journey hasn't been without its regrets. I'm honest. Waz and Yeech and the Jesus Dude and even Soon are interesting, but I seem to spend more time now hiding as my name is Roland and trying to be clever or funny or just flat out on the side of the losers, the flurfs. So there. So it's funny, like some people want to come to flat Earth and can't find it. Then they find it and they're basically dissed all over the place. And I don't know how to fix that.
That's
That's
so
it.
weird because it doesn't have anything to do with the shape of the Earth or the makeup of the Earth. It has to do with people, and that the worst part is that people are the reason other people don't come to this information.
Yeah, and that's, without the religious side of it, or just the basic ego side of it that gets in the way a lot. So I mean, I've heard a lot of people trying to talk about getting to us. And how would you know when you finally found flat Earth? Think about it. It'd be hell.
Yeah. You gotta trust. Listen, every time they're like, "Don't trust your senses when you're observing a reality." Well, if you smell something fishy, get the fuck out of there. And the real ones will present themselves, no matter what community you're in. You just have to, but you have to bear down and keep looking. You can't just let the first, you're always going to see the peanut gallery in the back rows when you first walk into the stadium, into the auditorium. But as you keep getting closer, you'll, move through all the other rows and get to the meat and potatoes up on stage.
Yeah. It's weird. I always talk about wrestling, and about how there really is a sport called wrestling. But when you get to the professional level, no. It's something else called wrestling. And everyone knows it's phony, but it still dominates. Kind of like the way our politics run, kind of. Like everyone knows it's just a show.
Well, you mentioned rolling the boulder, and I was going to comment on that. I'm a little tentative to say much because he's not here, so talking about someone who's not here, etc.
community often, they don't go away either. They still hang out. You know,
Wait.
your Jose's and your Babs and Sean G's. You know, like they claim to have left Flat Earth, but they still hang out.
You know what's even weirder to me?
Well, yeah, I just kind of didn't, what, since he's not here. But yeah, sorry, go ahead, Noah.
Now I know sometimes when I go, man, it sure is quiet around here. I know you guys are talking about something.
No, we don't really do that often. But yeah, just
with the people who left Flat Earth, that's one thing, I guess.
Yeah, when
But
it's
like the people
when it's
who
quiet.
came,
Sorry.
people who came, thought it was a globe, learned about Flat Earth, came here, and never thought it was flat once, and just kept on thinking it was a globe. And then they come here every single day to talk to Flat Earthers. Something weird about that.
Super strange. I mean, to say they're flat curious is, the least you could say. I mean, I have heard some people explain it. They just think we're smart enough to hang out with. Well, Kosho explains it, right? Kosho explains it a lot.
The problem is it's a very controversial topic because people are considering their entire worldviews, therefore their entire psyches sometimes, right? They got to consider and reconsider everything. The implications are so big that it's like, deep down, I think everybody wants to have this kind of conversation, but a lot of people don't do it because if you come and talk with flat earthers, especially if someone finds out, oh my God, like homeboy Jace has to get and go, on a walk because nobody can know. It's like, even though this is perhaps the most interesting, important, maybe like all-encompassing conversation, when we're just talking about how people are duped by other people, that's it.
yeah, and truth. And it's interesting because it's like, in terms of the Earth, like what the Earth is, it's so like foundational. It's like the actual the idea of the Earth as a womb in a sense, and we're all in it, or just Mother Nature. There's all these different kind of conceptions, but it's like the very thing. It's like the very basis of the entire world in which we live. Now, maybe you could argue some people are so involved in like their phone and their digital worlds, and in their jobs and whatever it may be, to where they're not really like kind of interacting with the Earth as much in a sense. But still, even at that, it's still the entire world in which they reside within. So you would think that a discussion like this would be just like primary and foundational, which I think it always has been through time. But in this current time, it's all been replaced with this like globe paradigm thing. Then everyone's just like, yeah, just I guess drinking that Kool-Aid to the point to where they don't think there is a discussion because NASA and all these places have got it all under figuring it all out for them.
At the same time, I just did an interview with some guy who probably never heard of flat earthers, or maybe his audience was asking him. And I'm not very happy with the way I did, but he was
nice. When did you do this?
A couple weeks ago.
Oh, cool.
He was tripping that when I told him that the Flat Earth Society wasn't us. Like, I could barely explain it to him.
Wow.
It was weird. And then same thing with us being stationary. He just couldn't grasp that. He goes, look, if everything else is moving, why aren't we moving? It was really weird.
Who the fuck is the fucking Flat Earth Society? Does anyone know anyone from that thing? Or that, is that what it's called? There's like the first thing you type, when you used to search it up before they really went hard on the censorship.
I'm not sure if he's new.
Society, but who is that?
I heard the main guy talking, man. I don't know if y'all can hear me, but I heard the main guy talking. I don't know if he's been the president or whatever you want to call it, but he was a smart dude. His arguments weren't as bad as you think. He just he argues it kind of like Austin, you know, like within their realm and shit. Like he don't really believe that we're racing upwards and shit. He's just making the argument. I think they were a little bit misinterpreted, or else maybe he's the new guy. But this dude was smart as fuck, dude. But this was only about a year ago. I don't know how long he's been in charge, but he wasn't really arguing that we're racing up. He's just arguing within the physics. You know, I think a lot of people misinterpreted that. He's real smart, man.
Okay, so
saying that, but you don't get the guy's name. Like, who is the guy? We never heard of him. We never talked to them. They don't hang with us. They don't do events. They don't come to our shit. I mean, we got to get real about whoever you're thinking they are, because I know a couple of couple of people have taken the name for fun, you know, particularly in Facebook, but that doesn't mean it's them.
Well, okay, so when I first looked into like Hollow Earth and Flat Earth and a lot of, back in like, this was like 2005, I was researching it. And back then on the internet, there was very little information on a lot of this stuff, especially Flat Earth. There was more on Hollow Earth. But anyways, and when I came across the Flat Earth Society website, it was like the first search, the first search that came up back then. And so, yeah, I like went there and I was reading in the forums. And anyways, I mean, I could share my journey with it, but that wasn't really the point of me bringing it up. I was just saying that Flat Earth Society. So that was like the original one that was like, is the main one that, has been always there. But then in later years, there's a second one now. And the websites are slightly different. One of them is like TFES, and then the other one is Flat Earth Society. You know about that, Dan? How there's two of them?
No, I was just looking. I just posted the TFES one.
Yeah, so there's two of them. And then I think what Brian's talking about is that like the guy from the new one or whatever, like the newer one, he was on Globebusters. You remember that, Dan, years ago?
No.
Yeah, dude, he was on Globebusters. And
He debated MC Toon also. He debated MC Toon.
oh, did he? But I mean, Noah, you were saying, what is a Flat Earth Society? I mean, all I can say is that it seems like the original one. I don't know about the second one, but the original one, as far as I could tell, it just seems like it's run by intelligence. Whether it's CIA, FBI, whatever it is that runs it, probably more related to the CIA, and to where it seems like just, or whoever's running NASA, the whole, whatever their whole thing is, because it seems like it's put up by them as like just a total front website. Like it has like a lot of like some good information and then some misinformation like LinkedIn with it. And then it seems like the forums, like, I mean, Dan, is there anyone like there might be some, I guess, real people in there, but some people even thought that those are all just fake accounts because like we don't meet anyone from there. Like, even though, like you said, there's some kind of people that claim to have posted on there or have it associated with them, but it seems like the whole thing is like 80% fake and maybe just 20% real.
Really sus. Like really
Yeah.
sus. I don't know. Like, or maybe it was a society and then now it isn't or something, but like there's no people. There's no Flat Earth Society people. They never come through here. They never come through like 24/7 or Gem Pandas, any of the servers, bro. Like it doesn't add up. It just doesn't add up. Like
Yeah, but
where's their Instagram?
Mark
Where's their
Sargent
where's their shit?
Mark Sargent bought in. Geo bought in. Shane St.
Wait,
Pierre
wait.
bought in.
Not me.
Well, you didn't join it. You joined it, right?
Absolutely not. No. I just looked at the website.
Oh, okay. So I think a lot of people that were interested that saw the Netflix film would have seen that Mark said that he was a member and joined accidentally. And I know that had to have happened in the dozens or hundreds or thousands. I think anyone that's a member are newbies that haven't figured out it's not us yet, really. So I did talk to Mark about it last weekend, and I'd like to make a plan to figure out who they are, make them come around if they're real, overrun them or sue them if they're not.
Yo, you know what I always wanted to know about is that Zetetic Society that they had like 100 years ago. Like, whatever happened to that? Like, did they just fizzle out or something? Like, you know what I'm talking about?
Yeah. Yeah, I don't know. I mean, same thing with geocentrism as a, as a term.
So you were saying, I mean, I'm not surprised Mark Sargent's associated with Flat Earth Society. You were saying Shane is too?
They both accidentally joined it, thinking that was the thing to do.
Hey, how do you join that? How do you join that?
I don't know. I just posted links to both of them.
To how to join?
Well, I mean, both the websites.
Okay.
There's no point in joining it. You're here with the with the real people. What are you talking about?
I want to join them like conjoined twins at the hip.
I mean,
How about if they're already here and we don't know? You guys don't know about it. Did you ever consider that?
I'm always feeling like.
So
you guys ever feel
Not
like you guys are
necessarily
singing?
here, like now, but in the community.
Here.
It's hard to find the community. It's hard to find the community from the outside. It's not very easy at all.
All right. Well, so
What do you think? They have like a T-shirt, Flat Earth Society, like logos with their names on it. How would you know?
Well, here's one way to think about it, like the one way to consider it, which is that, okay, let's say the actual, I don't know about the secondary one, but let's just say the original Flat Earth Society, like the one that has been around for a long time on the internet and whatnot. It's like the first search you always get. And that, like, there's an idea that, okay, if that is some, like, run by whatever agents, intelligence basically, then, or the same people running NASA, et cetera, then the whole thing's kind of a prop. But they needed to make it look a little bit real. So it does have like forums, and you could probably create an account with an email address. Or I guess there is some way to be a member. You pay something or whatever it is, you get a card or something. I don't really know. I've never looked into that. So they might make it like somewhat real. That's why I was saying like maybe it's like 20% real. But in terms of a lot of the forum posts, like it's not like a real community of like thriving like people and ideas. It seems like maybe a bunch of like fake like prop posts, and then maybe some real people like commenting a little bit, or whoever, some like, so, astronomer runs across it and goes in there and like tries to debunk a little bit or something like that. But it's not like a real actual community, it seems, of, people, which is why none of us have ever met any of them. And, other than these connections of like, Mark Sargent's connected to them, I guess. And then if Shane was, but I don't really even know of like anyone who's even really connected with them much at all,
For $12, you get a card. You get a membership card.
Oh, okay. 12 bones.
Hey, I heard for $13 you get a card and a blowjob. Is that true?
I know you can fit 4 Earths in Uranus. 5.
I don't think it is quite $13.
It's 5.
Hey Dan, if you ever get married, your wife's gonna be, her name's gonna be Jan the Water Woman.
Do you know how to get your Flat Earth girlfriend back if she leaves you?
I don't want her back.
That was ridiculous.
You get out your P900, she comes right back.
Hey, I don't want her back. Hey, I don't want her back since the last time I came on her back. I don't want her to come back. You know what I mean?
Come on now.
Slick back.
I could hell, man.
Yeah, I just looked on their website. Yeah, you can be an associate member, which is free, and you have to give your city, state, and country and your name for your online membership records and your email address. Or you can be a friend of the Flat Earth Society and pay $12. That's funny.
So where are they? Are they renting an address somewhere?
Why would I pay $12 when I can just come on Discord?
We should have a meetup there. Oh, okay. So this one's in England.
It says United Kingdom on this one.
Yeah.
Do they have a mission statement or manifesto or something?
Why would I pay $12 when for $15 I can get a NASA T-shirt?
Let's see. They've got a frequently asked questions. Oh, it says team. It's got a list of who's on their team.
Really? Now we're getting somewhere. Is there a USA rep? I'm going to check the other one.
Well, Daniel,
the manifestos says a lot. You won't believe. Yesterday I was speaking to, are you guys ready? A slave who claims, well, first he said he ate human meat and then he said he hadn't. So I was talking to a slave yesterday. That was his manifesto. He was owned by somebody. Yeah, and we were talking.
What?
Get this. Yeah,
I don't get it.
we were talking.
Wait, keep going.
Yeah, we were talking. You can ask me whatever you want after, but let me say this: we were talking about morality. Has anybody ever heard of that?
Yeah,
Amorality.
my dad was amoral. He was diagnosed as amoral.
What is that? A thing?
Yeah, he has no morals. He's a sociopath. He's a sociopath.
I figured. Okay, is that like a new disease or something? Okay.
He has no morals. He's been diagnosed.
That's a good one.
I wish you guys weren't laughing, but okay.
Oh, he's serious. That's the funny part.
Yeah.
Wow.
I'm way serious.
That is the funny part.
All right, now I'm laughing.
Well, I
No.
mean, it is a bit. Like, is that it is funny because, like, is that it? I'm sorry, it's not even funny in that way, but it's like, is that a diagnosis? Like, dude, that guy has no morals, so he's in this category now? Like, or what does that mean exactly?
My dad would say that he didn't kill anyone. And that's kind of where he drew the line. Like, he didn't eat me he didn't eat me. So what the fuck?
Excuse me? What do you mean he didn't eat you? Of course he didn't eat you.
Well, but you're thinking in terms of like your kin and love and respect and stuff he didn't have. He didn't have that.
Your dad was not like that much of a savage that he like had thoughts of eating you.
I'm telling you, his thought pattern, he said, what's the problem? He goes, it's not like I'm killing anyone. Like, in other words, if he let you live, he thought he was being cool. Otherwise, he'd move through anyone.
That's pretty cool. I mean,
In his eyes,
people
yeah.
like believing.
In his eyes, he thinks he's cool, but it's gruesome. It's a gruesome way of life. Like, he's always like one of those guys that says he'll pay you Tuesday, and then you can't find him Tuesday, Wednesday, Thursday. You catch up to him Friday, and he says, "I told you
He's
Tuesday."
amoral.
He goes, "I told you
He's
Tuesday,"
amoral.
and it's like, dude, I've been chasing you since fucking Tuesday, So, and I finally got one of his friends to tell me. He goes, "Look, your dad would give you the shirt off his back. The problem is, he'd promise it to 3 people. So when you get to him and you go, dude, where's the shirt you promised me? He's standing there with no shirt, so he doesn't understand why you're bitching. He already gave it away." But but I can't tell you how many times I've been left somewhere. As a matter of fact,
the doctors diagnosed him, eh?
I got left once in East Germany with no money or transportation. Like, there was this concert we were all working at, and it's like it broke down, and like before I knew it, man, he was gone. Like, I was just standing around in East Germany, not speaking the language, with my baggage and no money, nowhere to go. It was like, dude just split, left me in a foreign country.
Wait, what were we talking about before, though?
Morals, the flat Earth Society, and where's the integrity? We're talking about integrity.
SC was saying something about some slave or some shit.
Yeah, this dude. It's called Mr. Slave. So he freely admits. That's why when we're talking about this, I thought of manifestos. I thought of him. It's in his manifesto that he is owned. He is property. Somebody owns him. So in other words, if you get to, I kid you not, man. I kid you not. We have it taped and everything.
Is he like in the Middle East or something? Like where?
No.
Where is this?
No, I think he's American.
It's a sex thing.
I thought that was like a. Oh.
Yeah, well, you're talking about that thing where it is sort of part of like I think BDSM and some of the sadomasochist stuff, but where they have all kinds of things like that people get into. Like you could be like owned by someone, and you have to like
I thought you
do
meant like
everything yeah.
I thought it was
Yeah,
a
well,
legal slave, and I was about to
have
be
you
like,
guys
what about the like amendment or whatever, like the 13th or 14th Amendment? Like, I thought it was legal, but now I get it.
Okay, I'll
have you
send you
guys
guys. Here's an application. I know somebody that had slaves.
Oh, you mean like owned, like that it was like they had like an actual certificate from the government or like an actual. That's what you
No,
mean.
she would have to
Yeah, I
qualify.
thought they
She
were
would have
gonna
to
come up and be
qualify
like,
you.
"Oh yeah, my family was never emancipated" or something ridiculous. Like I was kind of like, but then it just turned out to be some fucking
Kinky, who knows
yeah,
what.
that type of shit.
It's the
have
sickest
you
shit you've ever seen. It's beyond kinky. It's
have you
fucking
heard
horrible.
have you heard the news about China? Like, China put out a warning to their citizens, and then they've just recently had a meeting with the leaders. I think this the tourism leaders of Myanmar and Thailand, because a lot of people have been going over to Thailand and Myanmar, and they basically get kidnapped to do, the scamming, online scamming and stuff. And then if they don't go ahead with the online scamming, they get taken away and their organs are sold.
Woof. That's really intense.
Yeah,
What a
they're
fucking
like
evil world.
prisoners. Yeah, but they're having a big meeting about it, I think, yesterday, to try and figure out what they can do.
That's
A lot of foreigners go missing there too, not just Chinese, but just in any culture.
As crazy as that sound, I've heard of organ harvesting in prisons in China. This is not the first time I hear this.
I was gonna say, are they at least getting a good deal?
Yeah, it's not funny though, man. You shouldn't be laughing. Imagine being like harvested for your liver, for example, or some rich guy pays, he needs your heart. They just come and take out your heart, man, and just throw you in the garbage.
Yeah.
I don't know how we got on this, but yeah, I mean, I'll say something kind of dark on it too because we're on it, I guess. But yeah, I've heard of like I don't know if this is real or what exactly, but I think it probably is. Sadly, where like somebody who's like homeless or like in some way kind of dislocated from society in some way, like they'll get like just grabbed into like a white van and then drugged and taken somewhere. And then they won't remember any of it, and then they'll just wake up like in a ditch somewhere, and they'll have like stitches on their body where their like kidney was taken out or something like that. How
Yeah, bro. Yeah.
dark. That is dark.
That's sick stuff, but that happens.
I heard all those treatments, those stem cell treatments, like high biotechnology shit that like millionaires and billionaires go down to South America to get. They pump this in you, and it basically like will make you stronger, like feel better. It'll heal shit. Like you could have like injuries. It'll heal your injuries. Like these stem cells are basically like miracle drugs that these rich people just pay millions for, and they do it all privately. It's not a hospital. Like it's a private doctor who has clients or whatever, and he administers all this or whatever. But basically, the way these guys in South America get these stem cells is it comes from like fetuses and shit and like abortion material and stuff like that. So
Yeah, it's sad. Money can't buy you love, but can buy you just about anything else, unfortunately.
Oh yeah, just pop on the dark web. Just about everything you can imagine there. I mean, I'm not really recommending going on it. I'm just saying, I'm just using it as an example to say that like you can basically buy almost anything on there.
You can get kidnapped by this chick here. Here's the application. Right there. There's 10 points, 6 points. you got to go
In
through?
mapping application form, and then
Yeah,
what?
so
Yeah,
The
I
harvest
don't know.
facility?
I don't know if we want that in the text chat, but
man, people will do the weirdest fucking shit. It only takes a second for me to feel normal. You know, when presented with really twisted shit, it's like, no thanks.
yeah, it seems as though the creator just wants to try everything at least once, if not more than once. Like it's like wants to express every possible combination of realities or experiences.
Are both these flat Earth societies the same? It seems like one went to the other, or I keep bringing up the wrong one.
One of them is theflattersociety.org, and then the other one is tfes.org. Yeah, you're saying which one is the actual like CIA one, or are they both?
I think they went to the same site. Oh no, they didn't.
When the guy was on Globebusters, he described like how they differ from the other Flat Earth Society. They claims it was like a split of some sort. So,
And then Eric is the International Flat Earth Research Society, right?
yeah, so that's one that Eric Dubay claims that he kind of like unofficially carried it forward, basically, because there was an original IFRS, International Flat Earth Research Society. Yeah, there was an original one that ended up not, was. I guess the people running it had passed away, or they stopped, using it or whatever for years. And then Eric Dubay, like, kind of unofficially, kind of took that name and then used it for his thing. Yeah, kind of intending to kind of carry on the original one.
I want the one with the shiniest, prettiest card. If I'm gonna be a member, I want the prettiest card.
You know, Dubay's last video.
The one that
He
was
did
an interview, kind of.
Yeah, the last video he did. Yeah, with this guy on it. Anyways, I never reached out to him. I never commented on him because, sure, it's obvious why, right? But I don't know what got into me the other day, so I commented on his YouTube page. I go, I'll get right to the point. Most people think you're a shill.
Wait, who is this to?
This is to Eric Dubay.
You wrote it, so you think he's going to see it though?
Well, he did, and he responded.
Okay, cool. Okay, let's hear it. Awesome.
Yeah. So I write to him. I'll get down to the point. Everybody thinks you're a shill. Would you like an opportunity to clear it up? We can do a hangout if you wish. So he responds, well, I already done it. Thanks anyways. And he sent me like a video. I didn't even watch it, where apparently he went through people accusing him of being a shill.
It's definitely more the other way around. He has a page where he calls everyone in Flat Earth a shill.
I know. I know.
And he's the only one that had product out at the time.
By the way, I just looked it up. Yeah, the guy's name was Charles Johnson, who was president.
The original guy.
Yeah, the International Flat Earth Research Society. And I guess he died. It looks like he started it in 1972, but then he died in 2001. So I guess Eric Dubay is kind of carrying it on from him. I actually don't think Eric Dubay is like an actual agent in that sense. I'd never have thought he actually is. He does seem to have let's just say, a unique kind of personality characteristic going on with him that seems to kind of drive his whole like psyche. But I think he is just when I say civilian, meaning like if we're going to talk about like agents or non-agent, to me it's okay. The idea that obviously there's a group of entities that are sort of behind the Federal Reserve and big, all this stuff, the governments, the big oil, the space agencies, big pharma, et cetera. Whatever that kind of cabal or group or whatever it may be. So there's like that, and then there's everyone else who essentially if we were going to use the term like civilian, just in that sense, like we were all just born, we went to some school, we did our thing, we have just lived our lives, not in that kind of network. So I mean, in terms of that, yeah, I don't think Eric Dubé is in that any of those networks or anything. Like I don't think he is part of that Illuminati, whatever you want to call it, type of network. I think he is just a civilian guy. But he does seem to have like a very intense kind of psychology structure in which he needs to call everyone else shills. And then he has kind of, he sets himself aside from everyone else. And he kind of wants to be like the ultimate flat earther or something. And he doesn't really want to actually interact with the community. It's like he wants to be the king of flat earth or something, but nobody really deemed him king. So it's just like self-assumed. And then he just kind of assumes that position and then kind of sometimes lashes out at people that don't, treat him that way. And then he doesn't seem to really want to interact with the rest of us.
He thinks he's fucking like the true fucking OG of flat earth and that he's too much of an OG to interact with new people to the subject. And that even to the old, more like people, he thinks even they should pay him homage and shit. He thinks he's like the one who fucking brought it to us and shit. So I know it's
I will say he kind of did, though. I will say he kind of did.
And he does respond. He does respond to people.
He played a big role. I will say that. Because basically, like what he did, I mean, I think he is like, I don't think he, okay, well, everyone just has their role in the world. But I mean, Math Powerland was doing some stuff. It was starting to kind of bubble up a very little bit, but there wasn't really any like content producers yet. And Eric was one of the first that was like, yo, I'm doing this. And the thing is with him too, is that he had researched, like he knew about Robotham and a lot of these older writings as well. Like he found those and got, like anyone found, gets into something, you start researching it. So he kind of found that, researched it, got, looked into it all. And then he came to his own conclusion that it's not a globe and everything. Because I've heard him share the whole story and it did seem authentic, like when I listened to him. So I don't have any reason to not believe that the way he told that was a legit, his.
I don't think he's a show. I think he's he's a guy with a big ego, basically.
Yeah, I would agree.
Like he does have the accolades, right? He is a OG, but like being an OG doesn't mean that you're some sort of fucking god that just like disappears into another universe and looks down upon everyone else.
Yeah. Yeah, dude. Because he has never interacted with like. Yeah, you think it's because it's like he's more OG and he doesn't want to talk to the new people.
It also might be he might be into that meditation shit, so it might even be like it might be some other shit like he doesn't like to interact with electronics for, you know what I mean? Like there's other factors that might not even be related at all to why he doesn't interact, like just not enough time.
Yeah, I don't know how much he does.
Time to dress as a woman. You see the one there where he dressed as a different women and different characters.
That doesn't make you chill though. That just because literally, like, I have guys from high school that I know that like literally they bullied him and then fucking made him dress up and then took a video of him, bro. It's so funny, but he's not a government shill. He's just this kid that I went to high school with,
Well, it didn't look like anybody beat him up. It looked like it was voluntary.
I drink piss.
He probably lost a bet, dude.
The thing is, he never comes around and we never seen him, talk to him. So I really can't really make anything out of him. I never spoke to the guy.
Dude, pee drinker. Hell yeah. It's a good night when pee drinker shows up.
Pee drinker. Bro, you remember that shit, Gio?
Dude, that guy just came back in. Yeah, I
Is that him?
It's the same guy, yeah.
Bro, do you remember him though when he was in RV laying down and then like he literally put like a jar below the camera and then it came back up, bro, and then he
fucking classic, dog.
No, because Brian Leakey was like, I don't believe you. I don't believe you. And he's like, he did it. Like, oh
Bro,
my
that was, I don't know if that was actually that.
I remember that, man. Bro, if you don't believe something, it's not the end of the world to call somebody out. Like half of my friends, I called them out at first, and they gave me explanations. I apologized and moved on, bro. It's nothing. People don't call each other out. And every now and then you get somebody who responds like, fuck off. And it's just unsalvageable beyond that point. But usually, bro, if people have called me out and I don't hate them for it. I'll just either explain or fucking confess, whatever. I had to call the guy out. I thought he was bullshitting.
If he ain't from the piss drinker society, fuck him. A real
right.
piss drinker would be a member
He's
of
not an official urine therapy specialist. I don't really.
member of the piss drinker
Oh,
society.
to me, he sounded like a troll, dude. He sounded like he was like trying to get somebody to drink piss to laugh.
Oh
Like,
yeah,
you
he's a
dumbass,
troll.
you
for sure.
fucking like you dumbass, you fucking drink piss. I don't really drink piss. I was a troll. I thought he was trolling, trying to get somebody to drink piss, dude. But he sure enough fucking went and got him a big old mason jar full of something yellow.
Yeah, dude. I mean, urine therapy has been done since the dawn of time, and it's an elixir in certain ways, and has various healing qualities to it.
I've heard about it, bro, but I just wouldn't. That's not how I would introduce myself. You follow me? Like if you did that for health, that's fine. It just like I wouldn't. That wouldn't be my way in the room, bro. Hey, I'm Brian. I'm a fish. Hey, I'm Brian. I'm a fish drinker.
Yeah, no,
You know
he's
what I'm saying?
completely trolling. Yeah, he's just full blown trolling when he does that. But yeah,
I'll piss on him. That's what I say. It's my form of urine therapy. Makes me feel better. Piss on somebody.
But yeah, in terms of
I apologize to him, bro. I apologize to him because he wasn't fucking lying, bro. He was honest to God, dude. He called my shit. He called my call.
Nice.
Or did he just go get a jar of lemonade or something?
Alpha juice.
So we were talking about Eric Dubé. In terms of Eric Dubé, I guess the question I would have is if there was like a new dawn in terms of something new that's occurring in terms of like this whole community and the interaction with the larger, the world at large, would Eric Dubé want to be a part of it or not? Like, would he be able to kind of put down the differences and actually, come through and actually share his information?
Maybe he's the type of guy like look at himself in a certain way where he's like, anything that I did or like these guys do is because I caused the initial spark, and he's like, I'm done. I did my work already, like these guys can take it. I already released my videos. Like you know what I mean? It's almost like he did his shit, and now like, because he is an OG, you know what I mean? He paved the way in a lot of ways. So like, in a way, it's almost like if you became the heavyweight champion of boxing, would you keep boxing or would you just like retire with your undefeated belt and title?
Yeah, well, that's interesting. Yeah, whether he would see it that way. He could. I mean, because I think he was like in the right place at the right time. Like he basically came across like Robotham and a lot of those early writings, and when I heard him describe his journey with it, it does seem like he authentically figured this out, and then he was just ready to make content, And he even says that he kind of waited till the right time, like he knew that he was gonna kind of spark something, and so he like waited until he felt like he could get it all out without like being suppressed. It's kind of interesting to hear him tell the story, but. So yeah, I think he is authentic in that way, and he is really good at like compiling a lot of those early writings and
well spoken. And Gio,
Yeah.
oh yeah, man. I mentioned I almost forgot, dude. But because I'm always trying to get more and more people in here and everything. I hope everybody's doing that. But I mentioned when I was talking about Ryan, because I've never talked to him personally. He seemed like a cool dude. And he debated McToon, and McToon was like reaming him on a subject that he knew he wasn't real familiar with, because none of us really works except a couple people, but about the spherical excess. And so I mentioned that, and I said, Ryan, if you're listening, brother, man, or anybody else, come join us, and we discuss the topic over Earth Awakening's Discord. So everybody needs to do that, man. Y'all keep doing that, because it seems to be growing slowly but surely. But man, a lot of these people probably don't even know this fucking place exists. It's I know there was a long time before I knew it existed. I joined immediately when I heard about it, but I went and I'm all over the place, and I didn't hear about this place for probably 6-7 months, man. So we got to get it out there and share it.
This server? No, I'm pretty sure you joined right away on this one. Is that what you're talking about?
Are you sure about that?
Yeah, dude, because we were all on Brandon's and
yeah.
I'll join the same day. Most of us.
Okay, good. All right. Well, still share. Tip of the spear, man.
Well, let's see. Okay, it says that you joined the server. It says if I just click on your account, it says when people join. You joined October 18th, 2021. So that actually is like 2 months after we launched. So yeah, that is some time. That's interesting. So were you not around for a while, or?
No, I was everywhere. I just didn't hear. I've joined the second I heard about it, bro. I swear.
Yeah, so it was a few months after, because we launched it in like the end of September, and then yours is October 18th, so like a month and a half roughly after. Huh.
I heard you mention it, Brian. That was cool. You
man, wait a minute.
So who did you mention it to? Who was that? Who was it that you mentioned it to, Brian?
Well, I just mentioned it on Modern Day Debates, man. I specifically said to Ryan or anybody else, but I try to mention it anytime I go other places, and they don't mind, just telling you where we hang out, where we talk.
Nice, dude. So you gave us a shout out on the debate. That's awesome. Thanks.
Absolutely, brother. No problem. I'm recommending everybody do that everywhere we go, and the discussion grows.
Your opening presentation was really good, Brian.
Yeah, I tried to cram as much. You see how he cut me off at the end, bro? Because he's seen where I was going with it. And I was bringing up McToon. He's seen that I already bashed PhD Tony with throwing in I was like, he should have did the math. Why didn't he show this entire picture? And then I showed the entire picture. I said, oh, there's why. Because of the diverging shadows. So maybe he should have done the math. I was like, in before his humiliation last night against Austin. Then I threw a shot on Mark, how he showed the parallel star trails, and then in reality we'd see this, and then my last bash was against MC Toon bashing Ryan, and that's the one I really wanted to get out there because I didn't like the way he treated Ryan. Like he treated him. Ryan was cool and laid back, and McToon just really, was just a dick for no reason, man. And so I wanted to give him a shout out, but MC2 or I want to say that James seen where I was going with it, and he cut off the very end, bro. He cut me off, but it was still pretty good. I crammed in as much as I could in 6.5 minutes. Thank you, Dan.
It was interesting because he's being overwhelmed with feedback, and he was getting a lot of super chats, and I could tell he's disinterested in the subject, and that allows him to be a good moderator. But he's completely disinterested. It's funny. He just tries to sit through it and get through it, and it's too popular. Like it does really well. And he was saying, like, who'd have known, on a religious format that it was going to end up being so much flat earth stuff. But he welcomes it. And yeah, I mean, I think you could create more stuff, a wider audience through that too. Whatever that audience is, it's definitely not ours,
Yeah, he's a nice guy and all, but he's the worst moderator, bro. I mean, the worst.
No, the worst.
Do you agree?
No,
that moderates me every time, bro. I'll give him that. He's on top of it when it comes to me. But that's cool. I still say he's cool, man. He lets us. Hey, he gives us a voice. I'll end it there.
Yeah, that's it. I think he's disinterested in the flat Earth subject. I think his ears are closed.
No, but he doesn't moderate. The only guy I've ever seen him moderate was Brian, I guess. Now that you're saying it, but He doesn't moderate. Or do I miss it? Because every time I go on there, they're always shouting back at each other, and there's no moderation. Very
He
rarely
moderates a
we're.
little bit, bro. He does sit back a little bit, man. He's a little bit biased, but like I said, he gives us a voice. So I'll keep him. You know, I'll keep him on my good side, bro. Not many people are doing that lately, man. You know, my last video got 30,000 views. My last debate on there. So I'm like, shit, I'm not getting that kind of views anywhere else. So, you know.
Well, good on you, man. No, I'm not. Like, I'm not saying it's. Well, I did say he's the worst, so I can't take that back. But yeah, it is what it is, man. I mean, yeah. Sorry.
Hey, but I'll tell you what, though, man. Oh man, I forgot what I was gonna say. With the oh yeah, somebody super chatted and it's the first time I was wondering. I can't believe it took this long to come, but somebody super chatted and said, "Why are you even hosting these flat Earth debates? It's a waste of time." Blah blah blah. And dude, yeah, because your globe is getting its ass torn in half. These last, let's say, few months worth of debates, bro, the globe has been getting handled, bro. I mean, I can see when flat Earth. I got a bias, obviously, but I can see when flat earthers don't win a debate. And lately, the globe, they have not been winning debates, bro. Not over there.
Ever since Bryant Myers, right? Ever since that one, it's been
How could
like
you lose a debate
by having too much
as a
bias
flat earther with
and
physics?
losing track of the subject by bringing all your crap. That's
Oh, all you got to do is say conservation of momentum. Show me everywhere. Show me everywhere with every kind of object that would show it. Any kind of spherical object, any kind of bike tire that would spin. Lift it up in the air, hold it still, touch it to the ground, and let's watch it spin. Conservation of momentum. If the earth is moving, it'll carry out to the tire. If the earth isn't moving, it won't carry out to the tire. Welcome to Flat Earth, motherfuckers. Just force their claims. Force for the conservation of momentum to be shown by the earth, which is supposedly demonstrating conservation of momentum, but it doesn't. Clearly.
What does it mean when they say that, Tim?
It means conserving something that's moving. It means conserve or conserve the potential put into something. So if I smack your hand and it moves, right? Action and reaction is all it means. Conservation of momentum is nothing more than action and it's nothing more than action or reaction, if you ask me. But
is it the things that say things that are in motion stay in motion? Is that what they mean?
Well, no, I've never seen something have to stay in motion. I just say it's the transference of momentum until the momentum isn't carried out, right? So therefore not staying in motion. Because if it stays in motion, then the little beads on your desk would never stop moving. It would be perpetual motion. Conservation of momentum means perpetual motion.
Mm-hmm.
We don't have that, right?
Picture a bird, an eagle, taking off and grabbing a mouse on the ground. As he lifts off with it, right? Eventually he's going to let it go. But as the bird is flying, when he lets it go, it keeps on that trajectory for a little bit. That's the conservation of momentum. That forward momentum given to it by the bird. So they think that happens all the time. Like he just said, perpetual motion, fantasy.
What's inertia?
Yeah, if you're standing on a ball that's moving, that's a huge ball, 24,901 miles. We got gears and ratios. We know the fucking specs, right? You have math, you have engineering. So this big ball, if you put a little cog wheel, your wheel of your tire against it, your tires should be going how many times the fucking RPM of 1,000? If you got a big thing spinning the little thing's going to spin a lot more, right? The big thing's going to go slow and the little thing's going to be turning a lot, like turn, 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 turn. So your tire or a bike tire or any object, a baseball, a beach ball, a basketball, you sit it on the ground, you're holding it still. You're fighting gravity or whatever that is. You're fighting the conservation of momentum right now with your hand. You're holding on to it. You let it go. It touches the ground on its own. Now it should start rolling. If the ground is moving, a moving ball, any moving ball I get in any kind of lab or outside, if it's spinning and I touch the other thing to it, it starts moving.
It's not moving at a
So
great
if the
rate
earth,
where you're standing. It's not moving at a great rate where you're standing.
no, that didn't make any sense. Listen to what I said carefully. Any ball you get, any ball you get that's moving, you go get another object that's not moving, you have it in your fingers, you bring it to it, let it go on that object. Now, if it doesn't move, I'll kiss your ass. The big ball is going to spin the one that wasn't moving every single time, unless you got some kind of weird physics that you can demonstrate to me where it doesn't happen. Then you can say Earth. But you have to demonstrate it before you can declare Earth does it. That's what Kosho always does. That's what they always do. They keep saying water moving. That means Earth's moving. No, it doesn't. You got to stop the Earth from moving, then start it back up and see the difference. If you can't stop the Earth, then, and they say they want to weigh the Earth. You can't weigh something that's spinning or moving. If you start moving around and I put a scale on your head and you're walking and moving and jumping and moving and spinning, you're not, it's not going to weigh right. You're not going to be able to weigh a bag of weed right.
Hey,
You're not
Dan.
going to weigh grandma's biscuits.
Tim, check this out. Let's say that we make a balloon, a floating balloon, weighted so it's at RI height. It doesn't go up or down, right? It's what do they call that?
Hovering.
They use it in submarines.
Anti-gravity.
No, when it's buoyant. You know, it's not buoyant or not. But anyway,
No,
equilibrium. It's at
so
equilibrium.
hold on a
okay?
second.
No, hang on.
So where's buoyancy in space?
Hang on, Tim. Listen.
I know, but you're not hanging on.
No, I'm
Where's
trying
buoyancy
to.
in space?
I came to an epiphany.
Okay.
If we suspend a balloon between us, right, in this equilibrium, and we go into a tiny shelter like a storage unit, and we shelter it from all wind, and there's nothing touching it, there's no way it could stay in place. It should have to hit the wall.
I know, and it should also hang diagonal if it is tied to the ground.
But so
you should have diagonal ones too.
We can prove that there's no effect, that the Earth is
That's
not.
my
having
helium
an
plum
effect.
you just described. Yeah, you get the tube,
not having
and
an
it's got
effect
to
on the
touch.
air.
Yes, movement or otherwise.
We need to prove that the Earth is not having an effect on the air.
Exactly. You can sit it in the tube, which would be the shed. The shed could be the tube. You could make the walls clear. We could all stand and look at it forever. You could put a camera on there forever, put it on live, and the balloon will never move left, right, north, south, east, or west.
It has to on a globe. It has to on a globe.
Right. 100%. I'm with you. That's my idea. It's called the helium tube. Yeah, because that's what I was looking for. Divergence from perfect vertical. Anything other than perfect vertical is what I'm looking for. I want the helium balloon to touch the fucking side. If it touches the side, globe.
We should be able to prove that there's nothing in terms of friction or drag happening. We should be able to prove that.
Right.
Huh.
I've been saying this for years. When they kept saying why helium balloon and everybody wants it, because you can put a tube around it. You're not going to have it in the wind. That'd be silly.
Yeah, and then so all we got to prove is that the non-connection to the floor is also not propelling it in any way. That seems doable. It's not very dramatic. Damn, you know what's dramatic? You know what's dramatic that I need from you really bad?
Truth.
No, I need to put you in the globe this year. and run around with you. I need to do it. Need to
Well,
go back.
you got to get it set up then.
You
As
gotta go
fast as
back
you
to
get
the
it set
old.
up, and
All right.
huh?
You got to go back to the old dem of being funny though. Got to go back to being funny. You know, I think that's going to get to more people than anything else you can do. I think we can get your ass on TV that way. I'll work on it, okay?
Yeah.
Do you have any days off when we could work on it, or when you might want to start running that? If we start to pick a day, like Saturday or Sunday or something.
It just depends.
All right. Gio, are you there?
Yep. Yeah, I'm here.
We had this idea to put Dem inside, like on a cell phone inside a globe, and I'd walk around with it like a ventriloquist, and I could walk around arguing with the globe, and then when people come up, he'd be able to see them if I put the phone right and start arguing with them as the angry Earth, you know, as the pissed off Earth, you know.
Yeah.
And it's like his voice is really good. I just got to get it to project and get him to be able to see so he can respond to them. And
well, that would be an interesting. Yeah, I'm kind of thinking of a couple ways. That'd be like an interesting like installation where you could have like a globe, and then it would like have like a mouth on it. It would talk to you, and you could like debate it or ask it questions, and then like it could be Democ's voice. Like either it could be Democ being pro globe. It'd be funnier if Democ was just ripping the globe to shreds. So like you go and debate the globe, and then the globe just debunks itself.
it's a real great thing, and I could march around the line at the Jimmy Kimmel show, and I think there'd be rumored, you know, that I was out there, and I might be able to get on the show with him.
Oh my god, dude! Well, there you go, dude. See if you can get on.
It's like Triumph the Insult Globe, basically, is what it is.
Oh right. Oh right. It would be in that category, and that's funny, dude. Yeah. That character was fairly funny. I thought it could have been funnier, the insult dog thing, but I think when it first came out, what is it? Triumph of the Insult Dog? Is that what it's called?
Yeah.
Yeah, it was funny for a while. There were some funny ones.
I like you to poop on. To poop on. Yeah, he had a limited amount of jokes, but that guy's Robert Smigel's incredibly funny. Pretty sure that's who that is.
Yeah.
So I've got Nick the NASA pimp, and then I'll have the talking globe, and me in the lab coat. And I hate to say it, but that goofy shit opens up more conversation than math or the Bible. Laughter helps. And music does a great job. So I'm surprised we haven't heard a little bit more about people coming around because of the music. There's been a lot of good music out there. A lot.
But I recently met someone who had was pretty awakened by the whole scamdemic thing. So like she had quite a you know, just questioning things more and having kind of more of a mindset of like, well, I wouldn't be surprised of anything at this point. Like, what else, could be false or a deception that, previously we thought was true. And she had seen like one like flat earth type video like years ago, but she said it was like overly, she just said it wasn't really very like well done. I was trying to ask her which one it was, but she couldn't really tell me what it was. It sounded like some like longer podcast of some sort, and it wasn't really going over the basics or anything like that. It wasn't like an ODD 21 questions or something where you get, just a download in a short amount of time, or one of Eric Dubé's like intro. The Eric Dubé one that's really, really good is the history of flat earth. That one is a very good little presentation going through, the whole topic of the earth and going to the ancient cultures and et cetera as well. Like it starts with that. But anyways, and like basically she is just completely open-minded to that the earth could not be a globe, but just has not come to a conclusion yet on it. So it's interesting to think how many people are in that boat at this point. Way more than I think there were years ago. To where in some cases, all they may need is like 10 or 20 very solid things and then their own awareness, and it's going to click. But I still don't think I think there's still be people that won't fully click for it. That's why we have to actually validate it. We have to prove it physically. Have a definitive measurement, because even telling people this information, the globe, it's too strong of a mind control, at least for now, for some people, that it seems like they won't be able to break out of it on their own, or even no matter how much people talk to them or how much they read or anything.
We're definitely going to have a whole new batch of people here real quick. This TikTok shit and everyone refining what we do down to smaller bites is going to be a big deal. Because people think in shorter bursts than 5-hour talks. This whole thing about shorts and clips and, the short attention span is we definitely have just monumental amounts of content in those short bursts. I guess somebody should just come up with Flat Earth Shit Show. That way the audience can get what they want. That's what the audience wants. The Glober audience, anyway.
Yep, that's their entire goal, is to keep it a shit show, because if you keep it a shit show, it'll never be taken seriously and the truth gets buried. So people against the truth are diligently working, it seems, to always keep this an irrelevant, chaotic, immature, dumpster fire, unprofessional, unappealing. I mean, to most people. I guess there are some kind of. I mean, there is like some entertainment value, because it can be funny and stuff, and it can be kind of wild. I mean, I think we've all at some point at least gleaned some entertainment from a dumpster fire, from a shit show.
What's this, Rakia? I don't know what that is.
It looks cool, whatever it is.
Rakia found Atlantis.
Yeah, it's got to be ocean-based, right? It looks like there's water, a coastline on the top, and a reef line on the bottom. Almost. I don't know. The scratches look too perfectly scratched to me, like it's artificial. I think this is meant to look old.
Looks like that thing we used to put in, what was it, the 45s? The little plastic thing in the middle of the record there.
The spindle
I'm showing
thingy?
my age now.
Definitely.
Remember those?
The spindle? Yeah.
Yeah.
Yeah, the little plastic clip thing, yeah.
Yeah.
I think that's a coincidence, though. Have you ever seen the footage that makes it look like JFK's driver shot him? And it's just a coincidence of light. But damn, does it look like he pulls a 45 and shoots Kennedy? It really does. All right, we give up, Rakia. It's not Bikini Island. Circle's too perfect to be anything. There's an inner circle. I don't know. It looks like a bunch of nothing. Oh, look at
Looks
that.
fake. Those circles are too perfect, if you ask me. That's a giveaway right there.
Look at this. Ah, with space in the distance. Good one. What continent is this? Chicxulub crater.
Of course, 65 million. Yeah, of course, they know exactly the date, too. I think it was February 23rd.
It's weird because there was another one. 66. But there really isn't stars on the moon in this shot. So what are we really seeing here? It's an artist depiction anyway.
Sure looks like a flat image of something hitting something flat to me. I don't even see how you could hit a round thing being a meteorite, being that big, and like something spinning that's around and you hit it and not leave a streak or a slide mark or something. Like, no way. There's no way you're gonna hit it direct like that.
You're seeing the explosion though. You're not seeing the object. You're seeing the blast. Crazy.
Yeah, it looks pretty flat.
But it's not the size of it. Oh, I see what you're saying. The crater itself.
Yeah, just everything about And anytime they should, like even the Piri Reis map, how you got all that on one map on one flat surface of a map? How would you even be able to do that right if it like was supposed to fit a round map and that's like the correct thing? I'm not getting it.
Oh no, this ain't a picture though.
No, I know, but I'm talking about like the dude who draws a map and it's supposed to be accurate from the 1800s, the 1700s till now, before anybody knew anything and had everything perfect in Antarctica? Come on, man. On a flat piece of paper, just fine. Kind of weird, right? You remember all those ones Pancho had, right? All those maps?
Mm-hmm.
Yeah, well, my question to everyone is how can you fit all the continents on one side of a globe? How? How can you fit all the continents on a UN map when that's not the map, when that's not the globe? That like the size and the way you like that doesn't, does that make sense to anybody? So the thing that they would fit on is 24,901 being in the whole thing in its entirety. Now they can fit on a flat piece of it, like a quarter. That doesn't make any sense to me.
These crater pictures are still interesting.
Yeah, they look cool.
They're similar, certainly similar enough topography to make it believe that they're both photos, but I don't like one's
Those
not.
circles are so perfect that it would have to be like a direct, like a direct hit, like straight dead on. Like if it was a dive, he'd get a 10 out of 10, no splash. Like it's, yeah.
So the top one carries the cloud structure the same. Like the top one is a variation of the bottom one with the stuff in the middle where we were talking about the spindle being added, looks like. That's what's weird.
Rakia's got it right. It looks like something could have happened from underneath. That's what I think. That's right, exactly, Rakia. Some water or something, some gas bubbling up or something. Yeah. Sonic is still muted.
I saw when he joined. He was. So it must have been from earlier.
Jeremy put him on timeout the whole day, so I guess it's 12:30. God help me. I guess his punishment is officially over.
Zanuck, man, you're causing a lot of hassle for poor Jeremy. Oh man, I hear about it, and I hear it. Yeah, was it warranted? I see.
Well, he kind of deserved it. He cut Jeremy off like 5-6 times, and he did warn him a few times. So,
Okay, what can we do to improve this? So this is a thing that happens. Okay, it seems to me like this is my kind of, and I've said this before as well, but if there's a heated conversation, like you and I, Essie, I am sure you and I could have a heated conversation without interrupting each other because we would just let each other go. Even if you interrupted me, I would just stop, or if I interrupted you, you would stop, or whatever it may be. We would just figure it out. We'd be fine. But some people can't do that, it seems. And when they start going, they go from that like organic back and forth, little questions back and forth, whatever, where everything's fine. They go from that all of a sudden into interrupting mode to where they're just jumping in to try to clarify or whatever they're trying to do. And now it's an interruption. Like a minute ago it was an interruption, and now it is an interruption. And then from there, it goes into all the chaos. If there's any like personal attacks or condescending, any of that shit, it sends it off the rails. Or if it's, somebody's explaining their idea and the other person doesn't feel like they're answering their question correctly. So then they say, no, you have to answer it. Whereas the person, then they feel interrupted. So sorry for being long-winded, but I mean, what are your thoughts on like possible ways that we could improve that? Because the other way to do it is to make it a little less organic and have it be like, 30 seconds each, or the list thing. Well, because when we do the list, there's none of those problems because whoever's on the list, everybody knows not to interrupt that person. Like they're at the center of the stage and then the next guy's on the list, So it has more of like it's less organic, but everybody's listening to that one person speaking. And those have been some of the most like great to listen to when, because then like there's no interruptions. You can hear everything everyone's saying. So, I mean, we don't have to go to a whole long discussion on moderation. We're going to have a mod meeting soon and go through a lot of this as well. But I just wondered, like, just since it got brought up a little bit, like, there's options to it, right? improve this because we're all spending our time here. We want the experience to be good for everybody ultimately.
yeah. Well, this is the way I see it. But there's like, I call it the dirty dozen, right? Everybody knows who I'm talking about without me mentioning any names. There's certain people that just cannot control themselves, no matter what. So it seems that the only solution is to mute these people. When there's a heated debate, I guess the list thing, what Jeremy came up with, I guess that's pretty good. But I really don't like it for it to come like that. People should just be able to talk back and forth, but unfortunately, it just doesn't happen that way sometimes, I think they have to be muted. That's it. They have to be warned once, twice, and then just muted for as long as it takes. Or what I really like is the 5 minute, the one I call it call 5 or call 10, right? There's 20 people in the room. Everybody wants to talk at the same time, but 2 people want to hash it out, and everybody keeps interrupting. So I think right there, the solution could be like 2 people, let's say me and somebody else, or you and somebody else, 10 minutes, nobody interrupts. And then the next guy could come in or whatever, there's different solutions. But the trolls have to be controlled. That's number one.
The trolls need to be fucking stomped on.
Yeah.
And I'm not talking like trolls as in people who are in VC that are like contributing. I'm talking about there's just people who literally come to Discord. This is just a general thing of Discord where there are people who come with no intent of having any discussion and only pissing other people off as like their way of getting their satisfaction or some shit.
Yeah, like
Yeah,
that's
and we
their
all know
whole,
who these people are. You know,
that's their whole MO. Yeah, like they're not even coming for any real interaction or discussion or presentations or anything. Like, yeah, they're only coming for that. Yeah, there are some that seem to be on that.
like let's say two people are talking or three people, and we hear like one guy moaning in the background, like some guy was making noises yesterday. Instant mute. You're out. You're out for a couple hours. That's it, and they'll learn
Yeah, that's
eventually. Yeah.
yeah, that's goopy stuff right there, making weird, like doing weird stuff. I can understand like people like stuff going on in the background and you accidentally just hear stuff. That's one thing, but for people to be doing, just purposely doing weird shit in the back, yeah, no way. And I do like conversation, just to make sure everybody knows. I'm not one of the people that come to just spite. Sometimes it might sound like that because of the conversation. But trust me, I want to get to a point or have an actual discussion or find stuff out. You know what I mean? I actually want to figure it out.
No, you're good. You're a smart dude. Just sometimes you go on these trips. But yeah, you got good info in your head, man.
You as well. You as well. Same.
Thanks.
Well,
I like the way we.
Well, it's interesting how rare it is to know a lot of this information. So, in a sense, we're like a pretty rare group, in a sense, to have. I mentioned Odysee. I met some this person the other day, and they were like new to a lot of this, and like, she knew how complex this whole topic is, and like in her mind, like it's like incredible to her how much complexity and how much information is within the entire topic, not only of the Earth, but yeah, just cosmology and even beyond as well, because what that represents as well. I mean, we're a unique group. Like, think someday if there was like a big like nationally syndicated radio show, or if we were being talking to 50,000 people, 100,000 people, like that's the thing. Like, I'm gonna say like we are experts in a sense. When I say we, I'm not just talking about me or any individual person. Just in general, like a lot of people in this community are very, very knowledgeable on these topics, to where it's like the top in the world of the people who know this information.
Yeah, we're definitely a unique group. That's for sure. Yeah.
And a lot of weird information too. Like when we first got into it, man, you had to go over cameras, videos, like all this other stuff, the eyeball, like everything, man. It was just crazy. And then we're where we are right now.
Well, it's also kind of funny because like you would expect like a ragtag group of random people on the internet to be the most savage, and you would expect like professional individuals to be the type that act a certain accord. But I mean, after Witsit's debate the other night, dude, like PhD Tony definitely proved the opposite.
That guy unraveled, didn't he?
Yeah, that was.
It was good.
Have you guys heard him unravel sometimes when I just say?
Think about how it looked, dude. It was like a chill, cool dude sitting there, easily refuting all the points coming at him. And on the other side, it was like this bald guy just yelling at the top of his head, calling names, interrupting, insulting someone's child. It was just like, wow, like he really got exposed.
One time I mentioned one word, and I knew it was going to trigger whoever, Highlander or somebody. I said, well, two words, but one phrase, horizontal elevation. And that guy went off for like 30 minutes.
The funny thing is that Austin turned that Professor Tony guy, whatever his name was, into the exact meme that we've been playing with AI images. To just put it,
It's almost as it was put out into the ether and created as a reality.
Yeah,
Yo,
because
Dan, that's so true.
he looked just like that. His mouth was open, his arms were up, he was animated. He couldn't believe he was stuck in that conversation.
It's
He
really
didn't,
I
he,
mean,
listen, he didn't
if you
anticipate. He did not anticipate anybody coming from the flat Earth side to be anywhere near as prepared or as calm as Wizard was. He devastated that Tony guy. He should get another PhD in creating flat earthers. You feel me?
Dude, that was just great, though. Like, just think about it. Like, you would never expect a ragtag group of guys on the internet to have better etiquette and behavior than a PhD. It doesn't
Yeah.
make any sense.
Yeah, Whitsitt had a higher level of professionalism than a PhD. Yep. He absolutely
asked us
conducted
something,
himself like
bro.
he conducted himself in a much more like grounded, stable, like yeah, just more of like a civil and professional, approach to it.
sounds like Tony was a PH disappointment.
Yeah, pretty heavy disappointment. The PhD.
Oh, it's a little globe comedy. I'm sorry.
Look at them side by side in this picture. Just look at how when they say a picture's worth 1,000 words, it really just hits home when you see the comfort level Austin has and the panic in this guy.
Yep, that's what it is.
When you say words they don't like it, you're like
Isn't ignorance
conservation.
bliss? They say that.
Words.
Zanuck coming in with the right hook.
Right?
The Randall right hook.
Zanuck, if I say the
Swinging
word
for the fences.
After being muted all day, apparently Zanuck just comes in with a solid hook.
if I say the word word.
I didn't even hear what happened earlier, but I saw you were muted, so I figured there was.
No, I mean, I think Jeremy had
Bro,
his hands
so
go with
funny.
Whitsitt and SC and everybody
It
going
was
at it
so
about
funny, bro.
visual.
Like, everyone was over talking to each other all the time, and Zanuck was like one of the persons contributing.
I barely was in there for like one word.
No. One of those persons contributing to it was Zanuck, and everyone was over talking to each other, like 6 people. And then Jeremy started trying to get a hold of the room, and like everyone else stopped, and Zanuck just kept over talking, bro. And Jeremy was like,
I
"Are
really,
you serious,
truthfully, I
dude?"
couldn't
And
hear
he
him.
just kept
I didn't
on
hear him
going,
talk.
bro. And then Jeremy just
Hey, I'm talking. Stop talking over me.
He just pissed, but bro, see, he's doing it right now, dude.
I know I'm doing it to be a joke.
Fucking
It's funny.
hilarious.
Wake up. No, I didn't actually. To
It
tell you
was
the truth, I didn't.
fucking hilarious, bro. You should
Tell
have
you
seen.
the truth, would you let me talk? To tell you the truth, I didn't hear him. I really didn't hear him talking when he was trying to get control. Because when he did say that, I go, "Oh yeah, maybe I did hear him in the background," and I was still going. I feel bad, and he goes, "Forget that's it, Zanuck, you're gone." He goes, "You're done."
But Zanuck, how do you think when that's happening that everyone's gonna just quiet down for you to go? Like, why do you even think that's going to happen at that point? If it's already gone, if you've already initiated that whole thing,
I didn't really initiate. I was actually giving a response back, and then Whitsitt didn't like what I was saying.
Yeah, he didn't really initiate it, but he was contributing to it.
Yeah,
and then like everyone else stopped when Jeremy tried to get a hold of the room, bro. And you just heard like only Zanuck just consistently talking like loud and fast over Jeremy, and Jeremy getting so mad, bro. So
yeah, that was kind of funny, but I didn't hear him actually. To tell you the truth,
It was really a preemptive strike. Really, Zanuck wasn't being that bad.
Thank you.
Yeah, not as bad as I've seen worse. Is what.
Well, I think there's like a tension building. No, there's like a tension.
You were just Zanuck was just in the wrong place at the wrong time, over talking the wrong person. Like he thought he was over talking like me or someone else, but he was like consistently over talking Jeremy and didn't realize it. And it was so funny because everyone else knew that like Anyone who was talking was gonna get the mute, and fucking Zanuck was just obliviously, just loudly talking. It was so fun.
So back to the PhD guy. I don't think he was the most impressive candidate for that debate, even though I think he
I
seemed very
agree with you,
knowledgeable.
Zanuck.
What?
So
I
a
agree with that,
PhD
Zanuck.
guy. So a PhD guy wasn't the best candidate over just a regular random guy like you were. You like just like, hey Bob off the corner, are you busy right now? No, I'm not busy. You got a couple minutes? Okay, I'll come and talk. So the PhD guy wasn't as good as a representative. I just a random guy.
No, he called himself a flat Earth geologist or something.
Seismologist.
Seismologist.
Oh my
Yeah,
god.
Demok, we're in the day now where the PhD is actually not adequate. So he's not the guy for the job, apparently.
Right. That's the funniest part, right?
That's what Zanuck's saying, but it's also kind of true. I mean, yeah, they're probably. Well, that PhD Tony guy has some kind of. He seems to have a whole thing like for Witsit, and then he has a whole thing for Flat Earth. So like he's in his own like world with it. It seems to where he's like hyper activated about it to the point to
Flat
where
Earth
he could.
Tourette's.
Yeah, pretty much. Like, he couldn't really have a discussion of the actual information. It was just like constant eruption after eruption.
He melted down though with all that heat. It was pretty.
If this is the guy I'm thinking, you guys, this must be your first encounter with him, but it's not my first encounter with him. Rakia.
Oh no.
Rakia, is this the dude that went berserk one time?
Yes.
The flat Earth geologist?
No,
Seismologist.
PhD dude.
He has a PhD in seismology. But yeah, he's been around. Like, wasn't he? He was maybe on Gem server or something, or maybe he went to Bev once or something.
He's on gyms a lot.
Yeah, I figured. I thought.
Hey,
so.
Buster, are you there?
Yes,
Buster
sir.
will remember. You there, Buster?
Yeah.
Isn't this the dude that went berserks?
Yeah, it's PhD Tony.
Yeah, that's him, no?
He said, what was it he said? Something about, I can't remember the exact terminology he used, but like, if you think I'm like a lunatic, like my psychiatrist would agree.
Yeah, that's it. That's it.
Yeah.
If you think I'm crazy, my psychiatrist would agree. Like,
Yeah,
this guy's gone, man.
He said that. Like, that's like not quote unquote, but like paraphrased quote. Yeah.
Yeah, there's three of them that are weird like that. They get like Tourette's all of a sudden and you say one word. Like the Highlander dude, he's one.
Oh, you gotta hear this. Rakia, oh my god. Rakia, he had a convo with Rakia and he went crazy. 15 minutes. Like, we gotta find that one and put it out, Rakia. That was freaking funny. So trust me, this PhD dude, don't think like it's like a legit PhD dude guy. He's not all there.
Yeah, but like he said your flat earth geometry. It's like what is that?
Exactly.
Yeah, I mean, like I don't get what the catchphrases are. Like, why isn't just geometry? Why did he have to label it flat earth geometry?
Yeah, good question. What is flat earth geometry?
I don't know. It sounds like he's going off in his own mind and imagining his own shit and thinking, "Oh, this is how they see it. This must be how they see it." And then, like, basically, Strawman just punching at the fucking Strawman.
Well,
Bro, the guy was yelling for 15 minutes straight. Nah, like a madman, bro. Like a Brenda. He pulled a Brenda.
Well, it's just the fact that what do people use in reality? Like, what geometry do you use in reality?
There's only one.
Yeah, there's triangles, squares, and circles. There isn't other geometry. Like, what the fuck?
Yeah.
You think your geometry doesn't have a fucking square in it? It doesn't have a hexagon?
No, watch your mouth. This is just geometry of spheres, and that's it.
Yeah, I better not see a triangle around here. It better be circles and spheres only.
That's right, young man.
Yeah, that's right. Ricky has a point. This guy's qualified to teach your children. I'm not sure which recording it was.
Teach him what?
Man.
What's he going to teach him? How to go nuts?
Yeah.
Yeah, what? He's qualified to teach them. Like, what would you send your kids to learn from him? Like, fuck.
Well, I'll go crazy right now. You can talk to my psychiatrist. Like, okay, our kids are gonna learn great from that. Good job, PhD.
It's so absurd, isn't it? Fuck.
Yeah, a lot of these guys, we think they're, professionals and they're this and they're PhDs. Yeah. Mm-hmm. You look a little deeper and you might be surprised.
Well, yeah, even some of the people that frequent here, they're like, oh, yeah, like I'm a specialist on this subject. And then next thing you know, they're just double speaking back and forth across their own subject matter that they're supposedly, quote unquote, self-claimed experts, professionals in it, yet they can't even fucking explain it without double speaking. It's weird.
They'll try to correct you on stuff, and then when you say, "Okay, well, what are you in this situation? Like, are you one of those?" And they're like, "Well, I don't know." Then how are you correcting me on my incorrections if you don't know? And I don't see how how any of them can have math for anything or be liable to act like they're going to argue any point and they have no physics. Like when I asked for a physical attribute of conservation of momentum on the globe with liquid or a thing, and then Kosho says, well, the ocean. Something that's been there before I was born, it'll be there after I pass. I'm going to point to that thing that moves and say, Earth moving? Huh? This is what we're dealing with here, man.
It's pretty bad, dude. The other day, this guy was claiming that he was claiming that straightness is not the absence of curvature, and it's like, wait, so you're saying that if it's like, bro, it's some of these people really, I think they're just, there's a subset, obviously, like I said, that are just here to troll and just to wreak havoc and trigger people. But I think there's another subset of people who are just here to argue, and they don't care what point they're arguing. They don't even care if their argument has been thoroughly refuted and just looks like a mangy dog starving and dying, like their side of the argument. They don't really care. It just keeps going on like it's a remnant zombie that just never stops. Like they're just here to argue.
Sometimes I don't think they comprehend what you're trying to say. When they'll say the stuff about the straight and the curve and all this other thing, and they're like, well, no thing's perfectly straight. And I'm like, okay, microscopically, you might look at a ruler and see little jagged pieces like teeth, right? And they might be a quadrillionth of a gazillionth of a gazillionth of an inch. And unless you're way smaller than that, it would be a mountain to you, right? Like if you're like to you. But now, since you're big, your eyesight puts it together as a perfectly straight line. But no matter what you're trying to explain to me, that still doesn't mean curve. That's a perfectly jagged straight line that's going to go perfectly horizontal. So in that aspect, a horizontal jagged straight line or a horizontal jagged tooth line is still horizontal. But it's not a curve either. See what I'm saying when they talk about the imperfections? Well, no line's perfectly straight. Well, that's not even the point of the matter. The point of the matter is it's a horizontal plane versus non-spherical, right? We're not talking about the tiny imperfections like in your fingernail, you know. And that's what they'll say. They'll say it's just weird stuff, and they'll calculate that attribute of, okay, this ruler line or this ink pen line that you wrote on the paper, it's not microscopically perfectly straight if you magnify it. If you magnify it, there's imperfections. Okay, I'm down with that, but that doesn't mean globe, and they think it does for some weird reason. That's their gotcha. The ignorance of a gotcha from ignorance. Like the point they make about the misconception of the little imperfections, that's true. But you can't then say globe. You can't point at the ocean and say, well, the ocean's moving, conservation of momentum of the globe. If you can't go take a cup of water and see the same movement, then no. Then no, not at all. And an explanation for an hour is not going to help you either without that cup of water doing the same thing the ocean does.
Bro, the same guy that was arguing with me about straight not being the absence of curve or whatever. He was also saying some fucking ridiculous shit like the absence of something is not zero, and it's just like, what? Like if it's not there, it's zero. Like, bro, I don't know, dude. Sometimes like I really question like, am I like typing to a robot? Like, am I like, I don't even know, dude. It's crazy.
It just depends on where their comprehension is, like their formatted comprehension or their train of thoughts coming from, right? Their basis of thought, like, because you have some weird motherfuckers that like are they're in like different realms or the different dimension or in arbitrary realms or quantum mechanics, quantum physics, and the idea of thought, right? So just thinking the idea that I'm out of money doesn't mean zero. It doesn't mean the number zero. Maybe, I don't know. So just the way that people think shit, they're like, I'm 100% right when I think this. But they didn't think all the way about it. Have you ever had that happen? You wake up in the morning sometimes and you're like, man, I got this great idea. And then you're like, shit. Like maybe a day later, if you haven't told anybody yet, then you find out, oh man, well, there is an exception. Have you ever had that happen? Think you have a fool. After a while of thinking about it, you're like, oh shit, that wasn't so foolproof.
I hear you, Denmark.
That used to happen to me all the time, bro. That used to happen, like when I left a couple videos up, but like I was like, this test will fucking prove it for sure. Then I realized, wait a minute, it would, but we'd still have to resort to measuring the angles, which are what's impossible in the first place. Not impossible, but just pretty much, Yeah, that's happened to me plenty of times where I got an idea, and I'm like, that's it, dude, that's it. Why did I think of that before? Let me think it through, before I go fucking talking about it. Think it through, and you're like, well, damn, dude, I forgot about this and something like that. Man.
Right. Like
all
measuring the globe. Yeah, like measure the globe. Be like, oh man, that's the surefire way to do it. Fuck, there's no problem. And then you start thinking about it, and you're like, oh, that would be a slight. Or another person talks to you about it, and you're like, well, what about this? Did you think about that? And you're like, oh man, I didn't think about that. But for the most part, most people usually try to think about everything. That's not a down. You try to. You just sometimes you can't think of every single thing at that point in time that you're so happy.
That's the mode the Globers are stuck in. Like they think about what would kill a flat Earth, and except for they don't come to the realization like we do. We think it through, not always, but 99 out of 100, we'll think it through and discuss it and shit, and then be like, okay, and pretty much quit using it as a proof or something. And they just hang on to shit and forget you even had the discussion and claim that it couldn't possibly work on a flat Earth the fucking next day. Even though, we showed them about every other month. We'll show them a few different ways it could happen, and a couple months later they're just right back at it again. Like this could never work on a flat Earth, motherfucker. We just went over this shit fucking a month ago, bro.
That's the idiocracy that we're dealing with.
Honestly, if there were new people, it wouldn't be that frustrating. But it's the fact that it's literally the same people the next day who are acting like you never had the conversation before. Like, I don't know.
This is
The funniest thing is, it's a flat screen they present their stuff. Flat chalkboard that the teacher presents to you. Flat paper to do any drawing renderings of art. Like, I don't know any point in time that anyone could ever tell me it's impossible to do or draw or present something to you on a flat graph.
Here's what they
'Cause
do, man.
that's all I've ever seen. I've never seen the
Here's
round
what they
ones.
do, D-Mop. They use like the globe, the geometry. They use like refraction and all these variables, right? And try and pin us down to just flat trig. Like all we can use is just baseline trigonometry when fucking y'all got all these explanations and variables and fucking, you know what I'm saying? And try and pin us down to
Yeah.
just baseline trigonometry. It's fucking ridiculous, dude.
Well, take the picture that they give you and say, what shape is that picture? Take the shape of the paper that they're doing the trig on. Say, what shape is it? What shape is the format or the basis surface of that paper you're writing your trig on? What shape is the picture that the camera took and you printed out to me? That's a flat ass picture, right?
Yeah.
What shape is the map? Everything that they bring to you is done on a flat format base.
Their globe is done on a flat base. Their globe is 2-dimensional, bro. You know what I'm saying? They've even hijacked a fucking dimension, bro, and try and pin us down to just pure trigonometry. We're goddamn ridiculous.
The UN map, flat. The regular map, flat. They don't have a round map that they go by that's round. They don't have the globe map. The actual globe should be the map. That should be the only map. The globe in the classroom should be the only map. Or bust. Like, if that globe doesn't work, what are we talking about? If they got to put it on a flat map to work and the globe isn't for actual educational purposes, what are we arguing about? You can teach educational purposes off the flat map. You can't off the globe. Where, what are they talking about? I mean, literally.
Hey, Jesse, are you there?
Yeah.
What's up, dude?
Oh, not too much. How are you doing?
Yeah, doing all right, man. I saw you write a big thing in the text chat there, but
everyone needs to be good at something.
Yeah, dude, you putting together some info. So yeah, what's up? So I'm sorry, Democ. I was listening to Democ for sure, but you were going for a bit there, and I wanted to say what's up to Jesse.
Oh, not too much. I'm just heading off to bed here shortly. But I think I figured out a good way to disprove flat earth. And that is the Haversine formula works on a sphere, but it does not work on a flat plane, and it works on the Earth.
It does if you mapped your Earth, if you measured it as a flat plane and mapped it as a sphere. Before you react, think about this. If they measure it as a flat plane, add R, and then map it, then the Haversine formula would absolutely work. You'd have to use Haversine to get real life distances. Would you at least agree with that? And that's a hypothetical. I'm not saying that's what they did, but that's the only way it would work. Is if right?
Well, I spent some time trying to think how you could possibly come up with any flat map coordinate system, which would allow you to feed those coordinates into the Haversine formula and get an accurate distance. If you think you can do it, I'll try it.
No, but I'm saying I'm just saying hypothetically. So we can here's my point. We can take something flat and add a radius, okay? Because it's done 2-dimensionally, and we can add a radius, okay? Yeah, it would be apparent in the further south you went, right? Yeah, I will agree. But as far as the majority of the world, okay, and at this size, you would agree we could take something flat and give it a radius and map it on a ball. And then when we went to measure it, if we didn't use the spherical geometry, if we didn't use Haversine, then we'd get the wrong distances.
But the point is that whatever reality is with Earth, the Haversine formula works with it.
Yeah, but the difference in reality, bro, you're talking about 9 miles over a span of 1,500 miles. You're talking about a 9-mile error ratio, bro. It's ridiculous how small of a difference it is until you get out over 2,000, 2,500 miles, dude. It's ridiculous. So to be able to test these we'd have did it a million times if it was that easy, bro. But it's just the reality of it, dude. Nobody's there's no continuous cities even. You realize it's like a 10 feet over 69 miles. That's the difference between flat and curve, bro. I'd say that's in reality impossible to measure. To me.
Well, all you have to do is demonstrate that the Haversine formula can work on a flat scale map. It doesn't have to match the Earth. See, here's the thing. I can take a basketball. I can draw totally arbitrary continents on there. I don't even need continents. I can draw the latitude and longitude lines, and I can pick any 2 points, use those coordinates for those 2 points, and the Haversine formula will work. You can't draw latitude and longitude lines on a flat map in any such way where the Haversine formula will work everywhere, right?
Yeah, you'd be off by
Yes, you
10
can.
feet. Listen,
Yes, you can.
if it ain't flat. Okay, if you get past
Hold
my
on a
first
second,
argument, which
please.
is we can map a flat map on a globe, but look, it's only 10 feet over 69 miles. So even if we've talked this over, bro, by laying out the straight lines and using the spherical geometry,
I got Brian.
it's not feasible, bro. It's not feasible.
One word, Brian. Depth. The Haversine formula doesn't have depth. Neither does their math problem. You don't even need depth. All you need is a flat dartboard, right? And then you need your longitude. Why?
Just making up words and
Listen, dude. All you need is you don't have any depth. Your math doesn't have depth. Why are you doing that? Why are you making up Haversine has depth? Show me depth in your Haversine formula.
All right.
Show me the depth.
I don't know, Demo. Maybe just try to make
He's talking
point.
about
Just say a concise point and pass the mic because it's getting a bit
flat versus round. Flat is all you need.
So Jesse, have you tested this yourself in the world, or?
I just did some thought experiments, and it doesn't even need to be tested in the world. It could be tested just on a sheet of paper. And here's the difference.
No, the distances on Earth is what I'm saying. The distances. Have you checked the Haversine with those actual distances on the Earth, or are you just going off a grid system or a map that you're getting off, the internet or wherever you're getting it?
Well, I mean,
that's like
I've checked. I've used the Haversine formula to check distances between coordinates.
And you've done that, and you've checked that distance in the real world. You mean yourself,
on a flat map,
not just going off of, some coordinate like Google Maps or something or anything like that.
Well, I've checked Google Maps distance against the Haversine formula independently, and then I've checked Google Maps against a 2,000-foot ditch I dug in the real world with an excavator.
Yeah, on a flat map. On flat Google and flat coordinates on flat math. We got you.
Yeah, 2,000-foot ditch, bro.
2,000 feet long. Yep.
Well, you should have no problem coming up with a test then that we could do in the real world and work it out, a practical test. I think I ran across a good way we could do it. I was going to bring it back up, but so let's see, how can we test it? Because you can't use a map and you can't refer to Google Earth or GPS or anything and say, look, there it is, see, it matches. That's our argument. That's what's in contention, brother.
He can use the globe, the one that's not for actual educational purposes, the one that he says is supposed to be out doing the flat map, which doesn't clearly. So get your globe that you want to run from and mark all your land masses on there accordingly on the little ball, and then show us what you're talking about. Versus a flat one. Versus a flat map we know that works perfectly fine.
All right, so yeah, he's saying that he thinks this Haversine thing matches. all the distances in the world, and you're saying that you matched it to Google Earth, and then you matched Google Earth to your 2,000-foot ditch. Therefore, you think that that logically to you seems like, therefore, all of Google Earth should be accurate, that the whole Earth's a globe. Is it because the 2,000-foot ditch?
No,
Was
that's not even my argument. I gave that anecdote because you specifically asked had I tested it against the real Earth. But
Okay.
I'm not even talking about the real Earth. We can take in the lab.
Oh, that is what you're talking about. You're saying Haversign works on the real Earth and it works on Google Earth. Therefore,
Well, no, I'm saying it works on the real Earth, which is the unknown, the real Earth, and it works on a basketball in the lab, but it does not work on a flat sheet of paper in the lab.
Here's the problem, though, Jesse. All the measurements across all the continents, and we're done like small section by small section. It's all planar surveys. It's a bunch of old joint, they've done some new shit, but it's pretty much a bunch of, they put together tons of surveys, planar surveys. And so like I'm saying, I don't know why you ain't getting this. I'm not trying to disprove your globe, but I'm saying if I took a flat section, a giant flat section, added a radius to it, when I went to measure it and map to match my model, if I didn't use Haversign, I wouldn't get the right answer. If I added R to a flat surface, when I checked the distance, if I didn't use Haversign, I would get the wrong answer, bro.
But here's my point. We could be aliens in another world that was neither flat nor spherical, or maybe didn't even exist. But we could still take a basketball and a sheet of paper and figure out what formula can give us the distance between 2 points on that basketball and 2 points on that sheet of paper, right? And they're different formulas, right?
No, they wouldn't have to be
Well,
different
that's
at
why.
all.
Yeah, no, I hear you on that. That's why I was asking. Ultimately, have you verified the distance? Sorry, have you verified the distance in the physical world? Meaning like in some way actually measure that distance is what the actual Earth is doing as well. That's why I was linking it back to that, because
that's a great topic, and I'd love to discuss that. But it's completely irrelevant to whether or not the Haversign formula can be used on a sheet of paper. And if it can't be used on a sheet of paper, it can't be used on a flat Earth.
That kind of reminds
It
me.
can
of the
it can
bias
if you use the
Brian.
grids and you give it a radius. It's two-dimensional
you just
Cartesian
make
either
it
way, right?
2D radius instead of a spherical radius.
That doesn't work.
Longitude and latitude.
You're saying like a 2D circle?
Anything flat. I don't
Yeah.
care. I don't care how you draw your grid lines. The Haversign formula is not going to work at all places on any flat surface.
It's analogous to when we were talking, I think yesterday.
I agree. In the real world, I agree.
Oh, God, Brian, do you not hear me talking?
I just said I agree, Janik. Fuck. I agree with Jesse. In the real
I know
world,
I heard myself talking before you came across. Stop.
Shut up.
So it's analogous.
Yes,
to
it
what we were talking
will
about
if you go
yesterday
from
when
the
they said,
ground like they
well, it's
do
not
with
fair
their.
that you guys won't let us use the 1 degree per 60 nautical mile when you guys can use it and we can't. I mean, the point is, certain things don't work in geometry and trigonometry. They just don't work. Those kind of ratios, it's linear relationships,
Yeah.
for example.
See, there they go.
That
Try to
doesn't
pin
work.
us
No,
down
hold
to
on,
the
hold on
strict
a second,
trigonometry.
Brian. Hold on.
You talk over me the
We
whole
got
time.
the
Go ahead. Talk over
protractor.
me some more.
The flat part is the bottom of the protractor. The round part is their imaginary fucking space and their imaginary stuff. That's their Haversign. It's flat. Trust me.
There's a little
It's
DMOS
all
icing
flat.
on the cake.
Yeah, I know.
Well, it's actually a good point. He's saying that the like flat bottom of it is the actual foundation, and then the curved part of the protractor, if you make that into like a hemisphere, then that's where
the formula.
That's where they're getting the sphere from, that they're calculating to claim that the Earth is a sphere, and it's really just the field of the sky.
And then Zanuck tried to do the same thing. He tried to pin us down to just pure trigonometry with no other variables. Like they have variables to explain where their shit ain't right. And but us, to say that it's a spherical grid of vision, basically it's a dome of vision, azimuthal grid or perspective, any of that. They won't. They just write it off. They hold us to the strict trigonometry. But I would agree as far as the measurements go, Jesse. But that's what we got to do is go out and measure, about a 1,600 mile straight line.
Go ahead and see if you can rectify the inconsistencies and the impossibilities of what you're claiming. Because as far as I know, sextant included, this particular discussion as well, are impossible on a flat Earth. Impossible.
It's already been
But
done.
not
It's already been measured, Zanuck. Flat. It's already been
It has not
measured.
been
All the links and all the states, they measured it flat. They did planar surveys, and your whole country, bro, was pieced together, state by state, measured flat, bro. Added radius. I don't see how y'all don't understand that. Even McToon would admit that he could map out a flat land as a sphere by adding a radius. He won't even deny that. Why are y'all denying that?
because we can measure the distance between the coastlines of San Francisco to LA and know that that distance cannot be on a flat line.
It was literally measured flat, Zanuck.
What's that?
They use planar surveying to measure it,
my
Zanuck.
God. They piece it together. They piece sections, small sections together. And each section that they attach has a certain angle change to it. Do you not understand that? That the distance over a chord or a curve is different than a difference of a straight line?
Bro, we discussed this a million times trying to come up with a test, bro. I mean, just you ain't
The
getting
easiest test is just to go up on a building and look at the horizon. It's the easiest test.
Like we didn't just have this conversation
I was
a
going to
month
say,
ago,
Xanax,
and then a month before that.
we do want to have new content, bro. You can't just bring the exact same thing every day. Like that's
Well, it's the easiest thing
just
to bring up.
like, well, it's just like the same talking point that we've gone through a million times. I mean, I'm not saying you can't bring it up. I mean, people do bring up the same thing over time, but this is like years in a row, and you're bringing that same one up, dude. Like it's. I don't really think we need to go over that one again, do we?
Well,
You got to get tired of being humiliated, dude. You got to get tired of getting humiliated, Zanuck. I mean,
that thing is just wreckage every time we go there for you. To be
Not
fair,
for me.
I'm not
for me because it never.
I'm laughing because I'm not.
been-
I'm not trying to like throw beef at you.
I know you're not.
But it's just the way I said it was kind of funny because it is.
I know.
It's just. It's
a
not
train wreck
proving the
here,
shape of
but
the earth.
for me,
You're not going up in an airplane, looking at a heads-up display, and deciphering the shape of the earth. It's just not.
No. You just hold a bottle of water out and you can see horizon. Everyone sees that.
That's almost like saying someone goes up in an airplane, looks at a bottle of water, and the top of the level looks flat on it, and they say, "Oh, the rest of the earth must be flat because the top of the water is." Which I mean is true, but it's like that simplistic of a.
No, the reason that you use a bottle of water is because the flat surface allows you to line up the front of the bottle and the back of the bottle, and then with a level orientation to the third point, which would be the horizon. That third point is below it, then you know the Earth has to be curved. That's a simple way to look at it.
What's that famous flat map?
And the easiest thing about that to understand is
Gleason.
Oh, go ahead. Sorry.
No, I figured it out.
Gleason's.
Who was it yesterday that was trying to?
I mean,
go ahead.
Dude, it's like it is as simple as like water finds its level. So we have basically level water in the oceans, other than the tides, obviously. So you do have the tides, but the land comes up out of the water. From there further, what the Earth is, like that's a much deeper question that we really don't have physical validation of. Like, dude, you Zanuck, you have to admit you really don't have the whole picture. Like you kind of come off as if you do, but you don't really, right? I mean, like, let's be real. At least we could laugh about it, dude. That's funny. I mean, like you come in, like you're laying it down, like you got it all, but it's like,
I know, I do, right? But it goes nowhere. It's like objection after objection. That's why I keep on coming back.
The classics.
I'm not winning. I'm losing. I'm losing the battle. It's killing me.
Can someone clip that? Can someone clip that? Can someone make a clip of that? Like, Zanuck admits defeat.
I'm trying to teach a horse to juggle, and I just can't do it.
No, I think Northern Rebellion said that like a week or two ago. He was like, dude, he's like, it's like these Globers, think about it. He's like, these guys are coming in here day after day for years, hours, thousands of hours at this point of their lives, trying to like just assert and push a globe, and they've just literally gotten nowhere. Absolutely nowhere. Maybe they have like frustrated some people, maybe they triggered some people, they trolled some people, whatever it may be. But in terms of like any progress on what they're pushing, it's just like a zero-sum game. Like there's just they're not moving at all. They've convinced no one. They've changed no one's perspective. I mean, I suppose you could say there were some people that have been on the fence that have thought one, so there could be some of that. But at the same time, like no one is coming back to the globe, like at all. And their efforts are just going nowhere. Like Zanuck, if your goal is to convince someone that you're correct and you're not doing it at all, then I mean, are you satisfied just completely failing at your goal? In that sense?
This is when he says, I'm just here for entertainment.
Well, it becomes an echo chamber without someone like, I think and he's checking himself and keeping us in check,
I agree.
A little bit. Not as much as Kosho. Not as much as Kosho, but
I also agree.
Yeah, Kosho is like a star.
Totally.
Hidden gem over here.
Because if we don't have something to bounce, someone to bounce it off of, then we only have trolls. Because we quickly can become an echo chamber really bad, really quickly.
I've never experienced any. I mean, all right, I can say maybe on some other servers there has been that dynamic, so I will say that. But I would say that even amongst like those of us that, I mean, if we're talking just about like the basic cosmology, like the shape of the Earth in that sense, like in terms of a stationary, planar type Earth system and so on, like there seems to be so many additional topics to explore that it doesn't seem as much like an echo chamber, but more like this infinite component of learning more or figuring more out and coming to further truth.
Yeah, you're right. I mean, a lot of it. Well, I don't know. I mean, before Austin coming around these days, I don't think we were expanding much. Like I think we're getting around to using the right language and reducing our emotion to the point we can be more effective. Like otherwise, there's not a lot of people as sharp as he is. Really willing and able to give a real a real position and not an argument. Like I'm good at arguing, but I'm not good at position. Like I really don't like the last thing I did at all. I just don't like it. I didn't feel I represented myself or anyone else very well.
Yeah, and I think of even though the globe earthers may not be like convincing a lot of people to kind of go back to the globe, as it were, at the same time, they are like I would say like sharpening our swords in a sense, or just sharpening everyone's swords, because any information is good information to look at, and to consider and to look at the source of it. And also just with most of, this huge portion of the population believing the Earth's a globe, that then means that it's obviously going to be a huge discussion for at least the next decade or two, probably even longer, until it all gets resolved and so on. So, and there's like a huge process of having to like unravel, in my viewpoint, the globe deception and everything that goes along with that. And so the conversation, like, I do think there's benefit to having, everyone be able to have their voice, because like it is.
Do you think
a process in which like a lot of understanding, we're gonna have to figure out a lot of stuff, is what I'm saying. Not not just us, just in terms of the whole world, like of what actually is going on. So yeah, it's good to kind of see all the sides of it and all the claims, figure out what's good and what's not.
Yeah, unravel is a good word. Because anything that
Well, you
comes
can't
loose, it's going to unravel.
you can't unravel anything when like Xanac and people think they've got it all, figured out.
I guess that'd be the difference between Zanuck and Kosho. Because Kosho knows he doesn't have it all figured out. Which makes him a more honest argument.
I want to see the sphere that they're using for their map. I want to see Jesse Gordon's spherical map, the one that like actually matches Earth. Because as far as I've ever been concerned, it's never been presented or created, or it doesn't exist. The actual
I gave
map
that
of
to you.
Earth on the
I gave
ball.
that to you, D-Mock. It's in your
You
bucket
did?
with curve. Yeah, it's in your bucket with the curve.
Oh,
said-
okay, some more nonsense.
You said show me a curve in a
Okay.
bucket.
Oh, okay, more nonsense. All right.
Actually, they did make one. It's called a Globus. And it was used on some Russian spacecraft for navigation.
Well, I would use it on a semi truck, a boat, a plane, a train.
An automobile?
Yes, sir.
It's so
Well,
mechanical.
would you?
Jesse, let me ask you this. All right, so let's say somebody is pretty new to the topic of what the Earth is. Maybe they're not necessarily committed to the globe. They've heard about the ideas of the term flat Earth and so on. They may only have a somewhat minimal amount of information so far. And if they just ask, they said, "Well, hey, the Earth's supposed to be a globe. We should have measurements of it, right? Like it should be measured." So if somebody asked you that, like they needed to see like what do we got for the measurements of the Earth, do you feel like you'd be able to provide something that would be sufficiently compelling to a significant portion of the population, as it were?
Are we talking about people who are already committed to flat Earth, or just people who have no preference either way?
They're on the fence. They were brought up with the globe, but they've heard flat Earth. They're just open that it could actually be flat, but they are not necessarily even committed to the globe. They're just kind of neutral.
I think I could.
You think
for a lot of them, yeah.
And enough to keep them on the globe, even if they started hearing a lot of all of the other information?
I think so, yeah.
Using what? Because if you're going to
if you've done that, you should be able to present it here. Yeah, sorry, go ahead, Rakia.
Well, if I'm on the fence and you're gonna come to me with the Haverstein formula, which includes the radius of Earth, I'm gonna laugh in your face.
Well, except you can't make it work with any fixed radius number on a flat plane.
Well, having my knowledge and not having knowledge about that, I'm gonna say then we should easily, if you can measure that distance, then you can measure the drop over a half a mile.
Yeah, I can, and I did.
Okay.
Actually, I
Then it
measured
should
it.
be over.
I measured it at 1.5 miles and 3 miles and other distances too.
Yeah, using an optic.
How much was the drop?
It was about 7 inches per mile squared.
How the fuck did you measure a 7-inch drop over a mile and a half?
Using theodolites.
So you looked one over A to B over 1 mile or 1 point something miles or a half a mile using that optic and measured something.
Yeah, I set up a flashlight on a tripod exactly 4 feet, and then I did it again another day at 5 feet. But anyway, I set the light up 4 feet above in a lake, in the shallow part of a lake, and then I did one at 1.5 miles and one at 3 miles from the telescope, and I also had the telescope set up at exactly the same height above the water, and it was a super calm lake too, a nice one, a beautiful one. And then I measured the angle to those two lights, and the one in the middle at 1.5 miles was dropped down a bit, and the one at 3 miles was dropped down even more.
Okay, so but flat Earth exists, right? So why would you say that someone like me would say that's not accurate?
Oh, my friend. Oh,
Don't break down.
what was your question?
Why would you say someone like me would say that doesn't accurately measure the drop of the water?
Because you're not the kind of unbiased person that's just looking into it like Gio asked me about. You're already deep into it. You know it's true. You think you know it's true. You want it to be true, and you don't want to examine the evidence. So
You're taking me now, though. See, I was that person years ago. And if you came to me years ago with this bullshit, I would laugh at you.
would you have a reason or just your personal incredulity?
I would have the knowledge that we would never use an optic tool like you're using over 1 mile for accuracy.
Why not?
What's the limit on a theodolite?
Oh, here we go. The same
No,
thing.
what is it,
over
Archaea? What
like
what is it?
groundhog.
What's the limit on a theodolite?
About 200 feet for accuracy.
Can you show me that? Can you show me that printed in the manual for the theodolite?
Can I bring you out tomorrow on a job site
No.
and show you and
No,
let
I
you talk?
want you to
Why are you over
show
talking
me
me?
where it's documented. I want to see where it's documented.
In reality, it's documented by every surveyor, by the surveyor I asked the other day. That was random. He's not my buddy. He's a random guy on the street. This is what I know. I use it every day, dude. I don't need a book. That's why I say go read a manual.
Are you talking
Or
about a theodolite or
And
an
you
auto
shouldn't
level?
be afraid to do what he's asking you to do either. If he says come out and go and come and see yourself, why would you say no? I can't do that.
I know, bro. That was kind of ridiculous, bro.
Well, the thing is,
Like if
there
Rakia
are
has
limitations.
if Rakia has experience with the tool and uses it every day, and can even go up to a random guy on the street that he doesn't know using the tool, and that random guy also agrees with Rakia, I'll probably go with Rakia's word on it rather than some random other person who's never used the tool.
You can go
Yeah,
out. Go out
they do
yourself.
print these limitations in the auto level stuff where you're shooting grade, but on the theodolite they do not document limitations to distance.
You're using the
How about
theodolite
you?
to do grade.
Hey, Rakia, I just posted the manual to that Lyisa total station that you had out on your job site, and its manual specifically said it's good for not only angle finding but also distance finding at over 6 miles in a single shot. So I don't know where you're getting that a theodolite couldn't do 1.5 miles, and I wasn't even doing a distance measure, just an angle.
He said with accuracy.
Oh
He
my
added,
God,
he
dude.
added
Are
the
y'all?
word with accuracy.
This is Groundhog Day. This is why Left Lane came
Pretty
in,
crazy.
right?
Well,
Because
Rakia,
first of all,
Well, but just
that's
respond to it though.
not. Yeah, I'm trying. That's not my theodolite. That is just another random surveyor on a job site that I happen to be next to.
and you said, when you posted that picture, you said, "Look what I'm doing today." That's what you said. "Look what I'm doing today," and you posted that picture. So that was your job site, okay? Don't tell us it was the next job site. You said, "Look what I'm doing today," and you posted that picture. This
He
was your
just
job
said it
site,
was
man.
his job site. He said he was going over to someone on his job site who had a theodolite.
Yep, and that's
Were
what
you
I
not
was
listening
doing
to him?
that day. He was measuring the horizontal plane of the slab that I also set as a horizontal plane from across the street,
And he
not
almost
6 miles.
All right, so let's go through the possibilities. Either what Jesse has claimed is true, and he did it and it's accurate. Number two, there could be a refractive effect involved, or what Jesse did, he didn't do it right in one way or another. But and then there's another point, Rakia, you're saying that it isn't even possible to accomplish what he's trying to with the equipment. Do I have that correct? Or
Yeah, they're saying they're taking angle measurements. They're not. They're using it for grade checking, horizontal planes. That's not possible over 1.5 miles. You can go out yourself and set up a tool, any one of these tools, and set it up horizontally and create a straight line segment and do it over 1 mile. And then just like George did. And on different days, even on the same day, you're going to get different measurements. Huge discrepancies.
And
It's not even close, dude. It's not go and quit talking to me on the internet. Go out to any surveyor and ask him what he would do for accuracy, like the one that I did on your channel, Geo, randomly. What's the maximum distance you would use this for accuracy, setting the horizontal plane?
What
200 feet is what he said.
You really need to ask how much accuracy. I would agree if you're trying to hold sub-millimeter accuracy, you're not going to get it at 1.5 miles. But if you're looking for like large discrepancies between the Earth shape, you'll see it fine at 1.5 miles. In other words, a 5 millimeter error is not going to account for, or even a 50 millimeter error is not going to account for that 1.5 missing feet at the middle point, or the 6 feet missing at the 3 mile point. You see what I'm saying?
Show us 1.5 miles in your area over different seasons. Go to a different area and show it over 1 mile in different seasons, and you'll get way different results.
So what I actually did, I actually only have 2 shots at that lake. One was a rainy day or kind of a rainy, cloudy day, and the other was a nice sunny day. They were still pretty much similar. But what I did do to get a better idea of the range of variation was I have a certain mountain, 75 miles, that I can see from my driveway.
Oh my God.
And so I measured the angle to that mountain 30 times over different years, at different times of year and different times of day. And I plotted it all out. And they all measured 3,200 missing feet, plus or minus 100 feet. So that gives you an idea of the variation due to temperature and weather.
Did you just say, wait. Did
32
you just say 30,
missing feet, 100. What?
Wait. Did you just say you measured 32 feet of drop plus or minus 100 feet error?
No, 3,200 feet of drop. 3,200 feet of drop plus or minus 100.
Okay.
What I was going to ask is, did you say that you did that for 30 years?
No, 3 years.
3 years.
I
I'll
did
get
it.
my 3s and 30s. Yeah, I didn't.
No, he said 30, but your
No,
I think you said 30.
No, I said 30 measurements over 3 years.
Okay.
Yeah, okay. That's what I understood. That's what you meant to say, but you
Illuminati
definitely anyway. But you measured over the lake over 1 mile. You measured a light, right? You didn't measure a story pole. You didn't do a measurement. You saw a light that appeared lower than your crosshair, correct?
Well, when I put the crosshairs straight and level, it appeared lower than the crosshair. Then, see, I'm not using an auto level. I'm using an actual theodolite, so I can move my crosshairs down to point right at the light, so I can actually get an objective measurement of the angle of the light as it arrives to the instrument.
So you can move the angle of your crosshair down to where the light is 1.5 miles away.
Yes.
What if it's above your crosshair? Are you going to move it up and say it's concave Earth?
No, I just measure. I have measured actually where the actual far shoreline did appear above eye level on a hot, calm day at the saltwater.
So the shoreline appeared higher than your crosshair. The horizon appeared higher than your crosshair on that day. And did you call that concave Earth?
No, I call that near surface variation. That's why. That's
but
why.
But when it's below the crosshair, you call it what?
So
Earth curve.
No,
Earth
it's
curve, right?
no. I'm completely open
that
that when you're measuring near the surface with the line of sight near the surface of the water, you can get very high variation. That's why I did a test where I was 181 feet above sea level, and I was shooting to a mountain that was 2 miles tall, 75 miles away.
Hang on, don't go too far. That's why professionals who get paid do it at 200 feet for accuracy.
Right. Well, when
Right.
when
Thank you.
when the discrepancy is 3,200, that is 3,200 missing feet, a couple feet of error due to the distance is not going to explain why there's 3,200 feet missing, right?
Yeah, a millionth of an inch will. If you're talking about a distance from you to something far away and you move one hair up or down, that's going to make so much of a difference. That just shows how much you don't know what you think you know. And do you have a side view, by the way?
That's in your bucket too, D-Mock.
Yeah, I know. Yeah. All your Narnia's in a bucket, right? Your globe Narnia.
And
Yeah,
you've got
thank
the
you,
bucket.
bucket
Yeah.
glober. Yeah, your globe is your globe proof in the same bucket?
Yeah, I put it all in your bucket for you.
Yeah. So your globe proof is in a bucket somewhere.
Yeah, your bucket. You always says here, put your proof in this bucket. I did.
So Jesse, was
I
that
always
if you were going to show people measurements, yours would be the one that you would show them? You're saying?
Yes. Yes.
Okay.
I would show them the one where I did the 30 measurements of the same spot, because that gives an idea of the consistency of my technique, right? You know, I mean, I'd be the first one to tell you that if I measured one day and it was 3,200 feet missing, and I measured the next day and it's 3,200 feet too high, and it's just like all over the park, I'd be the first one to tell you that ain't a good measurement. But if there's 30 of them and they're all within 100 plus or minus 100 feet of showing 3,200 feet, and that matches the globe prediction very closely, like within a few feet, then I would present that. And then
if there was
once they understood what I was doing and that I had taken the time to find out how consistent my technique is, at least, that doesn't mean with absolute certainty that it's accurate, but at least it's consistent. That much we know. Then I would show them the graph where I've measured at a whole bunch of distances from 1.5 miles to 105 miles and plotted the drop over distance, and show them how that it forms a curve which also matches the globe prediction very closely.
So if you had a diagonal bridge, right, or a bridge maker, you'd give your calculation to the diagonal bridge maker from your point to wherever you say all the missing mountain is, right, 1,000 whatever feet, and from your point all the way down, you'd have they could just go by your numbers, right, and just put the diagonal bridge there from where you are going down all the way to the mountain, and it would work.
I'm not sure I followed that.
Well, let me just ask
a diagonal bridge, a non-horizontal.
Well, Demak, I think he was talking about what he was doing with his theodolite. But
I know.
Yeah, you're trying
to
say that is it accurate enough to build a diagonal bridge? But
yes, because
all right, well,
to a building. You got a building down there. You're the king. I'm across the moat, and I got to go from me down because it's down to the point that I'm going to go to because it's missing from my horizontal. It's down. So I'm going to make a diagonal bridge to cross the moat from my feet where me and Jesse are to your mountain bridge, to your mountain opening where we can get to. Right? Would you give that to the king? You know what I mean? Because it's death if you don't do it right. So that'd work for you?
I can picture you being a king in a palace ordering your servants around.
All right, so Jesse, let me ask you. So all right, I just want to make one general comment. Why is it that there's a commonality between you and Ruhith particularly, and some others as well, where you guys are wanting to assert a globe and say it's a measurement for it, and then you're using theodolites over very long distances, like the way Ruhith does as well. He's even shooting it at the moon, getting angles. Ruhith's shooting it all over. And then there's Ranty. They were going to do that whole thing. They were going to go up on the mountain and shoot it on auto level over a tremendously long distance. Why is it if the Earth is a globe and it seems so verifiable, why are you guys all kind of doing a similar thing that is using the tool at a very, very long distance where there can be a lot happening through the atmosphere, and then trying to claim that, you know, and the fact that you're doing it like subjectively as well, but it's like a pattern that you guys are all sort of doing that same thing. So is it because it's really like, in your view, like you think it's because it's the spot on most legit thing to do, or is it that there's some kind of a almost like a collective trick going on that you guys are kind of running with this?
No, there's no collective trick. It's just a very practical fact that it's the most convenient to even attempt to measure, to objectively measure. There's just not any better way that I've come up with that I've been able to pull off. I'm certainly open to practical suggestions that don't involve millions of dollars and thousands of acres.
Side view.
But
A side view.
the theodolite is designed for measuring angles with great accuracy and precision. That's just what it's made for, and it's just a natural tool to use. And sure, there's definitely sources of margins of error. I mean, I'll be the first to tell you all measurements have a margin of error, except maybe counting integers. But it's really the one best way that is practical, and no one seems to be able to come up with anything other. And it's a measurement. It's not just, you know, kind of looking and giving it one's gut feeling. It is actually a measurement. Flawed as it may be, it's actually a measurement.
I know your ears need cleaned out, but a side view'd probably be pretty good.
Did he offer me a Q-tip?
Yeah, because clearly you can't hear side view, and it's too hard for a side view to appear for you to see yourself looking at your little magic mountain and how far it is that there's a dip between you and it, A and B, from a side view. It's only 1.5 miles, right? Surely you got to be able to get back far enough with one of your buddies to see you 1 mile away from a mountain. And then they can see how far it drops down, correct? They could draw a line at the base of your feet, then they could draw a line at the base of the mountain, correct, pal?
I gave you guys a side view. That's the closest I got.
Of you and the mountain.
No, this is the side view of...
no, we need 2 views. Then you didn't do it right. We need somebody viewing you, view the mountain, and we need it live on video. Or else you don't know what you're doing.
I guess, Gio, here's something. You could literally, anybody, you, me, anybody could literally rent or buy a theodolite and just go on a grand tour and go
Are you going to be in the side view?
Go to a
Are we
mountain
going to
peak,
watch you through our theodolite?
shoot an angle to another mountain peak, record it with no pre-expectation of what angles you're getting. You're just shooting and recording angles. You don't know what to expect. If it was a globe, if it was a flat, you don't know. You haven't looked anything up ahead of time. You're just measuring.
There isn't any angle.
And you go to another mountain peak and you measure to another mountain peak, and you can gather all this data without having a clue. It's really kind of a blind test. You don't know what to expect. You don't know if you're getting a good measurement for your preferred model or not, because you haven't looked it up ahead of time. And this is how I've done my data gathering, is I just go out. I like hiking. I go out and I shoot a bunch of angles. I take pictures through the telescope and at the LCD readout for the angle. And then I get home and then I plot the data. And you can do all this. You can get home, you can plot your data, and it forms a curve which matches globe prediction. The cause for that is,
and all that would be pointless.
Hey guys, I'm almost done here. I'm almost done. The question of why it forms a curve that just happens to match the globe curve, that's a good question. But the data is, or the fact is, it does form a curve, and I'm totally open to talk about how and why that's possible on a flat Earth.
No,
let's see the side view. Stop talking and making shit up. If you claim there's missing amount, you have a side view.
Hold on, Denmark. Someone was trying to get in.
I just wanted to ask: has Jesse ever cited to a plumb bob with his theodolite?
No, I know. I don't think so.
Though
Thanks,
you were
Jesse,
like
though,
you
for
have
going out and taking those measurements. Thank you. That's a good contribution. It gives us material or substance to actually talk about when we're in here, you know?
Thank you. Yeah, that means a lot.
All I'm asking is, have you ever, like, just hung a plumb bob and you've got a theodolite and you sight to it?
I don't recall doing that, but I have one of each. I sure could do that for you. Would that mean a lot to you?
Well, I think it would mean a lot to the subject matter. Isn't that the whole point? Like, you have an instrument that's set up properly, and you would sight to the plumb bob string because you have a vertical crosshair. Yes or no?
Oh, yes, but I don't see what the point is. Could you explain?
Yeah, it would be geometric. You set it up. You have your instrument that's you can swing around on a horizontal azimuth, and you could sight to a plumb bob string.
So, what would this do for us? Would it
It
help prove globe or prove flat, or
No, I mean,
what's our
it
goal?
it would establish that geometric principles work in reality. That you've set your instrument up. It's horizontal. You have that vertical aspect, and you sight to that plumb bob, and it would establish that along that horizontal.
It would demonstrate that my vertical crosshair is in fact vertical.
Yes, and it would establish that your vertical is parallel to the vertical you're sighting to, both parallel.
Oh, okay. Although I have sighted numerous times to the a horizon, and I think my crosshairs are pretty good lined up, but I'll try and remember to do a plumb bob just for you.
I think that'd be a problem though, right? Because a plumb bob, even if it were angled away from you, would still appear vertical in your crosshair, right?
Sure, but he
Well,
just wants to know that my vertical crosshair is in fact vertical, I think.
The problem would lie that no matter where you set your instrument up to the same plumb bob, it would always be parallel to the vertical crosshair in your instrument.
I know, but I'm saying that I think that would be true even if the plumb bob was angled away from you.
Yeah, it would
doesn't
be
matter. No, hang on. If you have one plumb bob string, you set that instrument up anywhere, it's always going to line up with that vertical crosshair.
Okay, I agree with you.
What does that mean to you?
That means that the verticals are parallel.
But if the string was leaning away slightly, wouldn't they still appear parallel in the axis that you were viewing it from?
Okay, hang on. You're not listening to what I said. The one vertical plumb bob that you hang, doesn't matter where you set that instrument up, it's always going to line up with that vertical crosshair.
And that's true for a globe as well, right?
Look, when you set the instrument up, no matter where you set it up, anywhere around that one plumb bob, it's always going to be vertical with that, or parallel with that.
Hey, Joe, can you make him answer my question? I answered a bunch of his, and he won't answer mine. Would not the exact same thing appear on a globe?
All right, let's waterboard him.
I'm just saying, and if you're agreeing with it, then fine.
Yes, even on a globe.
You have a proof for a globe. If no matter where you are, if you sight to a plumb bob with your instrument and that vertical crosshair lines up, it's parallel, then you have a proof for the globe.
No, it's not a proof for anything except that your crosshair is correctly adjusted.
Yeah, to that plumb bob that's vertical and it's parallel. It's lined up.
I think what Jesse's point is that even if in the case that it was my point as well too, even in the case that it's not parallel, even in the case that it's curved away from you, in your crosshairs, it would still appear vertical.
You think that it's curved? Do you think that the plumb bob's curved away from you?
Not curved away from you, but even if it were angled away from you, which on a globe
you said curved
you would
away
expect
from you.
If I said curved, I meant angled away from you. But regardless, even on a globe when it's supposed to be angled away from you, and it's not parallel to your vertical, and your crosshairs, it would appear to line up with the vertical part of the crosshair.
No matter, like, you got one plumb bob, and no matter where you set the instrument up, it's always going to be parallel with that vertical crosshair in the instrument.
You mean when you look through the telescope, it will appear parallel to the vertical crosshair? Or are you talking about whether it's leaning away?
You got one plumb bob. One. Just you hang it, you got that one plumb bob, that string. Now you set the instrument up anywhere. It's always gonna be lined up with that vertical crosshair.
Get the feeling that you've never looked through an auto level or theodolite and you don't really know what you're describing, and so that might be why it isn't making sense to me, because you're like assuming stuff about these instruments.
I'm not assuming stuff. I've seen it done practically. I know what it does, but I'm just saying you show me where you hang one plumb bob string, and you could set that instrument up anywhere around it, anywhere, from any vicinity, and it won't line up with that vertical crosshair if you set up your instrument properly.
Well, it should line up regardless of whether the Earth is flat or a globe, right?
That's not up to me. I'm saying that that's what happens. If you say it's different, then you'd have to prove it.
But I think we all three of us think that it if we looked in the crosshairs, we would see that it lines up with the vertical.
Right.
Then it would always then okay, that's fine. If you set your instrument up properly, it's horizontal, and you sight to a plumb bob, then it's parallel with that crosshair.
Right. If it's leaning to the right or to the left, you'll see a deviation. But if it's leaning towards you or away from you, then it will still appear parallel, right?
Well, that would I'm saying that no matter where you set the instrument up, sighting to that plumb bob, it's always going to line up. If you say a way or two, that's up to you. You'd have to prove that.
Okay, so we've wasted 5 minutes. What's the point, Buster? What are you getting at is all I'm asking.
I'm saying to you, it should be something you would want to do. I've seen it done practically. I know what sighting to a plumb bob does. I mean, I know what theodolites do.
In your own words, describe a theodolite to me, if you don't mind.
Theodolite, you set it up. It's got the scope that you can flip.
Okay. And what does it do? What's it for?
Well, the guy that I know personally that I talked to about it says that he called it his 90-degree machine. Because you can sight to a plumb bob. You can if you have it set up properly, you can swing to the you can swing 90 degrees. You could sight to another plumb bob.
90-degree machine, huh?
That's what he called it.
Mine are all 360-degree machines, I guess.
Well, he called it that because they went underground. They went in an 8.6 mile rectangle, just sighting plumb bobs at about 70-foot increments, and then matched it up within a couple inches.
So, is it what do you use a theodolite for? Is it just for setting 90-degree angles, or can you set other angles, or can you measure arbitrary angles?
No, you would just sight to a plumb bob, swing 90 degrees, sight to another plumb bob. That give you your.
How do you know if you've swung it 90 degrees?
It's on the azimuth. If you've set it up properly, you've leveled it. Like they have benchmarks. They hang a plumb bob and set their instrument up to it.
But I mean, if you were there and you were operating it and you sighted to your first plumb bob, and then your boss says, okay, I want another plumb bob position 90 degrees to your left, point that thing 90 degrees to your left. What would you do to make that happen?
Well, you'd have to back up and digress. You'd have to set your instrument up. You'd have to set the legs up, hang the plumb bob, make sure those are set up. I'm not a surveyor. I've just seen these guys do it. I watched it for years and years and years.
Okay.
I'm definitely not a surveyor, but I've just watched the guys do it. They set the legs up based off the plumb bob. Then they set the instrument on the legs. They level it. There's like a three knobs on the instrument that you set up on the legs. They adjust that, and then they'll put the plumb bob on top of it. There's a little divot in top of the theodolite, and then they'll spin it to make sure it's on that horizontal azimuth based off the plumb bob it's right over top of it.
I can tell you've seen him do it. Do you still have any contacts with these guys?
Why would you need to know that?
Well, I mean, I don't need to know that, but if you do, I really encourage you to call them up and say, "Hey, could we spend a day just playing with one of them things and have them teach you how to use it?" They're really cool, and then you and I will be able to converse at a more meaningful level once you've kind of used one a little bit.
Could you sight to a plumb bob?
Yeah.
Have you done that?
Nope. I've sighted a bunch of other things, but no plumb bobs.
Oh, well, there you go.
But I've looked through them. I know what it means to operate one.
I know what it means to operate one. I know what it means to use the principles, the geometric principles to get what you need to use the tools. Like you use geometric principles to get that 90. You need your horizontal, you're sighting to a plumb bob. You swing it 90 degrees, you'd sight to another plumb bob, and you'd have that horizontal plane. X, Y, Z coordinates. I mean, that's what that is, right? I mean, that's what you'd
actually
need to be doing.
It's a polar coordinate system. So it's angle and radius or distance.
Polar coordinate system?
Yeah, that's like
not
you know
Cartesian coordinate system?
No, Cartesian is rectangular. That's like an XYZ grid. Have you ever seen on a ship's radar where it shows the ship in the middle and then it shows all the different ships around it, but at an angle and a distance?
Well, I'll tell you what. I'll ask the guys that use those tools if they're using a polar coordinate system.
Yeah, ask them to actually teach you how to use them. That would be really cool.
But you're licensed to do this too?
No, wait. I'm not going to let that pass. So, implying by that before statement that you obviously don't know how to operate them, and that disqualifies you from making further statements. Jesse, don't do him like that, man. That's unfair. Come on.
No, I'm not licensed. But I have.
So you're telling me that you're not licensed, and I'm watching the guys that are licensed use the equipment, but you're saying to me, I need to learn it better.
Right. You don't need to be licensed to know how something works. I have 11 working units, and I've used all of them, and I understand how you use them just from doing it. So, and I'm just saying you should too.
I'm telling you that I watch guys sight to plumb bobs, but you've never sighted to a plumb bob.
Yeah, I've watched surgeons working too, but I never stitched anybody up. Sighting to a plumb bob is no different than sighting to anything else. It's just something to sight at.
Well, can you show me any practical observation where you'd sight to a plumb bob and it wouldn't line up with your crosshair if you set your instrument up properly?
No. Well, I mean, unless there's a stiff breeze or something.
Yeah, what would be the practical application in which you would do this in practice? Why would you do that?
Can I answer that briefly?
You mean measure to a light over a lake?
No, I mean sighting a fucking plumb bob. It doesn't
mean anything. Measure to a mountain?
It does mean something to me because I watched guys sight to plumb bobs over and over and over thousands of times, and they managed to go in a 8.6 mile rectangle and match it up within an inch.
Yeah, he worked in a mine or a mine system, and he watched the surveyors doing their underground surveying, transferring positions with plumb bobs from the ceiling and to the floor.
In
the
what
window,
professional
to the wall.
capacity have you worked with this tool, Jesse?
I only got paid for one job, and that was like 3 yeah, for 3 cents. I got paid 3 cents for 3 pictures of for 3 measurements to the angle of the horizon.
And you're trying to teach Buster?
Wait, but that's
Seriously.
Why were you taking a picture of the horizon? Was that some sort of FE related thing?
Some flat earther was disregarding my measurements strictly on the basis that I wasn't a professional, implying that if I wasn't a professional, that I was incapable of operating the equipment, which is obviously a fallacy. So as a prank, one of the other Globers paid me a couple cents to measure the angle to the horizon for him, so that I could say I was a professional at measuring, that I had professionally measured the angle to the horizon because I got paid for it, right?
That's not what surveyors do. You're making a mockery of surveying, measuring the horizon angle. Why are you laughing?
Oh, but I'm a professional.
No, you're not. You're a mockery.
Well, if I got paid for it, then doesn't that
But
make it?
that is mockery.
No, it
That is
doesn't.
mockery. That is mockery.
Why
You
you're
guys are
laughing.
being silly, man. I mean, he's basically using the strange mockery that you guys are using against him not getting paid for it ever. And then that makes no difference in how much he's gotten paid to do it.
We
It just
get the
matters if
mockery.
it matters if he knows what
That's why
he's
I
doing.
pointed it out. But
Yeah,
measuring viewing a light lower than the horizontal crosshairs of his theodolite that he set up to 0 to be horizontal over distance is not measuring anything. It's mocking the surveying community and now using it against us as some type of proof of drop when he says on a different day he got the horizon to be above the crosshair, but doesn't call that drop is a mockery.
How is that mockery? How's that mockery? It sounds like he's just using the tool for something that would be, to make a distinction between what would be expected
No,
on
the
either
mockery is
model.
getting paid 3 cents to measure something no one measures within the profession in a way that nobody measures it within the profession. And then saying because he got paid 3 cents, he's now a professional. That's the part that's mockery.
That's not a mockery. That was to satisfy the unreasonable claim.
That is definitely a mockery. Sorry.
He's mocking professions in general, not
see,
just
here's-
that.
But see,
Oh my
here's
It's
the
all right. Just keep mocking measurements, Ricky. That's okay.
But see, the fact is, and this is a fact, mariners using celestial navigation
I like how if we did something like
use
that,
changing
they
all
do.
you guys would be shitting on us.
Okay,
but since
guys.
Hold on,
Jesse
guys,
does
guys,
it,
hold on.
all you guys back it.
Mariners using celestial navigation do use the angle to the horizon as their reference point for measuring the angle to stars. So it is actually very valid of me to use a high precision angle measuring device to measure the angle to the horizon in order to see if the formula is correct, which is used by celestial navigators to compensate for dip correction. And it turns out it is.
I would just like to make the point that if I got a contract from one of my buddies who somehow snuck their way into NASA and I got a contract to wear a fake fucking spacesuit and ride around on a skateboard downtown and just say NASA and like prank people and blow fucking air balloons in their face and then said, well, I got paid $5 on a contract from NASA, you guys all would be in here complaining and saying, why is he mocking NASA? But then when Jesse does it and it's for the reasons of the globe and he mocks land surveyors, you guys then come into his fucking defense and defend him like a bunch of fucking fanboys. You guys are hypocritical. You can't see things outside of your bias. Thank you. I resign my
Deal with the measurement, Noah. Deal with the measurement.
Yeah.
No, I'm dealing with the fact that you guys are hypocrites. You guys would be all kinds of offended about something, and then you guys literally
the
say,
3
"No,
cents
that's
was a
not
joke,
mockery. That's not mockery." But you
3
good as
cents
well
was
know
clearly
it
a joke. Deal with the measurement.
The real mockery against truth here is the people who told me that
Mocking is a joke.
because I
You
wasn't a
can't mock
professional
without
that I was
joking.
unable to measure an angle, right? That was the real fallacy there. The real mockery against truth was denying my measurements simply because I wasn't a professional.
No, that's
Lots of
just a fallacy. That's just
lots of
fallacious reasoning. Mocking is something else.
lots of
Mocking
people
is,
are
yeah,
lots
you
of
were
people are
mocking. The
lots of
person was just
people
fallacious.
lots of people are competent at things they're not professionals at, right?
Yes.
But you know
Yeah,
what was
but it's just
distasteful,
if
Justin?
if I come somewhere and I make a fallacy about something, that doesn't mean someone else goes to go and mock someone else, and then it
You just
doesn't mean that
Deal
people
with the
that support
measurement,
your
Noah.
side on a random argument then deny the fact that it's mockery. I mean, you guys, yeah, I can't believe you guys just can't be fucking just a little fucking truthful for once.
Yeah, why can't we stick to the measurement and address that instead of talking about this shit?
Because you fuckers lie all the time. It doesn't matter. We can't address anything if you guys can't even
Okay.
get to become truthful.
I'll stick
If
to the
you're if
measurement.
you're liars, we can't discuss
Thank you,
anything.
okay.
Hey, Riakia,
Okay.
let's
That's true.
Okay, the measurement you did over a mile to a light. What did you measure there?
the angle. You mean what was the angle?
The angle to what?
The flashlights?
Yeah.
Oh, hold on, let me get you the picture with the numbers
No,
here.
just say a number. It doesn't matter. It was lower than the horizontal, right?
Yeah, hold on. I got that data here.
That's fine, but it was lower. That's the whole point. The light.
Yes.
Okay. So on another day, if you put the light at the horizon, it would have been higher than your crosshair, you said?
Yeah, if it was a hot day and cold water, which I actually haven't seen at that lake, but I have seen it at the saltwater at the Kleinspit County Park.
So you're admitting that the conditions made the light, if there was a light there, be higher than your crosshair.
At the saltwater, yes. When the
Oh,
observer is down near the water,
perfect.
then
Perfect.
yes. Hey,
Perfect.
we've all seen Skunk Bay.
Easy.
We all know
Easy.
there's
Easy.
strong.
We're talking about your measurement
Yeah, I let you talk. Just let me
being
finish the sentence.
affected by
I'm not a long
conditions.
babbler, Rakia. Just let
Yeah,
me.
you're the one who was talking about how we need to stick to the measurement, and now you're fucking babbling on.
Yeah, no, we've all seen Skunk Bay, and nobody here is denying that when your line of sight is close to the water, when you got your camera down a couple feet from the water, the things can be raised that can appear raised up above eye level that you know are below eye level, or the horizon can appear below eye level. There's no question about that. That's why I did the 30 measurements with 11 instruments at different times of year and different times of day to a mountain 75 miles away, because the line of sight was high above the water.
So we're changing from the light that you saw over the water as your measurement that you first came up with, your measurement, to a light. So stick to the measurement is what I'm doing. I'm talking about that light that you said on one day due to the conditions appeared higher than your crosshair, and on other days appeared lower than your crosshairs due to conditions, right?
The higher than eye level horizon was not at that lake, but if there had been a light, then yes.
But the difference is the conditions were different.
Yes.
Thank you.
But what do you make of, you said you wanted to keep with the measurements here. So what do you make of the 30 measurements from 180 foot high observer to 2 mile high mountain target at 75 miles, where the variation was plus or minus 100 feet with a total missing height of 3,200 feet?
So you're admitting that your light was in apparent positions that you measured the angle to, and now you want to go to a longer measurement of a different object, a mountain, that you're measuring the angle to its apparent position to.
Absolutely.
I think
The
I've
fact
made, then thank you for making my point for me.
the fact that there are certain known conditions which make a consistent measurement very difficult doesn't mean that there aren't other conditions where a consistent measurement is very plausible. And I showed that there is one by making 30 measurements with 11 instruments over multiple years and during the multiple times of year and multiple times of day, and I got consistency, right?
Well, you made however many measurements of apparent positions and said you got it within 100 feet and said, voila, here's my angle measurement to an apparent position. Yeah.
How'd you
Okay.
get to within? How did you get to within the 100 feet though? Like, how did you come up with that number?
That's just the absolute deviation. So I took all my measurements and I averaged them. That's where I got the 3,200 missing. And then I took the highest and the lowest.
Wait,
And
that's
Missing from what?
the flat Earth prediction.
I like how you laugh, Rakia, but never make a prediction for flat Earth. It's like you have
Why
no
would
idea
I?
what a flat Earth looks like.
Why
Yeah,
would I?
because you don't want it to be proven wrong, right?
What are you talking about?
You will never make a prediction for what it should be on a flat Earth because we will go and test it in reality and show you that you're wrong. You're terrified
I'll
of
tell
it.
you what you do. You go test this in reality, buddy. Go on a static lake and do straight line horizontal segments. Extend them out for distance where you
Right.
know that that horizontal segment is not curving and you're taking actual positions of things and then come back and see who's laughing.
Okay, so you're talking about leapfrogging, right? Taking like short sides, back shots, back sides, foresights, right? Over what, 50,
Extend
100 meters?
extend a straight line segment, make a horizontal plane so you know for a fact that it's not deviating, not curving
Right.
over
You're
static
talking about
water.
leapfrogging, right?
Do it however you want.
But you've
Well,
already
I'm asking you whether you're leapfrogging, right? So you're
I'm
doing shot
asking
after
you
shot.
how you're going to do it. You're the
No,
expert.
this is your experiment, your observation. Are you doing it by like taking a back sight to the rod and then turning around,
that's
taking it to the
actually Jesse's
foresight,
observation.
and then moving your auto level, taking another back sight and foresight? Is that how you're doing it?
Is that how you extend a straight line segment?
I'm asking you, Rakia.
I have no idea. I'm not a
Okay.
surveyor. You claim
No
to be
idea.
the
Excellent.
expert. Is that how you would extend a straight line segment?
No, that's not how I would do it.
How would you do it?
I don't think it's actually possible. You can extend one horizontal and that's it. As soon as you move your auto level to another place, you've got a new
The
plumb.
fact that you said it's not possible is game over.
Not possible to create a horizontal line.
No, not possible to extend, Rakia. Listen to
game
my
over.
words. Listen to my
See you
words.
later. I've listened and I laughed and
Yeah,
I'm leaving.
so I didn't
like,
say
because
not
everyone
possible.
heard you say it.
But then why can't you extend it, Ruhif, in your viewpoint then?
Because as soon as you move the auto level, you got a new plumb line. So your horizontal is
LIGO
then
did
different.
it. LIGO did it. I do it
Okay,
every
do you want
day.
to talk about LIGO and the elevations of the LIGO tube? Are you sure you want to do that?
You mean the straight line segment that they created?
Yeah.
And you're saying
What
it's
are the
not possible?
elevations of that tube, Rakia?
No, let's talk about the straight line segment.
Right.
Did
They
they
we
do
agree
it
it's
there?
straight, right?
They didn't
Is it
use
possible now?
they didn't use leapfrogged auto levels to do that.
Okay, fine. Hey, expert, what method did they use?
Yeah, they had to take the
GPS.
curvature of the Earth into account to get the
No.
right elevations to make it straight. Holy shit, Rakia.
To create a straight line segment that's not curving, you use the curvature of Earth? Are you kidding
I'll
me?
say it again. I know you can't quite understand basic
Yeah,
English,
maybe
Rakia.
attack
I
me instead of
understand.
what I said.
Well, it's not what I
Attack me.
said, right?
Yeah,
And that is
Ruhif,
true.
don't go to the personal. Just say your point, dude.
Well, he continually misquotes and mishears, apparently. Okay, to get the straight line, they had to take the curvature of the Earth into account. If you look at the elevation profile of the tube, you will see that it makes a curve. Correct, Rakia?
Then it's not horizontal.
No,
Correct,
the
Ruhif?
Earth is curved, right? Do you understand that a straight line, right, on the Earth will have a curved elevation profile?
A horizontal line does not curve, sir.
Do you understand the elevation profile, Rakia, of a straight line on a globe will be curved? Do you understand? Do I need to draw it?
I'm not talking about that. I'm talking about a straight horizontal line segment. Do you hear me?
I heard you. Do you agree
Then
that
you say
LIGO is
that's
straight?
impossible. So LIGO isn't a horizontal straight line segment. Is that what you're saying?
LIGO is straight. It is
Is it
not
That's
horizontal.
not what I asked. Did you hear me? So
Yes.
it's not horizontal.
It'll be horizontal at one point.
So it's not horizontal.
It'll be horizontal at one point.
So it's not a horizontal
It'll be
line.
horizontal at one point, Rakia. Jesus.
Okay, then let's move to something that is a horizontal line that you're now saying is not possible to extend. That's your
Correct.
claim, right?
Yes.
Okay,
yeah.
then
How would
I'm
you do it?
done. I'm done. Anybody can go talk to any surveyor and ask them.
Okay.
That would be a good proof, right?
A surveyor's opinion?
A
I'd rather go with
surveyor,
measurements.
a surveyor that does it for a living can create a
Extend
horizontal line
straight
and
lines.
extend that straight line segment.
I would love to see how it's done. Love to see it.
Oh my God.
Please find one.
This
Please
is
find a
crazier than I
surveyor
thought.
that can extend a horizontal line.
No problem.
Yeah, I won't hold my breath, but yeah, please do. Anyway, back to Jesse.
So, what do you think happened to cause me to measure that missing 3,200 feet, Rakia?
I mean, I could care less what angle measurements you're getting to what you've admitted to be an apparent location of an object in the distance. Do you think, as you have 11 instruments and have studied this, obviously, that you can extend the straight line segment that doesn't curve?
Not if I'm changing my angle of plumb by moving my instrument on a globe. It would work on a flat Earth, but it wouldn't work
It's
on a globe
not what
Earth.
I asked. It's not what I asked. Can you, with your equipment, establish a straight line segment, a horizontal line, and then extend that line? Can you do that?
You mean from with or without moving the instrument?
I don't give a shit how you do it. The question still stands. Can you extend a
Extend. The
horizontal?
keyword is extend.
Yeah, extend the
Okay.
straight line segments in every surveying book there is.
Okay,
Extending a straight line segment. Can you do it?
I extended it out to 3 miles.
Did it curve?
The Earth curved.
No. That's not what I asked. Did your straight line segment curve?
I don't think it curved very much.
You don't think
the lake curved though?
Oh my God.
Curved right out from beneath it. But look, you're
I think
skating.
everyone's heard. I'm done. See y'all later. Good luck.
No, you said you would stick to the math, my friend,
thanks,
or my
thanks,
fellow
Rakia.
human.
Thanks, Rakia.
Let's get this
that.
straight. I am not your friend.
I corrected myself. I said fellow human.
I wouldn't claim to be human either.
You did correct yourself. That is true.
But straight up, Rakia, I heard it. I was listening.
Oh, well, good post there, Jesse, by the way. Rakia has already admitted that leapfrogging cannot determine the difference between flat and globe.
Yep. So
Glad we didn't have to go through that again.
So, Gio, can you see my screen share? This relates back to what you'd asked me earlier about the Haversine formula. Can you see it, Rufy?
Yeah, I'm sharing myself as well.
Oh, oops, I didn't see.
Yeah, see, yep, cool.
Okay,
could you tell me what that term means? The hammer sign thing?
Oh, the Haversine formula?
Sorry guys, I don't know what that is.
It's just a mathematical formula where you give it a radius, and 2 sets of coordinates, like a latitude and longitude for one point, and a latitude and a longitude for another point, and it tells you the distance between those 2 points on a sphere, like even a basketball. If you drew latitude and longitude lines on a basketball, you could literally use the Haversine formula to tell you the distance between those 2 points, and then you could take a tape measure and spread it out or stretch it between those 2 points, and it would tell you the same thing.
Can I ask you a question?
Can you? You may, but can you is up to you.
Okay, don't be my fucking elementary school teachers. Anyways, the question is the distance that it calculates going like through the surface of the Earth, like in a straight line, or is it like conforming to the surface?
No, it's surface distance. It's the great circle distance
Okay,
between those 2
okay.
points.
All right, yeah, just wondering, because this is, you know what I'm saying.
Yeah, no, you did. That was a good question. I'm sorry I teased you about that.
Wouldn't that just be an arc length?
Well, that's what it finds.
Right. So
Yeah.
So here's the difficulty on a globe Earth. For those of you who are watching my screen, I have notated equal a line of longitude at a certain latitude, north, and also one south, but they're equal. See, it's the one's the two tropics, the limits, the sun. This is the line where the sun goes over during one extreme of the year, and then this is the other. So these two lines here are equal distance from the equator. If I got that right.
So on a globe, they'd be the same distance, but on this map, the southern line would be longer. Yeah.
Right, and so that's the point. On a globe, you could give it this coordinate and this coordinate for these 2 points, and it would give you a certain distance, and then equidistant on the other side of the equator, which I may not have it. I might be confused on these lines, but it doesn't matter. The point is, equidistant on the other side of the equator. On a globe, you give it these 2 coordinates, and it will give you the same distance as this first set of 2 coordinates.
Here's another thing though, is you'd have to correct north until you got down to the equator, and then you'd have to go straight. You wouldn't have to correct north, and then when you got past the equator, you'd start having to correct north again.
We're just getting
but they don't have they correct north all the time, no matter where
we're
they're
just
at.
getting distance between 2 points.
Yeah, we're just talking about the distance, the surface distance between 2 points. Like if you're,
So
if you're,
I don't trust any
Look at the
measurements
length
with
with the
distance,
longer
man. To
one.
be honest, man.
Listen, that one, the length of the longer one should be proud compared to the shorter one. The shorter one should be jealous of the big
I
one.
agree completely.
You see that because they both look like dicks.
Sure. But what's the next point you're getting at?
On a flat plane of any type, whether it's a sheet of paper, a chalkboard, whatever, it doesn't matter where you draw your grid lines. There's no combination of grid lines where you can get the same distance via the Haversine formula in 2 different ends like this. In other words, if you try to use the Haversine formula on a flat map, it won't work. And there's no ways that you can rearrange the lines to make it work. But I mean, for example, you could take.
It has the radius in it.
Right. It doesn't matter.
Yeah, we all understand that, right?
You could set the radius if you wanted to try to use the Haversine formula on a flat map. You could. I don't care. You can set the radius input to anything you want as long as it's fixed, because the globe uses it fixed. So you got to use it fixed too. You can set it to anything you want, and it's not going to be able to calculate the distance between any 2 points on a flat map. So even if you say, well, we're gonna draw. See, let's say we take this line. Oops. I'm trying to hold my push to talk and everything. So let's say we're going to take this line and we're going to. Oh, it's not. Okay. And we're going to put it like this. So now we're curving our lines funny so that we can force this measurement to work. Now, maybe now, the Haversine formula would work for this length right here. But the problem is, you've moved this line. So now, if you go to measure, say, from this point to what was supposed to be here, but is now down here, now Haversine formula no longer works for this. So there's no way that you can contort, rework, change, modify your grid lines in order to make the Haversine formula work on a flat map.
Yes, my phone died about an hour ago, and you were saying the exact same thing. We all said, yeah, that's fine, but show us the distance. But look, like without using the stars, Show
Right,
us a
sorry.
flat. Show us the flat measurement. You know what I'm saying?
Why
You got to
can't we use
assume
the
it's flat or
stars?
assume it a globe. But here's the point:
That's
if
not
you
going to
apply
happen though.
R to a flat ground, then any radius, any spherical, you'd have to use a spherical calculation to measure it. If you added R to a flat surface, theoretically, then
Why
you'd
can't
have
we
to
use the stars, Brian?
You're going to use a celestial sphere to prove the ground. That's our whole argument.
I'm just going to say the stars move at 15 degrees per hour, 15 degrees of longitude per hour. Do you agree with that?
They appear to.
Okay, we can use that to work out distances.
That doesn't mean they're exactly that in the distance, dude. Here's the thing, but besides that, I'll concede that. But besides that, we've been saying this, bro. The distance between the straight line and the curved line, like if he went to test the Habersign, bro, you're talking 10 feet and 69 miles, bro. Do you have confidence anybody measuring within that type of accuracy, bro?
Could I measure the width of Australia and then get a width of a 1 degree of longitude? Yeah.
Australia was done by combining a lot of flat surveys, man.
Are you
So was the
looking at?
United States. Bunch of
Are you,
planar surveys combined.
are you looking at my screen share, Brian?
Yeah, I looked at it for a second as I was joining. Look, we're agreeing, bro. We're not disagreeing, but you to go out and, I don't think it's something we could try, but if we could do that, yeah, sure.
Well, the argument I'm making is that
if anything match Habersign, then it ain't flat. Right. Got it.
Right. So, but Habersign does work on the globe or on the Earth, right?
Bro, did you not hear anything I said, bro? I mean, if it was that simple, bro, nobody would be here, dude.
So
if it were that simple.
You've got a boat, right?
I did. I don't know. I got a little ass boat, but not enough to.
Yeah, okay.
Not
But you
enough
had
to take out in deep water. Man.
But you had a GPS, and you would put a bookmark for your favorite fishing spot, right?
Sure.
Okay. And let's say you're at the dock. You're like, okay, I'm going to my favorite fishing spot. It's 10 miles out or whatever. You click that in your GPS, and it says, okay, you got 10 miles left on your journey. It tells you which way to go, right?
Yeah.
That GPS uses the Habersign formula based on your coordinates.
Says you.
What's that?
Says you. Nobody's got the original source code for GPS, bro. And why won't they let us have that? Yeah, we could do a what you call it, but it's not the same one. But here's let me say this.
Dude, it's not GPS that does it. It's your phone.
Let's say I put a bunch of lights above my yard, and I measured angles to them, and pretty much I measured a bunch of sections individually. Okay, and I put a light at each corner of every square that I measured, and it's flat. Okay, now I applied R and then gave you a map or a globe or a dome, let's say. Now, when you went to measure that in reality and you measured them angles, I've applied R to it. If you don't apply R, like using the Habersign or a couple other different ways, you're going to get the wrong measurement even on flat ground. You got to apply R. Once I've mapped it, calculating for R, if you don't use R, you'll get a wrong answer, bro. Agreed?
Well, if you try to use the Habersign formula on a flat map, it doesn't matter what you choose for R. It's not going to work in more than a couple spots.
Trigonometric function for the surface of a sphere.
Well, I think I have a solution to how it could be used on a flat Earth. So say the more southward you go, the heliocentric Big Bang cosmology model, whatever, right? It involves this whole like space-time dilation contraction, and I don't know if you ever thought about this, guys, but what if space and time both dilate the further south you go? I think a flat Earth of like a square nature, like a grid sort of nature system of a flat Earth that experiences like a circular sort of expansion from the North Pole outward of a space-time dilation. where one doesn't give and the other takes. You know what I mean? Like, I mean, I think that's what they say about like in your model, right? Like one, like something's got to give. Like when space contracts, time dilates. But on a flat Earth, if the further north you go, space contracts and time also contracts, and the further south you go, space dilates and time also dilates, then I think they'd be indistinguishable from each other in that sense. And that's also kind of what is being expressed by these flat Earth maps. You know, people say like, "Oh, Australia is like elongated." It's not necessarily stretched like longitudinally. It's stretched like laterally, right?
I've asked people who live there, and they said that it's not stretched out. It's not long and skinny like it shows on the
Right, but
flat.
we're not talking. I'm not talking about like actual physicality of any like material. I'm talking about time and space dilation as you go southward.
So, are you saying basically that even though the world is flat, it's indistinguishable from a globe as far as observation and measurements go due to the space-time dilation?
Nice one.
Yeah,
Jesse.
like you got those two lines drawn. They're supposedly, you know, as far as you would say, like being measured flight distances or you know times of sailing across these different you know A to B points, right? They're supposed to be the same distance, but drawn on a map, they, you know, one seems longer than the other. But if space was dilated, the more southward you go, then that would correlate to the way it's like represented on this map here.
Bundy is
What
not
if
a sign of flat Earth.
what if you what if space and time dilate the further south you go? Then that
Well,
would account for the you know these
well,
difference in lengths.
well, it only needs to dilate in one direction, not in the other two directions. So,
Well, this is why I was asking you before, Jesse, like, have you verified these distances on the Earth? Because if you're going off of the globe coordinates that are given through like the WGS 84 and, you know, these coordinate systems that are currently given, if you're going off of that, then you're going off of globe distances in the first place. So that's why I was asking, how much of this have you actually verified? Like, for example, the lines and the thing you have drawn there, you know, you'd have to actually go on the Earth and measure all of those distances, like between all those points, and have that verified to know for sure whether the distances in the Haversine formula are actually matching a sphere or whether they're not working and have the planar distances.
well, my argument has absolutely nothing to do with the actual Earth. It has to do with the fact that the Haversine formula works on a basketball, but doesn't work on a sheet of paper.
So nothing to do with the Earth.
Except that the Haversine formula does
Wait,
work on
that's
Earth.
not what you said the first time.
Bada boom. That's what
You
I'm
literally
saying.
just changed your fucking point in live time. You just pulled a Xanax, bro. You literally just changed.
He asked him just because he asked him if it had anything to do with the globe, but he's literally talking about it in reference to just straight geometry.
Yeah, an hour ago I says we could be aliens, not on an Earth that's flat or anything, not even on an Earth, just aliens. But we've got a sheet of paper and we've got a basketball. We can draw longitude and latitude lines on the basketball, and the Haversine formula will work to tell us the distance between any 2 points on that basketball. There's no arrangement of latitude and longitude lines of any orientation or style of any kind that we can draw on that sheet of paper, which will make the Haversine formula work for the sheet of paper. My argument is that the Haversine formula does not work for a flat plane of any kind.
Right, because it uses a radius value based on a sphere. So of course it's not going to fit a plane. But that's why the original thing is, if you're saying the Haversine works on the Earth, that's where you'd have to validate that indeed that's where it's happening. That's the part.
Google Maps.
You can't just go off Google Maps, and that's the biggest begging the question on the.
No, I'm saying Google Maps. Google Maps will use that. Like when you choose like the measure, like this measure thing on there, and you just click 2 locations. It just simply uses the haversine function to calculate the distance.
Right. So let's say I go out on the bluffs here in Sequim, and I look 20 miles across the water, and there's a city called Victoria, BC, Canada. It's a nice little city. It's got some skyscrapers, and you can find them on Google Earth, so you can get their GPS coordinates. Now, we know that the GPS coordinates are correct between the GPS receivers and Google
That
Earth
don't mean nothing, bro. Doesn't prove nothing.
because the people in Victoria, Canada, are using their GPSs to drive around that city. So we know that.
Sure, confirm the distance, bro. Here's the thing. So I'm gonna use
Hold on, Brian.
No, we got the point. Coach, we got the point. Okay. Okay, go ahead, Jesse. Repeat it.
Okay, so I can use my theodolites to triangulate and measure the distance between me and Victoria, Canada, right?
Welcome to Flat Earth. So I'm going to use Euclidean. I'm going to use Euclidean. If it works on paper, it ain't a globe. Right? If Pythagorean theorem works on a flat piece of paper, that proves it's not a globe, right?
No, the Pythagorean theorem works on a flat plane. It doesn't work on a large scale on a sphere.
In the world, though. So if I use Pythagorean theorem and I use a theodolite and show you that it works, then I've proven it's flat, right?
No, you've only proven that the air due to spherical excess is smaller than your instrument is able to do.
That's what we're trying to tell you, brother. Right there. Look, we agree with what you're saying. You're just finding 100 ways to repeat it. I can show that Pythagorean theorem. I could prove it in real life. Okay, haversine is is a different kind of geometry. Okay, and it means everything is up for whatever location. If you could prove that in reality, if you could coordinate and verify the exact distances, but they're so freaking close to each other. That's why I can't. That's why y'all won't let me use Euclidean geometry to prove it's flat, because we've said that a million times. Just the geometry alone proves it's flat. Now you're trying to reverse it on us. Well, we're not going to allow you if you don't allow us, right? Fair is fair, but I do say we go out and test some of this shit. But I don't have the confidence that anybody could test them distances, man. I think it's a model that was put together. It's fairly fucking accurate, but it's a lot of flat little sections tied together with R.
Flight times.
So let's say I go to my shoreline. I get someone to help me. We get 2 theodolites out there. We can see each other along the shoreline. We measure the distance between the theodolites, and let's say it's like, say, 3 miles apart. We zero off our azimuth angle to the 2 theodolites, and then we swing the theodolites at the same target in Canada across the water, and we measure the angle to that. We now have the angle for 3 corners of a triangle, and we've got the distance for one side of the triangle. Now we can calculate the distance of the other 2 sides, and hence the distance to Canada, right? Did that make sense, or do you want a diagram?
Yeah, man. Yeah. No, I got it. But yeah, you're using a 180-degree triangle if you're using line of sight. But yeah, absolutely.
Yeah, it's only 21 miles, so the spherical excess would not be enough to even be detectable by my instruments.
It never is, and with line of sight. But yeah, go ahead.
So does that sound like a good way to you for me to get a non-Google Earth related measurement to Victoria, Canada from Sequim, Washington?
Sure, man. That sounds like a reasonable way, but we're still gonna have to test verify the distance. At least on 2 of them sides, I would think. But I don't know. It'd be a start, right?
Well, no,
you're gonna get. It's gonna match in some places. I think in some places it ain't. I think it's gonna be really close everywhere you do it, no matter what. No matter what this Earth is. It's going to be really, really close. Really, really fucking close. Way outside the margin of error, no matter what we live on.
So what you're saying is, even if my measurements, no matter how many I did match the globe distance, did match the Google Earth distance, and did match the haversine formula, you would still say there might be some others, right?
No, bro, I brought this up. We tried till we were blue in the face. with George and others, and we're coming up with a test to measure angles and all that, and nobody's ever satisfied. We can't get everybody to agree with optics anyway. But I like your theory. I like the way you think, and I like the fact you're trying to prove something, man. But man, it's just I think we should stick to like precision. We need to come up with a way to if we could make a fucking solid 2-mile wall, and all we'd have to do is just tip it over. If we could make a firm 2-mile wall, run a string line, do 2 of them if we had to, and match what would match a globe on one and a flat Earth on the other. If it's straight, then it would bow out at the top. We all confirm that, but how are we going to make a 2-mile? How are we going to tip over a 2-mile wall? I mean, it's possible though. It wouldn't cost that fucking much.
As admirable as it sounds, I think it's funny because I understand how the average sign works, and it just like Jesse says, it kind of stands alone. It kind of stands alone as like an obvious. Obviously talking about obviously working on the surface of a sphere. I couldn't hear you. Sorry.
Averaging the fucking latitudes, bro. That's all you're doing. Averaging the latitudes and including radius.
Still can't hear you. Might have to fix your mic, man. I can't hear you.
It's just averages the latitude. It averages the latitudes. It averages the signs and the coast or the what's. Bleh. It's basically like averaging your position, your circle basically, and adding R. It's just a way of averaging.
That makes sense. That makes sense to you, Howard. To you.
Yeah.
I can't accomplish that, but what I can do is understand how the average sign works, and to me, in my head, it only works on the surface of a rotunded sphere.
To me, if we could just take the AE map, and verify the distances, to me, I think it's all gonna be in the south, man. Anything measurable is gonna be in the south. I think the test would be seeing if we have to. The more I look into it, the more I feel like they're corrected north everywhere on Earth, everywhere, even at the equator. That's the more I dive into it, man. But I could be wrong. I've never done it,
People do live in Australia. You're aware of that, right?
No, I'm talking about. No, I'm not talking about there. I mean, I'm not. Nobody's arguing south of the equator. I'm saying at the equator, we wouldn't have to correct to the North Pole. It'd be a straight line. We'd be equidistant from the North Pole. That's the only spot.
What are you talking about correcting, Brian?
Turn left to go east or west.
What?
Like, if we're right by the North Pole, Blue, then we'd have to spin it. We'd have to correct left like every step we took to do a circle around the North Pole. But as we got toward the equator, we could go straight. We wouldn't have to correct north to circle the North Pole because we'd be equidistant to it. But they do everywhere in the world. They correct north, heading east or west. And the excuse is in the southern hemisphere is because I don't know. Never heard a good one.
Anyway, Dan, are you there?
Where the wall idea sounds dangerous.
What's up, Rue?
Can you see my screen?
I will go look.
Okay.
Because you're such a fine gentleman.
Well, sorry. First question: did you see that video where I overlaid John McIntyre's position, where he claimed he was, overlaid it on Google Earth, and got the coordinates of where he says he was?
Hey, can I jump in real quick?
Yeah.
I just want to say it's bedtime for me, so I'm heading out. It was a pleasure. Y'all take care. And I filmed a new video showing the curve of the horizon from about 20 feet above the water, which I'll drop momentarily. Good night.
Night,
Good night, Jesse. I'll check it out.
So you're looking at the Great
Good night,
Bear
Jesse.
Mountain. You're looking at the Great Bear Mountain stuff.
Yes.
And you're saying that he's missed his shooting position.
Yes.
And
Right. So this. I'll This is his location that he gave in the video. So I'll turn that like that. That's where he said he was. Okay.
Wait a minute. Wait a minute. It's got numbers attached to it and names.
What numbers and names?
Well, I mean, I read what he said. It's in front of me. Let me see if I can find it.
You mean elevation? He gave you an elevation of where he was?
And he said he was on a ridge line, which means he might not be on the top.
Yep.
In other words, I think he was trying to match the other two mountains in height, right? He was trying to be level.
He was trying to get an elevation such that they would be at the same height if the Earth was flat. That's what he was trying to do.
Okay, so what elevation do you think he?
Well, we'll do this first, and then we've got to go and make dinner for the kids, which is kind of now. But yeah, he used a barometer basically to work out his elevation, which is never going to be accurate because you need to know the normalized pressure of the surface. Anyway, so I overlaid his video onto Google Earth to show where he thought he was. All right, and that's this location here.
How do you know that? How do you know that?
Because that's what I did. I took a screenshot of his video where he said he was. He pointed to where he was. All right, and I overlaid that on Google Earth, lined up. You'll see I lined up all these high points, right? I lined up all these, peaks of little mountains here and there, little tiny things, right? To line up where he said he was.
Is the 360 video online, the minute-long one? Is that his?
I found like an hour-long video.
All right.
That's not important. I've got to do this quickly because I'm going to go and make dinner. Anyway, I got his observer location where he said he was.
And what is that observer height?
1625 meters. It doesn't matter. Let's just get this little bit out of the way. Then I'll come back in like an hour. Okay, this is where he said he was. Now, what I've done is I've got this big yellow line coming from Greybeard Mountain. Okay, big yellow line from Greybeard Mountain.
That's the furthest destination in the pictures?
Yep, that's the picture in the back, the mountain in the back.
Okay.
And what I've done is brought that yellow line through. There are two towers on Frying Pan Mountain. One on the left is really tall, and one on the right is pretty short. So you can see that in your photo, right? You've got like a radio tower on the left, and then you've got, bring that over here. Yeah. So you've got the radio tower, the really tall one on the left, and then you got like an observation deck or whatever that is on the right. Okay, so I've drawn that yellow line through that observation deck on the right. Cool. That's where the yellow line goes. Now, if you trace that yellow line back to where he is, you will see that his observer location is to the right. All right, his observer location is to the right of that yellow line and the green line, which is the same line. All right, does that match the photo?
You're looking at a very short distance between that line and your mark.
If I am on the right-hand side of that line, right, and it goes through both points, then in a photo, the frying pan should appear to the left of Greybeard. Correct?
I don't have the photo in front of me.
I'll stick it over here. All right.
I know this is all about elevation, not left and right. But so
I understand.
Just tell me what you've discovered. First, you told me it's an elevation problem. Now you're telling me it's an aiming problem.
Okay, so if I drew a line on Google Earth from Greybeard, am I sharing screen or I am? Yes, cool.
I know. I can see in the black and white picture what you're saying.
Yes.
The yellow lines shoot off to the right, out of frame. I get it.
Yeah, so if I drew a line from Greybeard through this tower, that line will end up to the right of me, to the right of my observer position.
Okay? What does that have to do with his height or his position?
Okay, so, oops, where are we? Oops. So he is to the left of that yellow line. He is to the left of it.
Okay.
But his presumed location, where he said he was, is to the right of it.
How do you know
Guess
that?
what happens? Guess
How
what
do you
happens
know
if you
that?
move
How
left?
do you know that?
How do I know which bit?
Well, he's concerned about elevations,
Right.
and he walked to get to a certain elevation, which I think is what you work at.
Yeah, but he got his elevation from a barometer, which is inaccurate.
Meaning?
It's inaccurate.
By 700 feet?
No, I'm not sure how much. Maybe 100 feet? Maybe. I don't know. But his observer location, he said he was here, right? 1626 or so, 1625, thereabouts. If he moves to the left of this line, he's now 1640. Where are we? 1645, 47, 48, 50 even. He is somewhere over here, 70 to 100 feet higher than he said he would, than he said he was.
Google Earth, you trust the cartoon mode of Google Earth, bro? I'm just asking.
The cartoon mode, what do you mean?
Is that what you're showing?
Do I
With that
trust
line?
it? Yes. 100%, yes.
More than the reality, more than the real world picture.
No, it matches reality.
Yeah.
Yeah. Anyway, so yeah, he's not where he says he was. He was higher.
Or the cartoon is wrong.
Oh, okay. Okay.
You mean the map is wrong?
Maybe not. Just
the
saying.
map is wrong.
Yeah. Anyway, he was much higher than he said he was. This is not proof of flat Earth. In fact, if you then think about it, Greybeard, yeah, it should be the other way around.
Can I just, he says he's on Tennant Mountain.
Okay. Yep.
Are you showing that somewhere in this picture?
Tennant Mountain. Which one's Tennant Mountain?
Yeah, I mean, you think you'd be concerned because he says it says here, he then trained at Frying Pan Mountain, 6 miles in the distance from his position on the ridge at Tennant Mountain.
Yeah, hang on. Let me bring up the video that I had. That one. All right, his claimed observer location. So there's Tennant Mountain there.
This is your video, not his.
Yes, but I've overlaid.
But
right?
you're claiming his location.
No, this speech bubble thing here is pointing to where he said he was. All right, so I've overlaid this.
I can't see it. Is it Tennant
Yeah,
Mountain?
no. Tennant Mountain's over here where this speech bubble is. That's Tennant Mountain.
Okay, well, according to this, that's where the camera was.
He's this speech bubble here. He says my camera was here. So
Let
I've
me say
overlaid
this.
this.
Sorry, go ahead.
Yeah, I've overlaid this with all these high points, and I've matched up all the high points so that my screenshot overlays as best as I can get it onto Google Earth, so that where his speech bubble points to, that's where he said he was.
Yeah, that's in the mountains where they didn't do actual measurements, where they literally did, used line of sight and used triangulation and fucking all that stuff. That's where, that's where you're going to match a globe. Any measurements you ever get in real life that match a globe are going to be by mountains and in mountains, because that's how they mapped them.
Okay. Anyway, very simply, I've matched where he said he was to Google Earth.
Well, we're disagreeing on where he says he was.
Then go and disagree with John McIntyre, who has taken the video down.
Wait, what's the point though? What's the problem? If it isn't where it says it is,
because he's claiming an elevation. He's claiming an elevation which is wrong, and that just makes his conclusion wrong.
Look what you claim, dude. I wanted to run this one by you, Ruhif, bro. Yeah. You listen to Ruhif's claim, bro. How about this, man? I gotta call bullshit on this, or double check it, triple check it. Okay. Now Ruhif said that the freaking long distance freaking when I put it through the curve calculator with elevation and all that, I get like over 1.5 miles of missing curve. But in the debate, he said the 450 kilometer long distance world record is we're seeing exactly what we're supposed to on a globe.
Yeah. Yep. Yes.
In the
curve calculator, find out. Give me an hour, Brian. I'll be back. I'll go feed the kids. I would love to do
All
it.
right,
I didn't get to do it during the debate. Anyway, back in an hour.
All right.
Yeah, just put it in the curve
He went for
calculator.
the
dude.
big
See
meat
for
in that
yourself.
debate, bro. He didn't say like Black Swan or no shit. He went straight to the world record long distance photo. Is exactly what we would expect on a globe.
Brian, have you ever put it in the curve calculator?
I personally haven't, but I've watched Jaron do it, and I forgot a couple people do it, but personally, no, I haven't.
I would try it yourself, and then
let's do it together.
See. Whoa, dude! I thought you were married.
No, no. I mean, let's. What's the observer height?
Use the Metabunk curve calculator.
I'm
The
not
observer
using
height,
fucking Metabunk, dude.
I mean, it's a good one to use.
Mick
I'm just kidding, bro. We could use Metabunk. It's the math. It's the math.
Hey, Kosho.
What's up, sir?
An easy rule of thumb is 1 degree for 932 miles. So with that, you can use the distance and tangent, and then you can easily add on however much lift is caused by standard refraction, if that helps any.
1 degree. So in other words, if it's half that, then half a degree.
Yeah.
Is it scaled like that? So if it's a quarter of that, it's quarter degree. It's a 1-to-1 scale.
Yep.
All right. Sure about that? Just asking.
Yep.
Okay. Thanks.
What do you mean 932 miles? I didn't understand what that was for.
If something is 932 miles away, in conditions of standard terrestrial atmospheric refraction, it will appear 1 degree higher than it really is.
So in other words, under perfect conditions, we would see our own ass in a telescope.
Yeah. Standard refraction. They're still just throwing it in whenever they any distance, any weather. They don't even ask about the weather.
Then use it as proof. Then use it as proof in debates, bro. Then they go in debates and use it as proof.
Consider that if the Earth was really a sphere, you wouldn't best to have any fanciful art measurements, or you wouldn't even have to give us any kind of parameters. It would already be done, able to be checked by a 6th grade school student.
Well, if we're going to test observable reality against a given model, like say the globe model, we might as well test it against all of the globe model, not just part of it, and then straw man it that way, you know.
You're creating fanciful measurements, 1 degree over 900 miles, barometers, the theodolites to try to build your globe because it's not there.
I wasn't clear, Jesse. What observation were you talking about that distance?
He's just talking about refraction. Basically, you take the 1 in 1/6 or 7/6, and you take the 69 miles, and you multiply the basically the 1/6 basically, and that gives you just multiply 70 times 13. I mean, roughly, I guess that's what he did, or something like that. Or he did it exact, I guess. But he's just saying refraction over that distance. That comes out to 7/6R over that distance. That's 1 degree.
Okay.
Is that right, Jesse?
I didn't follow that, but if you're looking at a mountain that's 932 miles away, it'll appear 1 degree higher than it would without any atmosphere.
Oh, I see.
Due to refraction, right? Due to 7/6, exactly, right?
Right. Yeah.
Which 7/6R that's over at like for atmospheric or for our what's it called astronomical refraction.
No. You got to add that, bro. You got the regular drop depending on your height, and then you add 1 degree to whatever the geometric drop is. Right, Jesse?
Okay, fair enough. I wasn't asking about that though.
Yeah, I thought the sphere drops 1 degree every 69 miles, not 900.
That's something else.
Oh, it drops 1 degree every 69 miles, but then after 900, it appears 1 degree.
Yeah, on top of that.
Appears to be
that's
more
what they're
small,
saying.
Correct?
Yeah, that's what they're saying. On top of that, on top of the regular, that's why I tried to clarify. I figured somebody might ask that question. So on top of the regular drop, then you add
it's not
that.
A drop. It's a dip angle. You would add to the dip angle.
Whatever you want to call it.
The dip angle will take it down some, and then I guess that would bring it back up some.
But how do you have a 900-mile observation when we can't see that far?
I
Well,
think
it's
you're
just the
supposed to
math.
use that as a starting point.
Yeah, it's just
That's
a
why I asked him if he
fraction.
cut it in half.
Let him answer.
Yeah.
Let him answer.
No,
Because
no,
isn't it
no.
an exponential drop, right? So you couldn't take it, you know, divide by 9 ways. You have to measure the whole thing, right?
I'm not sure
You
what
got
your
to catch up.
question is.
You got to catch up, little Godric.
Well, he's claiming it bounces up 1 degree over 900 miles. But how do you confirm that without observation?
He's talking about the dip. The dip angle goes down some. The dip angle is not the drop. It's just a dip angle. The angle that the horizon is dropping from
How
you.
do we confirm his
And he's saying that
900-mile
refraction will bring it down 1 degree at 932 miles, and so it brings it up. So you take your take whatever fraction of that your actual observation is, and then take that fraction of that 1 degree, and then bringing the horizon back up that map.
I'm just asking, how do we confirm this 1 degree up over 900 miles?
That's just the globe model. I mean, it was measured by probably watching the angular position of stars. You know, when they're straight overhead, they're moving exactly 15 degrees per hour, but as they approach the horizon, they slow down. And so and then as they hit the horizon, they'll be refracted up a certain amount. And since they move at a constant rate, according to the globe model, and they were at a known position and time straight overhead, then exactly 6 hours later, when they're right on the horizon and they appear raised up, then the actual amount of refraction can be measured according to the globe model, of course. But we're comparing.
There's only a couple stars you can see on the horizon, man. Most of them you can't even see. But yeah, here's what basically in reality they measure, and whatever it's off, that's how they measure refraction. It's not vice versa. They don't measure the ground based on refraction. They measure refraction based on the observation. They don't even deny that.
Right, but that's what the globe model says. So when we're comparing observed reality to a model, we need to compare it to that whole model as it's intended, not just cherry picking part of it in order to strawman it and make it force it to fail, right?
Right, that's my problem with when you, not necessarily you, but others, not too many people in this room, but except maybe Zanuck and, but or Sean Hawkins, or try and hold us to just strict trigonometry, like going to use like refraction and use the drop, use the spherical geometry and whatnot, and hold us to strict trigonometry. No other variations or anything, like when we're trying to explain something. That's not fair. You know, like I said, I've never really heard you do it, but I've never heard you make that argument. But like, just to hold us to strict trigonometry with no other variables, you can't work on a flat Earth. Yeah, well, the strict geometry doesn't work on a globe either. There's factors, you know, there's corrections and fixes and shit, you know. So it'd be like that on either model. So don't hold us to just the strict geometry, you know. Not you, once again.
Yeah, and that's why I say, hey, you know, this is what I measured. If you think it works on a flat Earth, then explain to me how, you know. The problem is, though, to make my observations and measurements work on a flat Earth, you have to concede that light can bend to the tune of 8 inches per mile squared. And
Like
if
6.
What's that?
More like 6. Everything matches up to reality if we bend it at about 6 inches per mile squared.
Actually 7.
6.
Well,
no, I'm not going to argue 7 or 6, but
yeah,
but not 8. It's I mean, I started with 5 and it worked for some observations, like with the mountains and all that shit. But I wound up going to 6. I don't think I'd have to go to 7, but you could be right. But
yeah, I calculated it exactly from lots and lots of measurements.
I made an entire model a few years back with that observation. It's still on my channel, bro. Like 2 videos and with the observations and just with the 6 inches per mile. Well, the first one was 5 inches per mile squared, but I had to change it to 6 and made a whole model, a graph and everything. And then I come up with my new model, and I'm working on an even newer model.
Well, anyway, the issue is to make my observations work on a flat Earth. we have to concede that light can bend significantly. In fact, very well, possibly enough to also allow the black swan to work on a globe. So that's kind of the catch.
Agreed, and it would accumulate over distance, so it's very minimum over short distances. But yeah, over distance it accumulates. Yeah, 100%, man. And you would have to concede that light would have to make it appear flatter than it actually is. Not a ton, but about 18% or so flatter than it actually is. So yeah, so either model's got its variations, and you know.
Right, but the tiebreaker is we can measure in controlled environments which way light bends in a density gradient.
Right.
And
how many times have you heard me say?
Right, and the problem is we know that light bends downward in a stable density gradient.
But that doesn't make things appear higher like y'all claim. It does the opposite. How many times I got to show y'all that? When you get low to the ground with the refraction, it makes the bottoms disappear. So your laser light appears halfway up the city. With the way y'all do refraction, it makes the laser light higher. So my crosshairs, that pretend the laser light is crosshairs. Now look after you add the sugar water. Where's the laser light now? It's halfway up the building. So my crosshairs would be halfway up the damn building.
Can you see that picture I just tagged you with in the live stream?
Oh no, not the blurry one with the background with backed away from the fish tank picture.
I don't think so. This one's pretty clear.
I'm just saying, I'll show you time and time again with Ranty's, Brandon's, with Mick West. Hold on, let me look at your. I've seen the one you showed with the shit in the background where you backed away from the fish tank.
Right. So the question is,
what's with the two ball?
There's a little one-eyed guy looking at the laser. Does he see the laser higher than it really is, or at its correct location?
If he's got crosshairs where that one-eyed guy is, if he's got crosshairs looking to the laser where it's coming from, he's going to see it halfway up the building. If you put a little skyline and before you add the sugar, you shine the laser, and then after, sure, it bends down, but it doesn't make things appear higher. Okay, it's been shown over and over again that the crosshairs are going to see that laser way higher, just like in reality. Just so that proves a flat Earth, right?
Also, Jesse, you'd have to shoot your laser upward to get it to land where it landed. In other words, we're shooting level, so a downward arc on our laser would bury it in the water.
Right, but remember when we're looking at a mountain or a building or something, it's shining off light in all directions. So the light that comes straight at us but dips down and hits the ground, we don't see it.
But you understand you're shooting upward here.
Well, it's just one of many rays, right?
Are you level or shooting upward? Why are you shooting up? Is a better question.
In order for that ray of light to reach
That's
the
a
observer.
CGI, man. That's CGI.
Actually, it's a
You
real
gotta shine
tank.
you got to shine at a slightly downward angle.
Wouldn't I have to shine my laser upward to get it to reach the other side?
Doesn't
and
do
wouldn't
that.
I have to change my angle to get it to go different distances?
If you have downward refraction, you have to shoot high to hit your target.
I don't do that though. We just shoot straight.
Well, you don't know that because it's a fraction of a degree, and you really don't know with.
Gosh, if it's visible across 40 inches of a fish tank.
Well, anyway, this wasn't. I'd love to talk with you about it another day. It's past my bedtime, but I was answering Brian's question. Brian, this one-eyed observer will see the laser higher than it is.
Yeah, that's what they told you. They fooled you, brother.
No, I tried this out. I looked through the tank myself, and everything looked higher.
No, it doesn't, bro. Put crosshair, bro. Put crosshairs, okay, in the tank, and your crosshairs are gonna see higher. You understand what I'm saying? In other words, if the ground is flat and we're seeing a little ways up Blackpool Tower way off in the distance, that's from refraction. That's what we see in the fish tank. Just check it if you don't believe me. Just try it if you don't believe me. I've got a little bit bigger of a fish tank that I just got to clean it out and re-grab the sugar. I bought some sugar, but we used it. But I'll do it too, and we'll compare results.
By the way, salt works good too.
Sugar, yeah, salt's probably cheaper, but I'm just gonna go with the sugar like everybody else. But either way, I recommend. My tank is considerably bigger than all of theirs. I don't know if that's gonna make a big difference, but same results so far. I want to see it in reality, though. I like to see it in reality before I just keep backing up the claim. But they all showed the same shit. Our crosshairs would show higher up the building with a flat line of sight.
But doesn't that? So you're saying no? That's not right. Downward refraction makes things look higher.
That's what they're telling you. So let's put it to the test. Like I'm saying, I've already showed Mick West and Ranty's and Brandon's okay. The crosshairs appear higher. Okay, but maybe they're wrong. Maybe I don't know. Let's do it. Let's me and you do it, and let's compare our results. In a week or two.
Okay, I already did it. So you go ahead and do it. Let me get you. Have you seen my videos on the fish tanks and stuff?
I seen where you backed away from it and showed something back across the street, up here a little higher.
Okay, so it made it look higher, right?
Yeah, but you backed away from the tank. I'm saying let's do it. Let's stay within the refracted zone. Let's not go through multiple layers and in and out. Let's put the city skyline inside the tank, and keep all the variables down to a minimum. And let's I wish we could even use maybe underwater camera, but we ain't got to go to that great a length. I guess not. But let's go down toward the bottom. Let's represent a person standing on Earth with line of sight, and let's see where the crosshairs wind up.
He did it a few times. Try and watch his stuff just in case you missed something.
I've seen it. Maybe not all of it. I think I have, but yeah, I seen what he had to do to show shit higher. He had to do a little finagling.
And then Jesse, since I've already done Salt and Sea, I need you to bring a shitload of salt.
And some glass. Don't forget about the fish tank that you're looking through. Put water in a glass. Put water in a glass and view an arrow going behind it. It changes direction. They can't be kidding us, right? I lost interest when Ruhif said you can't extend the straight line segment. It's not possible. What a joke.
I take you, Brian, with a picture. This is showing a view through the fish tank and not through the fish tank simultaneously, so you know what the fish tank is doing. Can you see that?
What's your fish tank made out of?
Whatever lensing effect is not refraction right there. That's just lens. That's a lens.
That's just lens. What's your fish tank made out of again?
Flatonite.
What you got in the fish tank?
Liquid flatonite.
Yeah.
Flatonite. That represents about what? If we're going to scale that represents like about 11, 12 miles in the air. I'm just saying. I want to do it down toward the bottom. We would expect what you're showing is exactly what we expect, and on any world, toward the top of the tank, looking down, or level even through glass and water. But what I'm asking you to do is let's try and mock reality. Let's try and recreate reality as close as possible. Let's do it down with line of sight, real close. You ain't got to bury the camera, but down at the bottom, and let's maybe use a theodolite app or use an actual instrument. You have one, and film through it, and let's see what the crosshairs show. Let's see what the refraction makes us see down at the bottom where the refraction gradient is.
Well, okay, but what's wrong with what I just showed? We can see the house outside the fish tank, so we know what the actual position of the house is. and then we can see the house through the fish tank on the left part. And this is just one picture. I just put the camera so it was seeing on both sides.
Yeah, what
The
that's
house, does the house appear higher or lower due to
higher.
the okay.
Higher, bro. Higher. Would a fish
It
appear
also
higher?
appears smaller.
Would a fish appear higher if we're looking in the water? Yeah, I'm not denying that. I'm trying to recreate a density gradient and what it does to light. Not at the top of the tank. I'm talking about down where the gradient is at the bottom.
This is in the gradient. I had super dense saturated salt in the bottom, and then fresh water on top, and then a gradient where they mixed in the middle. And that's where I have the house positioned, is right in the gradient.
So why do you think the house is smaller in the tank?
Because the gradient has more lifting power down at the bottom part of the house, and it's pushed up that bottom part of the roof.
I asked why it was smaller.
What's that?
You got to show the laser too, bro. You got to show the laser so we can see the density gradient, but also you got to do it down toward the bottom also, you know. I would expect nothing else. You probably would do that even without the salt, bro.
No, actually.
So, really?
Yeah.
All right.
By the way, this one's not even salt. This one's just hot and cold water. I'm sorry. This one's just cold water on the bottom and hot water on the top.
So it would do it without the salt.
Well, yeah,
No,
but if
it wouldn't. No. Oh,
you
yes,
need,
this one would.
well, you need something.
joke.
You need something to create a density gradient. You can use salt. You can use sugar. You can use hot and cold. I was using hot and cold on this one, but I have one that I did it with salt too. But you need something.
You're showing something outside of the fucking refraction that you're trying to create. You're showing something in the background, and you're backed away from the fish tank, bro. That you are totally okay. I'll give you something. You did something, bro, but it's a little bit slick if you're trying to use it as some kind of proof, bro. Because look, you're shooting something way in the background, outside of the refraction gradient, and you're backed away from the glass, so you're shooting through 2 layers of glass. Different temperatures of water. You did manage to do it, so kudos to you. But look what you had to go through to fucking show that. I mean, shouldn't you have just been able to do it within the fucking medium that you're trying to prove? And so kudos that you did it, but trying to use it as proof is to me a little deceptive, bro. I'd be careful with that.
So highly exaggerated. The gradient that you're creating is so highly exaggerated. You know, and everything you're doing just it's not replicated in the air unless there's weather to get that much moisture in the air
Or a temperature difference. Didn't I give you the link to my video about seeing over the signpost that was above the observer and the target?
It doesn't show the ambient conditions.
I don't.
That's like the guy who did on this hot driveway. Like he shows it hot and blocking it, and then cools it down. Like that's the ambient conditions, bro. I want to see the ambient conditions.
Just
that
to
guy.
be honest, I'm staring at this and staring at this and staring at this. I'm with Rakia. I can't compare that to real fucking life. Why am I looking at this?
Can
Okay,
you post?
I
Can you
dropped the link.
post your horizon that's above your crosshair?
Yeah, sure.
Yeah, post that now because you realize for years I said that happened and people called like you, like in your group. You know, people that are here today called me stupid for saying that. And it took me 2 years to get one of their own to post it.
I made a video of them showing it and claiming it a while back. So me and you was in the same boat, Rakia.
Actually, that last video I
Sit on the
posted shows
cross
that,
for a little
Rakia.
bit.
But ignore the crosshairs on the right-hand inset. That was just some B-roll footage from a different day, and the scope was pointed just at some random position.
This is crazy. You know, I'm looking at
You
all
know
the
where it
pictures.
is, just take a snapshot.
What's that?
You know where it is, just take a snapshot.
Okay.
I can't believe we're arguing so much about optics when the properties of water are not really in dispute.
There you go. Oh, I forgot to tag you. There you go. On that left-hand part of the picture, the crosshairs are straight out horizontal, and you can see the horizon is, and in fact, water itself at the shoreline is high above eye level.
What do you mean straight out horizontal? How did you
Perpendicular to plumb.
level at what height? You mean level and at what height?
Oh, a couple feet, few feet above the water, not much.
Okay.
But you can also see that everything's compressed vertically too, compared to the picture on the right where it's not compressed vertically.
The picture on the right is magnified.
Yeah, one or the other.
I mean, who do you think you're talking to, man?
Jesse, you're naughty.
Rookies. Yeah,
There's another one.
He's practicing on us, Rocky. He's practicing on us, man. Motherfucker. And I was just kidding. Excuse the language.
A joke. I mean, it's actually a joke. Like Dan was saying. So what are we doing?
Here's one also that shows the horizon itself above eye level.
What? I'm still looking at this other one. You're saying it's compressed on the hot day?
It happens a lot at the beach. Just a little bit of, not a lot, but it happens.
But the center
Sometimes,
building,
especially with a storm. If there's a west wind blow, bro, it's
yeah, but the center building appears wider. They're appearing more squat, but they're also wider. So there's a different form of manipulation there.
Well, he might be at a different angle.
No,
Different
same
view.
location. Yeah, no, same location.
Well, then
It's
he's
just
right.
there was vertical compression going on that one day. And let me find another
so
screenshot.
not earth, so
And,
not earth
and
curve,
horizontal
right?
stretching. Horizontal stretching and vertical compression? Sorry.
Optics, not earth curve, right? Optics.
Right, this is optics because on this day with a line of sight 2 feet above the water, the line of sight caused the horizon to appear above eye level.
Yeah, so it's not earth curve, it's optics. Welcome to Flat Earth, Jesse. Drinks are in the
Yeah.
front.
Also,
snacks
look
are in the
at
back.
the shoreline. You can tell the magnification by the shoreline. Look at how much shoreline there is. Yeah, you got that all fucked up, Jesse.
No, I don't.
Okay.
So here, I'm going to post another snapshot here.
It's not the same shot. Don't do that to us. It's not the same shot. It's not even close.
Just to clarify, so if we have a ball Earth with a curve, so a big hump, and then we have something that's behind the hump, down below it, the light from that object that's down behind the hump is going to bend down. And that's going to cause it to actually bend up over the curve and come to us.
Okay, so Dan, in this picture, you can see, it's hard to see, but you can see a signboard just on the shore there, and it's got a circle on it and an anchor and a line through it. It's a no anchor. It tells ships to not drop their anchor there. Maybe they have a telephone line on the seafloor there. I don't know, but you can see that that circle is oval. So that's one reason I'm pretty sure that the buildings are being compressed on that picture instead of being stretched in the other picture.
It's just that, one is more zoomed than the other, and you should, it doesn't have to do with the temperature. It has to do with the zoom as well.
You put hot day, cold day. Anytime you have obstruction, like a drastic obstruction, it always is accompanied by magnification, and it does happen more on hot days. But that you happen to catch a couple days, it mixes, bro. I thought that's what I thought at first a long time ago, but it happens both ways on hot days and both ways on cold days. But to me, it is more prominent on hot days. But that's a lot, bro. Like that is a lot. But so not Earth curve, right? Just optics.
Right. This is just
We're in
optics.
agreement. It's all just optics, bro.
Well, no, I don't think that's a logical, good conclusion. Just
Bro,
because
you
there's, yeah, just because there's situations where refraction can cause great variation, that doesn't mean that there's also situations where it doesn't. Which is
You
why I
told me it
bring.
happens every single day.
Was
Well,
it a hot day over the frozen lake?
there was no frozen lake here.
The one that I just posted is over a frozen lake. Was
Oh.
And you
that
told me it
day?
happens every day.
No, I did not
Wow.
say every day. Why do you keep lying?
Nope, I told you that there's actually a location where Canigoo Mountain should be obstructed by Earth curvature, but you can only see it 2 days a year because of the annual path of the sun setting behind it. So on those exact 2 days every year, they see the mountains as the sun sets. And is that just because of coincidental refraction? And you said that it would happen pretty much every day, and that it would be a rare anomaly that it didn't happen.
I said it happens frequently, and you keep telling people I said it happened every day. Thank
Pretty
you for
much every day, yeah. You said that it
Yeah.
would be a huge rarity that it didn't happen. Now it's just a rare occasion. So you just get to run around the internet double speaking, I guess.
That's the same thing Xanax says. Same script.
By the
Just
way,
whatever conversation you're in at the time, huh?
where was the observer, or what was the observer height, by the way?
In such a height that the Earth's curvature should block the mountains.
Did the line of sight pass near the surface of water if the Earth is a globe?
It was many feet above the ground, and we looked out and saw mountains that should be below the Earth's curvature, and you claimed that it happens pretty much every day.
But I've presented to you evidence that line of sight passing near the surface of water can very readily bend down enough to allow you to see over obstructions, right?
So we are back to it happening every day.
No, but I said it can.
Well, you actually said pretty much every day, because the whole point was if you think it just can occasionally happen, then it wouldn't just coincidentally always be on the same 2 days that the actual path of the sun set going behind the mountains lets us see Canigoo every time.
Well, why not? That's 2 days out of a year. That could happen 2 days out of a year. It could happen 20 days out of the year, and that's not very many, but it still could have been those two.
Whoa. So if it happened 2 days out of the year, it just so happened to land on the same 2 days that the sun sets behind it every year. Holy sh...
Well, so how high was the observer?
This just keeps getting worse, bro.
Yeah, you make these big claims, but you don't bring actual evidence.
Says Mr. Doublespeak, who just said that it happens pretty much every day. Now we're back to it could just happen 20 times or 2 times a year.
Hey, can you explain to me what you mean about the earthquake waves not
Oh,
wrapping
you're just
around
imploding
Antarctica?
now, dude. You're just totally imploding. Can you address that you were just telling them that it's just like a rare occasion that there would be a fraction, and now it is every day?
You're all or nothing, aren't you?
Which one is it, man?
It's frequent.
So, but why'd you just tell them? Why'd you just say it like it was just every once in a while?
I was countering your argument and saying that it could have happened as little as 2 times. Even if it
No, the
happened
only reason I
20
jumped
times during
in,
the year, it still could have fallen on those 2 days, and it doesn't mean it
yeah, I
happened
get it. You
every
sound
day.
religious. I'm not putting any money in the plate. So, the only reason I jumped in was because you were telling them that it was like a rare occasion. That was what your argument was. So then I jumped in to say, whoa, didn't you just tell me it happens like every day?
I said nothing of the sort to them.
Yeah, you did.
I just gave them videos and stills showing the horizon being above eye level.
You said that only sometimes that you'll get the refraction that makes it look like you see further than you should.
Sometimes I do, sometimes I don't. I gave them pictures of when I didn't also.
But when it comes to Canigoo, it happens on those 2 days every year.
So far, you haven't even provided evidence that it did happen on those 2 days.
Oh, all right, man. I get it. You can't answer.
Spot, bro. It's world renowned. for being able to see the mountain on them 2 days, Jesse. I don't know why you'd bring it up with that point. Maybe other observations, but Canada, bro, you're questioning
Did you hear
the
what he
tourist
said though,
spot?
Brian? He said that it could have just happened 2 days out of that whole year, and it just happened to land on those 2 days.
Well, you only
Yeah,
have
he is spiraling a little bit, but I mean,
you
he ain't catching attitude. He's cool to talk to, but yeah, he is burying. Go ahead, defend yourself, bro.
you only provided claims that it happened twice in a year.
That's what we're told for the tourist spot, and what if you look it up online, that you can go there, and twice a year, maybe maybe it's a gimmick, and maybe they're suckering people.
Yeah,
And maybe
all
somebody will
CGI.
post it. It's a big hoax. You can't see it when you go there on them
Yep, and
days.
it's CGI. Those spacewalks are legit.
So you're not
Wait,
gonna
wait, Jesse. Let me switch up a little bit and calm things down. Look, so his first argument, Austin, was we don't even need to measure the Earth. We can just use Habersign and measure a flat piece of paper. And if Habersign doesn't work on a flat piece of paper, Earth's a globe.
Oh wow.
Yeah, I know. I like the way he's thinking, like trying to come up with a test, but I said that's like me saying the Pythagorean theorem. Okay, if I use it on a flat piece of paper, if it works, then I prove that the Earth is flat. We've been trying to say geometry. Bev still does use advanced simplicity and uses geometry and provable real world measurements and geometry to prove that it's flat. I guess that's the Glober's way of trying to use spherical trig to prove that it's wrong.
Yeah, it's like a spherical formula, so therefore Earth a ball.
Yeah, with R in it.
So what do you think, Whitsit? Do you think there's any possible way that you could draw latitude and longitude lines in any configuration on a flat surface where the Habersign formula would accurately tell the distance between any 2 points on that flat
No,
surface?
I'm not retarded.
I told you what I thought. I thought, yeah, it'd be off by about 9 or 10 feet over 69 miles, and that's outside of the margin of error. So to test it would be, not non-realistic. And they say they can.
Why would I
these
apply a Habersign formula to a plane? And by the way, in case you didn't know, you know where we actually got the longitude and latitude lines from, right? We got the latitude from taking angles to Polaris from a plane Earth and then drawing concentric circles out from it. And then you took it, wrapped it around the ball, and made it a little like tube, and then flattened it, and boom, Mercator.
Added R, yeah.
But you're not answering my question. Is there any configuration of longitude and latitude lines that you could draw on a flat plane where the Habersign formula would calculate the distance correctly between any 2 points on that grid system that you created?
You're asking me if a spherical formula will accurately calculate locations on a flat map.
Yes, that's what I'm asking you.
Do you think that's like some type of home run?
All night.
Yes, that's my home run.
I'm
you
like
gonna answer it?
impressed with how dumb that is.
Cool. Are you going to answer it?
Yeah, I did answer.
It's
it.
self-explanatory,
I'm not
dude. You just
retarded.
said the answer, but in the question, of course, that a spherical geometry is not going to work perfectly on a flat piece of paper.
So if it turns out that the Habersign formula works on Earth, then Earth can't be a flat plane, right?
There you go.
Bro, I done told you 100 times.
Perspective, buddy.
Yeah, I done told him 100 times that I could take a flat, just my state, Florida, and measure it flat, real world measurements. Okay, so we're not going to question the tape measure, and then I could add R, and put circles extruding out, and add R and put it on a little dome or a hemisphere, and if I don't use Habersign, I'm not going to get the correct. Once I've applied a radius to my flat measurements, now I have to use a spherical geometry to get a correct distance because I've applied a radius, bro. What don't you? I mean, think about that one for a second. Once you apply the radius to your map, the measurements are what they are. They are what they are. Okay, but once you've applied R to the real world measurements, you've ruled out not being able to use coordinates like that. So in other words, if I'm matching it to a globe, then I've got to use the spherical geometry and haversine being one way to do it to get the right distance because I've applied R.
And of course, when you actually go further south, it doesn't work.
That's what I was trying to say. We'd have to go down south for it to be apparent because it's outside of the realms of being able to measure anything within that accuracy in the real world.
What a coincidence that when tons of people went out south and used this very thing, they ended up hundreds of miles off every time.
So Canagoo's not the world record anymore.
What a totally random, weird thing to say.
Never was. But did you hear about all the accounts in that one what you call it with all the different sailors? I think Cook, Mercator, and all the islands they claimed, and then like I think Cook went to verify it, like a 1,200 mile stretch of island they named after the royal something, and couldn't find it, so they wiped it off the map. And then I think Mercator went behind them and refound it. Like one of them would find it, one of them wouldn't, and they're all saying they were off by however many different amounts of miles a day. Then the guy went to 3 different cell nav schools and challenged them to go down by the equator. And I think Austin might be able to repeat it a little bit better.
Yeah, I
but
wrote
it's
3 different navigation schools, asked them a certain how it is they should navigate with a certain route in the north, on the equator, and in the south. And the 3 navigation schools gave 3 different answers. Yeah, you know what's funny though? You guys claim that they were using it and it worked the whole time, and in reality, it never worked ever in the south. And now we use GPS, which assumes the globe. Hey, guess what, Jesse? You could take a flat Earth. You could then take that data and make a globe. And once you force the flat Earth into a globe, you could then make GPS based on that globe. Very, very profound, huh?
So if I find a long straight highway and I get my car at one end, zero my trip odometer, take the GPS location for that, and drive 100 miles, whatever, hundreds of miles to the other end of this straight run, look at my trip odometer, take the GPS reading for my destination, and use the Haversine formula. Is that going to work? Is that going to match my?
I tried it with mile markers, Jesse, a few months ago, and I was off by almost an entire mile according to the mile markers. And I was almost off by an entire mile, like right before I hit 100 miles. And then I was off by almost 2 miles, about 1.75 miles over 150 miles. And I started to try it on the way back, and it was like off in its own way. I was like, it didn't make sense. Like, but even the mile markers were off. But if you sit there and measured every mile, it's so close. Like it could have been my tires or whatever. I'm just saying it's and to find a road that straight and to be able to measure it within 10 feet over 69 miles, it sounds like when we're talking about it, yeah, that ain't shit. But bro, we get out in the real world and start driving for a fucking hour, going 70, 60, 70 miles an hour, and you'll be like, dude, if you had a perfectly straight even surface, then yeah, we could do that. But that's like we'd have to go to salt flats, and the salt flats are flat.
No, they're not.
Hey, Ruhef.
Hello. Please go to bed, Jesse.
So we found ourselves every day from 12 to 16 miles by observation in advance of our reckoning. Our observations at noon, we found ourselves 58 miles to the eastward of our reckoning in 2 days.
You should send me the source documents. What's it? Send me the source.
Okay, are you actually going to read it?
I literally asked you 3 times in the debate yesterday. DM it to me.
I got money you don't read this. Like actual money that you
jackass.
won't read the whole thing.
It's just anecdotes from a flat earther's book in the 1800s.
It's not anecdotes, buddy. It's from their documented navigational charts. Why do you lie about everything you say?
So what did you say by their reckoning?
Hey, why do you lie about everything you say?
Did you say reckoning?
Hey, buddy, can you answer my question? Why'd you just lie?
I didn't.
You did.
Is the author not a flat earther?
You said it's just anecdotes.
Well, yeah, he's telling it's his word that he heard or said or saw or whatever, right?
No, buddy, it's the actual charts that you can verify.
Oh, I didn't realize. I didn't see that you had posted those. I only saw the book.
You do realize that. So you made up that the flat earther just made stuff up, but in reality, he specifically cites every single thing he says, and you can verify it. So you just made it up. Have you even read this book?
I
So
looked
which
through it.
Yeah.
12 to
See.
16
You
miles?
see what
Is
you
that one?
guys do, man? Weird.
Hang on, which ones do we look at? 12 to 16 miles or something?
The whole navigation section, buddy.
The whole navigation section. All right.
It's only a few
I will look
pages.
at it.
You can do it.
I will look at it, and I will DM you back. What's it? I will DM you back. Anyway,
So
Brian.
when he said reckoning, are we talking about dead reckoning or celestial navigation?
Oh, it sounds
Hey, how
very
do
much
you-
like Dead Reckoning.
Do you not see that they're saying that the actual charts were off? Do you not get that?
Do you know what dead reckoning is?
Yeah, the charts are what was off, dude.
Or they
That
were
wasn't the
dead
question,
reckoning?
Witsit. What was the question, Witsit? Do you know what Dead Reckoning is?
They were
Yeah.
dead reckoning, bro. They'd have been fucking. They'd have been off. They don't use dead reckoning, bro. But back then, this is when they were using cell nav, bro.
Yeah, well, Brian.
In the 1800s?
Brian.
Yeah, in the 1800s.
I don't know. It's the word.
How do you do? Oh, sorry,
Wait, hold
please.
on, whoa! You don't think they were using the cell nav in the 1800s?
Yes,
Not if
you
it's
do that.
cloudy.
You do that
Yes,
with
you
a
do.
Dead
Wait.
Reckon position, Brian.
Not if it's cloudy.
You do
Okay,
celestial
so
navigation
if
with
I-
a
so-
Dead
so
Reckon
it-
position.
If it works, okay. If it works, if the cell nav works and the stars, whatever, then do I report that I was off course? Was I off course according to the longitude and latitudes?
Sorry,
not
if you
sure.
got your position via celestial navigation.
But
Well, y'all
do you
should
not
read
know
into
that
it before you just go making claims. Y'all should read into it
have,
instead of
Brian.
just throwing
I know
out
how it
shit and
works.
seeing what
say the
sticks.
dumbest stuff, dude.
I
So
know how
dead
it
reckoning,
works.
you have to know your previous position.
Yes.
So when you're out there in the south, you're going to use maybe a landmark or something based on your nautical charts. You're going to
No.
consistently use a previously established position, which uses your nautical charts. And whenever they do that, and then whenever they actually use an established position, and then they compare it to what the chart said, they were significantly off. Do you guys
If you're in the
understand?
middle of the ocean, what landmark are you going to use?
You don't
Stars.
have
I said, I didn't say you
Stars,
had,
correct.
dude, you're making my point.
You
You
work
guys
off
never
your
get
last position fix is what
Yes,
you do.
you have your last position fix. And
Oh, how
then
do
you
you do
have
that?
an
Just said.
estimated.
How do you do
Then
that?
you have an estimated position based on Dead Reckoning. That's what you take into celestial navigation.
Yeah.
Dude, and he's acting like he's schooling me and shutting down the point or something.
Okay.
He's throwing
Again,
shit up
the
against the
question-
wall. They
Holy
just said
question-
three different things. They're throwing shit up against the wall, seeing what sticks.
Didn't say three
The
different
question
things.
that I asked Nathan yesterday was, have you ever done celestial
did.
navigation?
Jesse said it was
So
cloudy.
You've never done it. The
So
fact
I
that
will ask Witsit, have you ever done it?
you've never done it.
Yes, I have.
No, you and Bacon circle jerking your houses isn't celestially navigating.
Yes, it is.
No, it's
I got a
not.
position fix based on angles to stars. Have you done that?
I could easily do it.
Then show us, please.
Well,
We've
who
been
cares,
waiting 2 years.
Riff? Why are you dodging the point, bro?
Dude, you're just slow. I literally exposed this point in the Q&A, and you and Bacon looked like you were just stumbling out of a bar.
How
Looked
did you
retarded.
expose it?
You got so exposed. It cost a few bucks just to completely destroy you guys. In the form of
I must
super
have missed that. Please go into how you exposed this.
You
with celestial
avoided it
navigation.
every single time it was said. Could you even repeat it? Do you even know what it is?
I don't recall getting exposed with it. Can you please tell me what you're referring to when you say I got exposed?
Every single super chat.
So the ones directed to PhD Tony that I said I have no idea about geology? Is that being
Well,
exposed?
that also exposed
If you want to
for,
take a
like,
W on
that's
that,
not-
Witsit,
yeah, you were
please
there to
feel
defend
free.
the globe, but as soon as a question about the globe was brought up, you're like, "I'm not a geologist." But anyway,
take the
the
W on
other-
that one, Witsit. Please take the W. You need one.
No, I'm just saying you looked retarded, and then I gave it to Bacon, and then Bacon, you actually claimed he did answer it, which he didn't, and then you just
Don't
gave
take it
up
up with
and then,
me.
And then I gave it to Bacon,
Why are you taking
and
it
then
with
Bacon
me? I
also
don't know anything
repeated
about it.
and said, "I think that the I'm not a geologist answer was a good one." But I was talking about the thing relevant to this conversation, of course, which is that I
celestial
brought up the azimuthal grid, right? We have an azimuth and an altitude reading.
Yep.
Yeah. Yeah.
Yes.
Okay.
What's
so
the question?
that's how we took our actual measurements to the sky and have our coordinate system that maps out the sky, right?
Yep.
Wow. So and that is that always relative to the observer's position?
Altaz, yes. Yeah.
Oh, very fascinating. So, based on what time it is and what location we are on the Earth, we're going to see the sky in a certain way.
Sure.
And that's going to give us an azimuthal grid.
That's our coordinate system. Yeah, that's what we're using. Is our
So, we
coordinate
took
system,
that
yes.
coordinate system to map out the sky relative to the Earth.
Well, the sky is mapped out in right ascension declination, right? And then you
They
transform
started using
that.
ephemeris in the 1700s, dude. In 1767.
Brian,
was,
you're interrupting.
Okay. Yeah.
Sorry, I just wanted to point that out.
The sky is mapped with right ascension and declination. To convert that, to transform that to your observer location, first of all requires a sphere, yes. But yeah, that's how you get your Altaz
No, it doesn't, dude. You got to
This is
verify
so
any of these distances, bro.
No,
Brian,
dude,
Brian,
it
if I
doesn't
gave you a
require
right
a
ascension
sphere,
declination,
dude.
right?
Oh my God.
And you
What
told me where
happens
you
is we
were.
get data points from our observations. Then you guys say the reason we see the sky like that is because the Earth's a sphere.
Yes. Do you know what right ascension and declination is?
Are you saying that you can't take those readings on a flat Earth?
I asked a question. Do you know what right ascension and declination is?
Yes.
Do you know what the
Yes.
celestial sphere is?
Yes.
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 Okay. Right.
Uses
So
a flat plane. It uses a flat plane
No.
at the middle of the sphere to do the calculation.
it has an
Yeah.
equator. Yes, it has an equator. Right.
A
Do you
flat plane,
understand?
right?
The equatorial plane is a flat plane. Yes, Brian. Right. Do you
Right.
understand
So,
in the
so it's a
celestial
flat Earth
sphere?
either way, then, right, Rue? Just saying.
The equatorial plane of the celestial sphere is not the Earth, Brian. Okay.
It's where you do your calculations off
Yeah,
of
I
the
mean,
celestial equator, which is a flat plane.
You treat your
celestial
position as a
sphere.
plane.
The celestial sphere, if you understand what right ascension and declination is, then the celestial sphere has stars in every single direction, 360 degrees, every single direction.
Just because
How
you
is that
say that
possible?
doesn't mean anything to anyone with a brain.
How is that possible if the Earth
on a
is a
flat Earth?
flat plane?
There, see,
Yes.
there you go. See,
What would we see if it were flat, Riff? Tell me what we would see if it were flat.
If you accept the celestial sphere, then there are stars under your feet.
And he
anywhere
thinks that's
on a flat
actually
plane.
a good argument, dude.
Well, then you don't understand what RA and deck is.
Wait, Roof, watch how easy it is.
I asked you whether you understood.
What if our eyes were round?
Roof, let
What
me
if
guess,
our eyes?
equatorial mounts prove the Earth's a ball.
Do I think they
disprove
do?
a
Yes, they do. Yes. Oh,
They
Jesus
disprove a
Christ.
ball.
See, Roof, it's so like you're like 2015, dude. It's like not. Let me guess. There's no sunset possible on a flat Earth, and there would be no horizon.
Correct. Yes.
See what I'm saying,
my
bro?
God.
It's the dumbest.
Come on, man. Why would you
Show
got to
us
say
how
there
it's
wouldn't be no
possible.
horizon? Come on, dude.
The
Let me guess.
horizon
The
is
sun's
the point at
insulting,
which
man.
things
triangular
start getting
size on a flat
disappeared
Earth.
bottom up.
Let me
Well, you
guess. The
got good
sun's
arguments,
change
man. That's
angular
just
size.
insulting, Riff, man.
Brian, stop your yapping in the background.
Who's that?
No,
Zanuck?
Brian,
Who was
I
muted
actually
all
came-
day? And
I actually came to talk to Brian. I came back to talk to Brian.
Yeah, just a point. I want to point one thing out that we were just reading through the book that you're probably not even going to read, but we'll see. Maybe you'll prove me wrong. And
Just
you
poison
guys,
the well some more with it. Just keep poisoning the well.
You guys brought up that dead reckoning. You were like, did he use dead reckoning or celestial navigation?
Is that mocking?
They're used
Let me
together.
just say something, just so we all
You
know.
really have to do that.
Ruhif, I
They're
made a
used
horizon.
together.
Ruhif, I made a
Yeah, that was
horizon on
my
a
point, buddy.
checkerboard on my kitchen table right in front of me, and you can do it too. Just bring your eye down to the table, and you'll see at some point you can't see more checkers. That's a horizon.
That's not the horizon. If flat Earth, a flat Earth horizon would just be faded off into the distance. How do you get a hard horizon on a flat Earth?
there's no hard horizon until you zoom in. You're just
Because the
enlarging.
angle is
You're
too
just
small.
enlarging what you just described. What you just described, not a vague looking position. That's what we see. Until we zoom in, then we can see it a little harder. But we're not changing the horizon by zooming. We're just enlarging what's already there, right?
The only place
So-
that ever even kind of
Hard
looks like
horizon,
a hard cutoff is over water when you'll have that reflective effect where it'll look like the water's mirrored up.
Yeah, and magnified.
Yeah, and
Anyway,
it's still kind
Brian,
of blurry
can
in
we
reality,
do
but you
this?
guys don't go in reality.
Can we do this so I can go and change the sheets. On
Can
my
you
bed.
guys? Can you admit that you and Jesse's nonsense about acting like reckoning and somehow was a rebuttal to these sellers being off was ridiculously dumb?
I haven't read your sources yet. I asked you to send them to me. Right, I'm going to read it.
Okay.
Well, at least Ruhib said that. Like I said, they were throwing shit up against the wall, which maybe I do that sometimes. But still, Jesse said maybe it was cloudy. That was funny. I heard.
Yeah. We
still
use
haven't
Dead
told us
Reckoning.
Yeah, you still haven't told us what dead reckoning is. Tell us.
That was funny though, man.
I literally
Maybe it
did
was-
say what it was.
Maybe it was
Tell
cloudy.
me.
Please,
I
please
missed
tell us
it.
again.
I'm sorry.
Oh, so both of you don't remember?
I didn't hear it. Please,
didn't
please
hear
tell us
it.
again.
Sorry. I
It's
missed
funny
it.
that you guys do that.
Tell me what a compass rose is, and I'll tell you what dead reckoning is.
Just wits it,
Y'all
please.
couldn't even tell me what due east is. Y'all didn't understand due east is a great circle. Took me forever to. I still
explained
don't know if y'all realize that.
I quite literally explained that it's a form of navigation using a previously determined fixed position, and you travel relative to that. And of course, in modern times, we use GPS, and then you try to use your speed. You try to, if you're close to a landmass, it would be ideal that you use like a known landmass's position. And you can't just separate dead reckoning from celestial navigation in entirety. Certainly, when you're out in the Southern Ocean.
Yeah,
I
because
said
you're trying to
all this.
maintain a straight line the best you can anyway, right?
Right. So we agreed Dead Reckoning is taking a known position and then using like speed and direction to work out an estimated position, correct?
Yeah, and trying to
We agree?
maintain a straight line, trying to maintain a straight
That's
heading.
what they do in reality for the celestial navigation is they use a dead reckoned position to estimate where they are and then take angles to stars and work out an adjustment, right?
Yeah, they
That's
do the
how it
best they
works.
can. There's a couple methods, but that's non sequitur, bro. If they're checking their position due to the stars and charting, these are accomplished. These are motherfuckers who sailed for years in the north and never had this problem, Riv. And they're
I
using these
guarantee you
stars
they
in the
use it,
south,
right?
and they're not lining up, bro. And these books aren't really readily available. Like they're kind of hidden. They ain't just throwing them out there in
These are
front of our faces,
specifically
bro.
like lieutenants and captains and veterans mariners and like these are people that have sailed their entire life, and that they explain that when they use the globular assumption of symmetry in the north and the south, when they get to the south, they have tons of issues being way off using those nautical charts. And then
We will see.
we progressed to a world where people use GPS. And now you guys on the internet pretend that all that time before GPS, it worked perfect in the south and that it still does. And in reality, when you're really going to get the discrepancies is when you get significantly further south, closer to 55, 60 degrees south latitude, which is probably just a coincidence that in 2023 you can't privately explore even on a ship in the water past 60th south latitude.
Okay.
And why
Anyway,
would
Brian,
63 degrees be
can
the
we do
lowest
this?
star?
I've got shit to do. Brian, can we do this? So I got shit to do.
Yeah. Go ahead.
Okay, cool. All right. Can you see my screen?
Okay, did you go do the spherical or the check the drop or check the hidden?
Yeah, we did that on the debate, right? There should be like, was it 80 meters or something visible? Something like that.
Okay, so
Some of it should be visible. Right.
just so everybody knows who wasn't here, yeah, let's look at so the Ruhib claimed in the debate. I'm questioning it whether the world record 450 or 475 kilometer long distance photo, the world record should have no hidden height.
No, it should be visible, not no hidden height. Like most of the mountain should be hidden, but there should be some visible.
I, for one, am going to be super surprised when he brings up refraction.
No, it's standard refraction. Standard refraction.
Wow, that was hard to summarize.
Yeah, cool.
Even with standard refraction, I want to see this.
Yes. Okay. Yeah, this has nothing to do with refraction, really. All
Okay,
right,
you
so
got 443 or 44,000 kilometers. Shouldn't it be 47,500?
I got the distance off Google Earth. If you have a different distance, I would love to know how you got it.
I thought the world record was 475 miles.
No, 275 miles.
I mean 475
km.
kilometers. I meant to say. I'm sorry, 475 kilometers.
273.
275 miles. 443 kilometers.
How many kilometers, Austin?
443.
Okay.
Yeah. Anyway, Yeah, so on the screen, I've got like an angular size calculator, right? This is the test of whether you accept perspective, which I'm sure that you do.
Why do you got angular size? I wanted to see the drop rate, but go ahead, fuck it. You done did all
anyway,
this.
the distance 443 k's and the height of the mountain 3,883 meters. All right, so the angular size, if you plug that into an angular size calculator, is half a degree. Is that cool?
You trust the okay, so I'm gonna let you finish, yeah. Okay.
Yeah, cool. All right. Second question: we can line up. We can make a like a horizontal scale by looking at the azimuths of each of the mountains that they've identified. Okay, and actually, there's an error. What's his name? Mark Brett, whatever, mislabeled Rock de Garnesia and Tate de Garnesia. These two are around the wrong way. Doesn't matter. Anyway, we've aligned all these azimuths and made a horizontal scale. Okay, so this is 47.75 degrees, 48, 42.25, 48.5. All right, so this much is 1 degree. That's how much 1 degree of azimuth is. We can also do that vertically.
Wait, how are you applying azimuth to I mean all the azimuths would be different if they're different distances. They'd be slightly different, right?
What do you mean?
I mean azimuths wouldn't be the same if they're different distances, right?
It doesn't, the distance doesn't matter.
Okay.
I'm not sure what you mean. Yeah. These are the azimuths to these mountains.
Okay.
Right. Anyway, so you can do the same thing, is make a vertical grid as well. So I've arbitrarily put the 0 degrees here and 0.25, 0.5. So these are all squares. Cool. So remember how big we said Pic Gaspard was?
Wait, is this picture zoomed in?
Yes, it's like
Okay, well let's make sure we take
1.5.
that in. Let's make sure we take that into account.
Yeah, horizontal field of view like 1.5 or 1.6 or whatever, and vertical field of view about 1 degree. Cool.
Wait, no, I mean what's the zoom? What's the millimeters zoom? 'Cause we're gonna
Focal
shrink
length,
it massively.
whatever 1.7 degrees is horizontal, and yeah, whatever that works out to be.
All right, we'll figure that out later.
This grid part's the trickery part. This is
It's
where
not a trick, Dan. It's not
Using
a
a
trick.
grid with a zoomed in photo. He's using actual distances and the sizes in the zoomed in photograph, and then applying it real world. We got to shrink it due to the zoom.
It's
So whatever he
perfect.
shows us, we got to shrink it like times 200. No, that's crazy.
These
That's
perfect
ridiculous. I don't know why I
squares
said that.
only exist right up at the camera. It doesn't exist
Hmm?
off distance. You're dropping perspective.
No, I'm taking perspective into account. We worked out an angular size of the mountain. This is
Good
how
luck.
much it takes
Come
up
up with
in
the
your field of
numbers.
view.
Don't give us angles.
You're
Come up
already
with the
scared of the
numbers. We
conclusion.
know what
Wow.
the fuck you're saying.
Yeah. So we worked out the angular size of Pic Gaspard was half a degree.
What's the numbers, man? He's asking you.
It's on the screen. Angular size of Pic Gaspard is half a degree, right? And I've put the 0 line at the top of Pic Gaspard. This is how big Pic Gaspard is.
It's
That's
a
how big it is.
drawing, and they term a half of the. We're asking for the feet. We're asking for things we can understand, right?
Rip, if you unzoomed, that's about what you'd see in the mountain, bro. Here's the thing: you're using actual distances and applying an actual angular size to a zoomed in. But you're making your grid and applying it to a zoomed in photo, bro. That's why every single one you've done like that, you've got these ridiculously low measurements, and they work better in the foreground because it's less distance. Okay, but still, even the ones in the foreground are a little off because you're using a zoomed in photo, bro.
He must.
This is how big Pic Gaspard is in any photo, regardless of whether it's zoomed in or not. That's how far it extends to sea level at the distance of Pic Gaspard. This is perspective, Brian. This is what it is.
No, it's not, bro. You're zoomed in. You're applying the angular size to a zoomed in photo. You don't get that?
Right.
I think
So we've got
he correctly,
less field of view.
I think he correctly calibrated it, Brian.
Yeah. I
So you think,
calibrated it by the
you
azimuth.
think the bottom of that mountain is A, lower than sea level?
Yes.
And B, You think it's supposed to just cover that much of our field of view?
Yes.
Except it's zoomed in, though, right? It's
Right,
zoomed
it is
in, so
zoomed
that's
in.
why it doesn't match. It
No,
looks
I've
so ridiculous.
like Jesse said, I've calibrated it against the azimuths. Go back a
Got
couple.
to do with it. What's that got to do with what I said to zoom?
This is how I work out the field of view of this photo.
I
The
know,
field
but
of
you're leaving
view
out-
is like, 1.7, 1.8 degrees wide and about 1 degree high. That is the field of view for this photo. So if the photo is 1 degree high, then Pic Gaspard will take up about half of that height. This is
Okay,
perspective, Brian.
Okay,
That's
say
why
like
the
with this.
question
Say
at
with
the
the Blackpool
start is,
Tower. Listen, with the Blackpool Tower. Okay, here it is. So, if I take that same angle from where the camera is, and I zoom all the way jammed up against Blackpool Tower, I'm not going to see the mountains above it no more, am I? Because Blackpool is going to block the entire everything behind it.
Right.
Okay. And now I'm just saying that to make a point. Okay. The more I zoom in, the less of this shit it's gonna not apply the same. It's gonna apply different. And my example is jamming up against Blackpool. The mountains are no longer gonna look higher than Blackpool because I've zoomed all the way into fucking the tower, so I'm gonna see nothing behind it.
and we can
Blackpool's
do
gonna be
the
higher.
same
It's gonna be
analysis.
way higher than everything, bro.
If you're close to Blackpool Tower, then yes, Blackpool Tower will appear higher than the mountains.
Even if I zoomed in, though, bro. If I zoomed all the way in where I had Blackpool Tower just filling up my whole screen, it's gonna in the photo, it's gonna look higher. I mean, if you're trying to judge the photo and judge the height, then it'd be a 90-degree turn to look up to the top of Blackpool. The mountains are gonna be way fucking lower. So you're trying to apply this angular size shit to a zoomed-in photo, bro. Think about that for a minute, man.
Let's do it to any photo, Brian. Let's do it to any photo you like. Find a photo and we'll do it again.
So you didn't understand what I just said. You think it doesn't change with Zoom? And I just give you an example where it changes fucking so much where you can't even measure it because you can't even see it.
It does not change with zoom. Pic Gaspard is half a degree angular size, regardless of whether you're zoomed out or zoomed in.
If I zoomed in enough, like I said, I would have just one little point of Blackpool Tower, and I would see nothing behind it at all. Because
if you want me to do this with another photo, I'll happily do it. I love this shit.
I know you do, but I would need you to do it thoroughly. And
Well,
now you got to hold on. You got to subtract the zoom. You got to do the zoom ratio, and divide it into the what you got there. Just take the zoom ratio, okay, and just divide it.
You're telling me what I should do, as if I'm doing something wrong, all right?
No, you're not doing it wrong. You're
I
you're
agree.
skipping a step. You're missing a step, I think.
Okay, if you think I'm doing it wrong, show me how you do it.
Okay, you got to find out the millimeter of that camera for me,
Yeah, of this camera. I suppose I could work it out.
or the zoom time, the optical zoom.
Hang on a sec. I've got a little calculator for that. My massive spreadsheet. Where are we?
Brian, you do realize that if we have
it's the wrong way around.
two
Hang on a sec.
things in the distance of a known distance apart, right to left spaced, and
Sorry,
we know
it's
the distance,
about 1,500 millimeters, Brian, roughly.
and we know the distance to them.
Okay, 1,500 millimeters. Okay, give me a minute.
We know the angle.
I'm listening.
Probably a bit less than that, actually. I'm just trying to
What'd
work
you say,
it out.
Rue? Jesse, I was listening. You cut out, but
Probably
what'd you say, Rue?
1,300. I think about
1,300 millimeters.
1,300-ish. I'm trying to get the aspect ratio right.
Okay, give me a minute.
Yeah, I'll work it out later, but approximately that.
But you do admit you have a grid based on the trig, the distances, the real life distances, stamped on a zoomed in photo, right?
Yeah, the distances don't matter. The azimuth doesn't change whether it's close or far.
I just gave you an example where, all right, just let me work this out.
Yeah. Anyway, I better go and do some shit in a minute.
Yeah, I like discussing it though, Riff, man. I mean, I'm sitting here obviously debating with you and all that, but I know you enjoy doing it. I enjoy looking at them too, bro. Just so you know, man. I like.
Yeah, all good. Yeah, find a photo that we can analyze together, and you do it your way. I'll do it my way. All right, I'll go. And Whitson, I love you. I will read your book. All right, see you guys.
Later. I hate it when I make an example and give a example that just fucks up the whole thing. It's so extreme. It's way extreme, but sometimes examples are good to just go to an extreme where, look, it doesn't work because I don't even see nothing above Blackpool because it's got my whole field of view blocked because I've zoomed in so far from that height. And they just brush right past it like, bro. But, you know, maybe, but I've learned some shit too, so who knows. But I'm going to apply this. So to do it correctly, you have to take, I'm going to divide the, I'm going to ratio out the human eye, you know, with the trig, basically what we would see with the human eye. And I'm going to divide, like I said, ratio it out to 12 and 1300 millimeters and apply it to the ruler he drew on the picture. And I bet it matches fucking right on, dude. That's my prediction, but maybe I'm wrong, but I'm going to try that. I'll give another extreme example. Let's say I've got a tree in front of me, 1 mile, 1 mile in front of me, and I'm on the ground at, let's say, 1 foot, and I do the and I get the angular size of it. Okay, and I determine it's going to be take up such and such grid. I do the sideways, and then I zoom all the way in. I've got enough zoom where I zoom in where I can't even see the trees filling up the entire screen. But I apply the grid. You know, it's the grid that I calculated to without the zoom. I just used the distances and the angles. Okay, now I'm only going to see like one little tiny I mean, the grid's going to fill the screen, and only a tiny part of the tree is even going to be in the grid. So if you wanted to draw a line down to where it would be, I mean, I'm just using an extreme example, so it's hard to go any further past that, but it's not going to work. That grid is not going to work to that tree if I'm filling my whole damn screen up with just a piece of that tree because I'm zoomed in so far.
Not if you change the angular size. No, of course it won't work.
The angular size is based on the distance and the height.
The angular size is based on when you change the zoom, you change the angular size, Brian.
Negative. No, he just showed that he used the distance of 43,000 meters, and he used the height. He didn't use the zoom, bro.
All right, yeah, that is true. If you use the distance and the height, you can calculate the angular size of the object. But when you zoom in with a camera, you're changing that angular size.
Thank you, Blue. That's what I was trying to tell his ass, man. I mean, that doesn't prove that. I mean, I'm not saying it's a globe killer or nothing, but that's what I was trying to say to him. We got to calculate in the zoom to get it correct, and it still might be bigger. You know, I want to see, but I think that most certainly has to be factored in. What's going on, Blue? How long you been listening, man? What were we talking about when you joined?
Oh, I don't know. I joined before Rue Hiff left and came back.
Okay. Well, it's gonna be hard for me to tell you what you're wrong about, man, if you don't know when you join. No, I'm just kidding. But I'll be honest, I thought he was going to go away, and I think he did and realized that. No, I don't want to put words in his mouth when he ain't here. I can wait. But I thought he was going to check the hidden height, because even when I seen it done, I seen Jaron do it and one other guy. But I'm going off memory. But I thought it was like even like a mile and a half of hidden height, even with refraction. But I thought that. But maybe I'm wrong. I'm going to check it right now.
It's a good assumption to make. But that's the best time to put words in his mouth, man. That's why he's not here. You get less likely to get caught.
Well, I don't mind repeating what I've already said to him, you know, but I don't want to bring up any new points or tell him he's wrong about a new point if I didn't present it to him first. So. That's fair enough.
It's funny, Brian, because I know you know sometimes when you're wrong, but your convictions are still so strong. I think you're like Jeremy, dude, where you like the game. It's like a game a little bit. It's like a sport.
Yeah, but when have you ever admitted you were wrong, bro?
I've been wrong all the time.
Yeah, like about the spiritual triangle.
Jeremy has kept very detailed record of every single one of those times, most likely.
Yeah, he tells me
He's got them all memorized. He's got them memorized, and he pulls them out when needed.
Yeah, he's mostly wrong about the times I was wrong. He'll still bring up when I was wrong, but yeah.
So when you admitted you were wrong, you were actually right.
No, I mean I admit when I'm wrong, but he brings up dumb shit that's not even I'm not even wrong about.
Don't make us have Jeremy pull your file, bro.
Yeah, don't pull my file.
It's very extensive. It's a very big file.
Well, the whole thing with the trains on trains, man, it's just too much. Trains. Who said it earlier? Somebody said steaks on a train.
Yeah, that's funny. But that's why I told him he should use bring it outside the train and use something telescopic at the front of the train, like say you have something that protrudes. I mean, theoretically, like 100 miles or something, or whatever, 10 miles or a mile. So something extends telescopically, just stretches basically like a joust, let's say, from the front of the train. So so that way we ain't just stuck inside the train. We can see it from inside and outside. So we literally see the train moving and we see the thing in front of it moving faster from both positions.
Yo, Mike.
Yeah, that's not how it works, though.
Mic check 1 2 3. Can y'all hear me?
Yep.
Loud and clear.
All right, cool. Thank you.
Yeah, Brian, it's not how it works. The problem is not about where the stakes are. The problem is about how much time has passed, and both frames have two different records at the time.
It seems like a lot of trouble, bro, to keep your Earth rotating around that sun.
You know, it's not work if you love what you do.
Kosha, what is the force that is actually controlling your gravitational force? Like, what is actually making the gravity do these things? Like orbit things?
The Sith.
Sith
Lord.
Is that it?
Yeah. It's gravity. It's gravity's force.
I know, but what is making it do that? What is making gravity do like cling things to balls and make it so that you spin around balls?
Well, actually, it's time dilation in that case. Because time dilation is honestly the cause for a gravitational time dilation is the cause for gravitational attraction in most cases that we know about, or cases we're aware of. Because because of the fact that an object like myself will have two different rates of time from my head to my toes. So yeah, it's a whole thing. But that's no one knows why masses warp space-time, but it does.
I don't think it warps anything. I think it just
you haven't isolated anything that's doing any of those things. You've just observed certain reactions and then created a model around it.
Well, I didn't do that. Einstein did that, and
I know you're just basically kind of repeating, in a sense.
If I had enough guts, I would build something, some sort of test to go against what he came up with, and I'd prove him wrong. I'd probably get a lot of acclaim for that. But a lot of people have tried it and they failed. So you have to say if you can't beat him, you got to join him.
Same fucking math, bro. How are you gonna? I mean, it's the same answer basically. So you have to stop the Earth. I mean, if you're taking it all the way down to its core, but plus you can't have zero and then infinity. Okay, so there's things, and they will lap you out of science, bro, and they will discredit you, and you think you'll get this award, bro. No, you'll get shunned, bro. No matter what you say, even if you had the best fucking proof in the world, they would not accept it, and you know that. But
If I disprove Einstein, if I disprove Einstein, I'll get laughed out of science.
Yes.
You sure with that?
I'm 100% sure. If you even challenge it, you won't get published.
You sure about that?
I'm positive.
Well, that's actually not the case.
You can't even challenge fucking Kirchhoff's laws or any of the shit, bro. If you challenge any of that shit, you won't get published unless you get lucky.
Well, many people challenge Einstein every year. Some of them fail. Most of them fail. Somebody might not fail one day, but yeah, I don't know what to say, dude. It's a pretty robust, strong theory, so it holds up. One day it might not. I don't know. I'm not going to be the one. I mean, I could be the one. You could be the one, Brian, for all we know. Come up with something that disproves it. But it's the same thing. If you came up with some theory, Brian, that held strong for 100 years, we'd have no choice but to adhere to it.
Just for starters, hold on.
Yeah, but Kosho, if I came up with a whole model that described, which one are your favorites? It's the unicorns, right?
For starters,
it's not my favorite. It's your favorite.
Don't his math?
Yeah. Is it the gnomes or like the elves or the unicorns? But whichever
it's
one.
Y'all's favorite is unicorns.
All of them. And and then these different types of unicorns push the matter in different ways. You got the big ones, the medium ones, and they push the matter around. But if I came up with a whole model and then I used a way to use some phenomena in reality that I'm going to call a prediction, even though it's not really a prediction, it's like a post-diction. I'm going to call that a prediction. Then I'm going to link this idea to that prediction, say that prediction is now linked to this other thing, which you're trying to say it's evidence for it. Therefore, that whole model just has to be accepted. And hey, if you can't disprove it, then it's true. It's kind of what you're saying.
No.
Right when you use infinity, he's disproven. You can't have zero and infinity, bro. That's an oxymoron.
Won't do that then. But no, Gio. You said no because so for instance, if you came up with a theory about unicorns and they were you were able to explain things that already we see to have happened, and also you were able to come up with predictions for things that you haven't yet observed or no one's yet observed, but your model predicted, and this happened consistently and hadn't yet been shown to not be the case, then I would have no choice but to hold, give reference to your theory you came up with.
Bro, the math is made to match reality, bro, but it's unnecessary, bro. That's why they don't even fucking hardly use it, dude. Because it's unnecessary. You're gonna get the same damn answers in reality. It's just adding in horse shit, bro. Like I said, once you claim infinity, you can't then put a zero at the other end. Infinite's infinite, bro. Zero is zero is a limit. And the infinity, like the black hole with infinite densities and shit like that, bro. It's in the mathematics.
Yeah, that's not in general theory of relativity, though. That's just a solution to general theory of relativity. And either way, those have been observed.
What are you talking about, dude?
Black holes?
No. Oh my God. No. I'm talking about you say that in the infinity. The solutions is what I'm talking about.
There's solutions that that alluded to black holes, and then they were observed. So what's the point?
Hey, Gio, I think I have a way of maybe saying what you were trying to say in another way. It's like there's a difference between a theory that's held up strong and a theory that's held strongly onto. Difference between a theory that's held up strong and a theory that's there's someone's making noise on purpose there. Who is that? I'm not gonna let me say it without getting some kind of paper crunching over it. There's a difference between a theory that's held up strong and a difference between a theory that's held up strong and a theory that's held strongly onto. That's what I was trying to say.
Oh yeah, that's a great distinction. Yeah,
there is a difference between those two things. It's true.
And it seems like these theories are held strongly onto rather than held up strong because they don't test, they don't check out. You know, it's just, they don't.
Sure. By the blind, maybe, and by the
by the blind, by the people that aren't paid to say that it's totally, you know, on the up and up.
Well, I just mean they're tested against. So like they're tested and verified. They're also given the opportunity to test and verify against. So it's almost like you have to think that the people who go up against these things, who haven't yet proved them wrong, you know, there must be something wrong with them or something right with the theory. Because if they're easily proven to be wrong and they're just wholly held on to,
well, no, if they're created,
anybody can just come by and knock them down.
But they're like carefully. A lot of them are carefully created to be unfalsifiable. So
I don't think that they're gonna be held to any regard if they're unfalsifiable.
It's just unnecessary math.
They shouldn't be.
To prove their shit. They make it match reality in the real world measurements.
Yeah.
And
if you're using assumptions, if you're using any big assumptions, then
exactly
and it really doesn't hold up.
What math is unnecessary, Brian?
Just saying it. If you claim that the Newtonian works just fine in the solar system down here to Earth, right?
Yeah, it does.
Okay, what's the fucking point then?
The point of what?
What's the point in the relativity and all that bending of space time if the math works perfect on a scale solar system and down?
Well, it doesn't work perfect when you get into relativistic conditions. When you get really
right, so
close to
exactly, so bullshit conditions. That's my point, Blue.
Okay, Brian.
I'm just saying I don't agree with it. I'm not saying, you know, maybe it's right. This is my contention. Okay, I ain't trying to sound like that.
For almost everything we deal with on a day-to-day basis, Newtonian physics gives a perfectly workable answer, perfectly serviceable answer. Not too many things require relativity. GPS about the only thing I can think of that I deal with routinely that needs it.
GPS didn't work. They had to bring in Ron Hatch. I put it in one of my videos where he had to.
GPS will not work if you don't take into account time dilation.
Right. Well, that's what they said, and he had to come solve it. Okay. Shit didn't work like y'all are claiming. I put it in one of my videos. I'll post it.
Well, there's nothing
Neither did their
stopping you
radar
from
bounce.
putting.
Neither did all their radar bounces y'all claim. Like
Well,
these
there's
radar
nothing,
bounces
nothing,
have
nothing
Venus.
stops you from putting wrong information in your videos, Brian.
Well, I just let them do the talking, bro. If he's the guy who built the system and fired the radars at all these different bodies, and they were wrong. Just saying, I didn't make the claim. Just showing the expert. I'm sure he thinks it's a ball.
Well, I don't even know who you're talking about, honestly.
Ron Hatch. I'll post a little short video. Wow. I just put in 443 kilometers. Or fuck, I might have put miles, which means I got to go back. But I put in for the height instead of 4,000 meters height. I put in 12,000 meters. Just went ahead and tripled it. But I might have got the distance wrong. Let me check. But even still, it should have been about 5 miles of hidden. But let me go correct that. Can I get a mic check?
You're good, Brian.
Thank you, man. So I put in the long distance world record shot. I had to change it to kilometers, which made a big difference. But still, I doubled the height. It said 4,000 meters. I put in 8,000 meters, and the top of the mountain should be hidden by damn near a mile, like over 3/4 of a mile. In that debate, Riv said that we should see like such and such meters of that mountain. I'm like, what? Like he went for the gusto, the long distance, but I found that hard to believe. But sure, they got reasons. But I knew something wasn't right. I knew I'd seen something that did not agree with that, and that would be the Earth curve calculator. Right when Austin brought that up, okay, here's 4 bullshit. This is hilarious, bro. Right when Austin brought that up about he was reading the about the captain's recollections or what he was off, and Ruhiv said that first he said they didn't use the cell nav in the 1800s. Okay, then Jesse said that that it was probably cloudy, and then Rip said that they're using dead reckoning, and I said, man, y'all just throwing shit up against the wall and seeing what sticks. Y'all just claim 3 different things, and then Blue said, no, they didn't claim 3 different things. I'm like, bro, that made 4 wrong ass claims in just 10 seconds. Like they just insta spiral, and then they regathered and shit. And I was like, dude, they're just, boy, they don't like that. They start firing what sound like facts when they say them. You know, I think Jesse might have been playing actually, or just throwing out a possibility, but still, just defending. Well, if they put as much time into scrutinizing, like NASA and all the claims, globe claims, and all this stuff, they spend as much time scrutinizing as they did defending, and time and energy. Man, think how far we'd be by now. They defend it to the death, no matter what, before they even know.
Good morning, flat earthers and left wing. Anyone? Anyone? Bueller?
There's no way they can get out of traveling, having traveled the distance. The photon traveled the distance between the two stakes in the ground, no matter what they say. That's how far you seen the shit he tried to do to get out of that. Like, it doesn't matter what you want to say. The photon traveled through that space in that guy's time. The guy on the train has a clock. He has the time. In that time, he traveled through the space of through the distance of the train. That's how it works. If you're on a plane, just because you're on the plane doesn't mean your clock doesn't. You didn't travel that time over. That distance over that time. It's ridiculous. The shit he's trying to pull to get out of this. At first, I was using the guy in the grounds clock, but then I saw the workaround for that with the time dilation and shit. So I'm like, all right, just use the guy in the train's clock, whatever. He still traveled that distance. Just because he's on the train doesn't mean he didn't travel the distance in between the two stakes in the ground. They lost, dude. It's fucking ridiculous. Einstein made up some shit in his head, and everybody fell for it. I mean, ask anyone. If you're in a train, can I time the distance with a clock on the train between when the train started and stopped? How much distance I traveled? It's fucking ridiculous. I can't believe people let this shit fly for this long. Kosho was acting like we don't experience traveling that distance and the time because the clock's on the train. The people on the train definitely experience. Either way, even if the relativity thing is true, the people on the clocks still experience traveling that distance in that time.
It'd be kind of cool to see this animated for simple people like myself. You just see like a cartoon of what's all going on.
Okay, use an animation in your head. You're on a train. You got a clock. I'm going to start the train and then I'm going to stop the train. Did you Did you travel that distance? Can we put stakes in the ground where you started and stopped and measure the distance and use your clock to see how long it took you to travel through those stakes?
Mm-hmm.
Yeah, that's it. It's real. It's literally that simple. Literally that easy. They have to deny something weird. It's weird, bro.
What do they have? What's ruining the party for them like that? Or
The party,
what
the
is it threatening for them?
ruination. Yeah, the ruination. Their whole paradigm. The ruination of the model is when you put a is now when you
So using
the
that's with the stake with your stakes.
yeah, the devastation of the model is when I shoot a photon from the back of the train to the front of the train and shoot stakes in the ground from when the photon left, from when we shot the photon, and then put another stake in the ground to where the photon ended. That's what destroys Einstein's speed limit of light, the universal speed limit. That ruins it right there. It literally proves it's wrong.
Yeah, I always thought like C was specifically light's speed, but that conversation I heard bits of seemed to lead me to believe that C was really the vacuum speed, but not necessarily for light. It's just
It's see, despite what Kosho says.
Okay.
This is not. I don't even believe this either. But despite what Kosho says, C is the constant speed of light in a vacuum. You put light in a vacuum, it'll constantly go at that speed.
Okay. Okay, that's
That's
what I
all.
thought.
That's all it
initially.
means.
And
That's
I
all
learned that
C
from
means.
K-Pax. So
Okay, that was a dope ass movie. Yeah.
it is because we can move in multiple ranges of C. And I was like, what does that mean? But yeah, I found that out then. But the why was Kosho trying to suggest that the vacuum itself is basically C?
The vacuum is C. He said.
I think he said the speed of the vacuum is really C.
No, the speed of light through the vacuum is C.
Okay.
Well, they do have their vacuum moving at over C, but that's neither here nor there. It's dark energy bullshit.
All right. Yeah, sometimes I'm not sure if people describing like peas and carrots or no, these are carrots and peas, you know what I mean? But they're together, but they're individual, you know what I mean? They're not blended. I don't know, man. Sometimes people's definitions get a little bit. So
It doesn't
Kosho,
matter, bro.
trying to talk to you. I don't know, man. I hear what you're saying.
It doesn't even matter. The train destroys their fucking photon speed. They can't. You can't tell me you're on that train with your clock and you didn't travel that distance in that time, according to you. Even if their whole time dilation bullshit, even if there is weird shit going on, like you're on the train, you have a clock. I have a time. If you have the train sitting still, and you were to put stakes in the ground, you would get C for the speed of light. That's why when the train's moving, it fucking ruins it. It ruins it for them.
Oh, okay. That's
once you move the train,
because can't move. Okay, because you're saying was it just
once
like
you move the train.
Yeah.
So if the train's standing still and you put the stakes in the ground, you come up with C with your clock on the train. But now you have a clock on the train and you put stakes in the ground as it's moving. You now have a larger distance that the light traveled through, but at the same time. Unless they want to say it slows down, like they can't, they're stuck between a rock and a hard place, pretty much, is what's going on here.
Right. Well, it's like they're saying like the maximum speed of a motorboat is like so fast, but then like we throw it in a river and the river's moving fast. Now what? Is that kind of the argument?
Yeah, they're saying light can only move through space at this speed, c. That's the max. That's the max speed that light can move through space.
Right.
That's as fast as it can travel. Can't travel faster than that. However, when you put it on a train, it's traveling faster than that, whether they like it or not. I can give a fuck what they like at this point. It's over for them. This whole bullshit relativity thing Einstein made up in his head is nonsense.
Like, I think I was about to fall asleep last night, and I was thinking to myself, like, for instance, like we have clocks, right? Clocks will regulate time, and we can both agree that in 5 minutes' time, it will be 5 minutes' time, right? But there's nothing to really measure the passage of time or to know if time moves slower or faster, given we're going to still record it at a minute, but can it last like Inception time and shit? You know what I'm saying? Like,
yeah,
like where the time is actually like, or it could be quick. Sometimes, I don't know, whatever. Anecdotal experience. Maybe it's got nothing to do with anything. But it's like sometimes a day is just fucking poof, it's gone. An hour is poof. Sometimes it lasts forever. Sometimes it takes forever to get to tomorrow. You know what I'm saying? I know that's subjective. I realize we're people, but is it possible that if that was occurring, like we couldn't, how the fuck would we measure it? You know, if it just warbled around, time feels like it's a little longer, a little shorter here and there. We're still gonna have clocks and they'll still work. None of that gets affected. That's just a weird thought too. But I mean, from a reference frame point of view, I like the putting it in a train. I mean, that makes sense. And you're slowing the light down, so it sort of takes the edge off of this. Like they just like they walk. It's like they walk in the throw the door open and be like, yeah, the speed of light is 186,000 miles per second. You know what I mean? That's what it is. And it can't go in effect. A certain kind of reverence and certitude that we base everything off of the speed of light. See what I'm saying? I find it annoying because they're not thinking about it in a rational sense. They're thinking about it in the mythical. So fast you can't even. You just have to memorize what that is. You have no concept, no clue of how fast that is. Anyway. Not trying to derail your point or mess it up. I'm just whatever. Just talking around this whole topic of trying to measure time. It's like so we can't really measure actual time. We just measure things that happen at a rate, and we say like, okay, we'll base clock off that. Base clock off the induction of a amount of voltage through a coil, and we'll say we get a tick 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 tick. We can base clock off that, or right, water dripping. Yeah, but it's crazy to think about too. You could throw in acceleration curves on your train as well. And I wonder what that might do. Is it moving at like? Do you start the experiment when the train's at maximum speed? You know, or in the idea that you're just shooting the light at 40 miles an hour, then the train is already moving at faster than the speed of light. Fucking brain games. Brain games.
No, you need to do a shoot light in a vacuum through the front of the train and have the train moving, and it's now moving faster than the speed of light. Because when you measure the train still, you know what I mean? If the train's not moving and you were to shoot stakes into the ground, you get the speed of light with the people on the time on the train's clock. There's somebody on a train. They have a clock. You get the light. They measure speed of light. But when a train's moving and they have stakes in the ground, it's faster. The distance becomes longer. That's its photon travel. It has to. But they have the same time.
Yeah. I mean, the light can't then slow down to its maximum. Right?
Yeah, the light's not going to slow down. The light's not going to slow down because the train's moving. The light's going at sea through the vacuum. They're fucked.
It can't drive 55. How do they fucking slow light down?
Use various mediums and shit. I think they said they got it to stop.
Or like light propagation, let's say you don't change the speed of light, but you have an infinitely long train, you shoot the light, and then you move the train backwards at the speed of light. It's like the photon really is never moving in relative.
Oh, that'd be dope.
Because right then you could take light down to zero in a way. Or something approaching zero. This is interesting. Interesting idea, man. It's interesting, I guess, because like we're not thinking about it at regular, like whenever, like if Chirality comes on here or whatever his name is, Nate, and then if he came on here and then he was talking about like, okay, we're in the car and I throw you a tennis ball and you're in the back, you know what I mean? If we start doing that, we're in real time, right? You start slowing down the speed of light, you make us have to kind of slow everything down in a way and think about it a little differently, you know, like in its frame of reference. Like when think about something happening in slow motion, it's a little different.
It's funny because they told me they're like if this was true, you would see the light hit the front of the train before the guy even flicked the switch. Right? You would see the light coming before you saw the guy flick the switch. But the thing is, you would see that anywhere you had light traveling through a vacuum and a person hitting the switch in the regular air because the light's going faster through the vacuum. So that should be the case anytime somebody flicks a light switch in a vacuum and you watch them flick the switch from a distance. You should see the light before they flick the switch. So I don't know why they said that.
Oh.
You know what I'm saying? If I have a light,
Yeah.
if I'm about to shoot a laser beam in a vacuum, and I'm at the end of the vacuum, and I watch somebody flick the switch, I should see the laser beam before they flick the switch because the light's going faster through the vacuum than the air.
I mean, it's only going to start to go through the vacuum once the switch is turned on.
I mean, I don't know. They say you would see it before, so I don't know. The thing is, though, when you're on the train, the speed of light coming off the person is also has that 1,000 miles per hour added to him too. So their point doesn't really make any sense because either way.
Well, it's like putting headlights on a spaceship, right? You're already moving it faster than the speed of light, right? Because in itself, it's already moving. Where everything's already moving at 1,000,000 miles an hour already. There's some shit, man. I get lost in these reference frames because they're sort of meant to lose you, I guess, in a way. You got to be very, like, you got to hold on to them. Oh, man. it's just hard. It's just tough to mess around with these like light. Like I just one thing to think about physics, you know, and then like try to bring light into this reference frames thing. Whoa, talking.
Dude, they try using a reference
It's like
frame so
juggling.
bad. They tried using the reference frame so bad to save him for this, but they can't because the guy on the train has a clock and he traveled the distance we have marked in the ground. Like there's no reference frame, nothing can. There's nothing you could do.
Right. Right, because
Like if
you're
you're on
marking the outside reference frame. You're
if you're
using
on
the
a
stakes
train,
to break the reference frame in a way, or
if
to
you're on a train,
notate out of it. I'm sorry. Go ahead.
that's fine. If you're on the train and you have a clock on the train, you know how much distance you traveled from outside your reference frame. Obviously, it's the only way to tell how much distance you actually traveled. This whole that thing with that thing Kosho was saying last night with it's different reference frame, so you can't use that distance in the clock. It's like, dude, that doesn't make sense.
Well, it's literally like you're punching through the core reference frame to get to an outer reference frame, and then mark it there with the stake idea.
Yeah, the stakes ruined him. I only used the stakes because he tried to use the Lorentz contraction, but it ended up ruining him anyways. Because now we have a definitive distance that the photon traveled
Yeah,
through space.
I like your train of thought, man. It's pretty cool.
Like, if you like it or not, it's irrelevant. The photon traveled that distance through space. And the guy in the train has a clock and a time.
Yeah, it's just weird. Look, what's the speed of light that we observe in the atmosphere? That too would
I
still
don't
be the
know.
speed of that's the speed of light in the atmosphere.
It's probably only a little bit slower than space.
I mean, it's like, well, right. Yeah.
It's
Yeah,
probably
light's
still a
just
little
light.
slower
Isn't
than a
it?
vacuum.
So it's like trying to compress water, right? Or say like water's incompressible. It's like light's just moving. You can't slow it down, right? But apparently they fucking can. Man, I don't know. I need to go back to school or something. Go back to flat earth school.
What do you think, Left Line? If you're in a Mack truck, can you use the time? Can you use your clock inside your 18 wheeler to tell how far you've traveled on the ground? Like Kojo was legit trying to act like we couldn't use the time in the train or the truck or whatever. We couldn't use that clock and the distance on the ground, which is literally how we get distances or how we get our speed.
You can't use both. Sometimes I'm not sure if I'm listening to like physics being like wrought out, or I'm hearing like people with the ability to play like board games like argue about rules. I'm not really sure what I'm listening to sometimes. It sounds like some people arguing Magic the Gathering for a minute, but what do I know? Is there like a rule book somewhere? Like it's like Bacon always has a rule book. He's like, no, you can't do this and you can't do that. That won't work because you know what I mean. It's like, do you already have are you the rule book master already? Like, where's the rule book? I'll read that shit too. You know what I mean? Who's the arbiter?
Einstein was the arbiter, but that shit was bullshit.
Right? Because the whole idea of experiment is to, well, the whole idea is to do experiment, not just have mental experiment. Mental experiment is regressive to the process of science. You know, if one guy is, it's like, I'm really, really smart. I can do these in my head. Okay. And then don't do them. It's like, that's regressive to like demonstrable science.
I don't know. I feel like Kosho's best rebuttal was you can't use the clock on the train and the distance on the ground, which is fucking insane.
Right.
Like, that's literally nuts, dude. Imagine somebody telling you just took a plane flight and you're like, yeah, I traveled fucking 4 hours, and you look at your watch and they're like, no, you can't use that clock. That was you were on the plane with that clock. You know what I mean? The plane's pulling into the tarmac or the landing strip or whatever, and you're like, "Whew, that was a 4 hour flight. That was a long flight." The guy next to you's like, "You can't use that clock. What are you, fucking stupid? We weren't even in the same reference frame as the ground."
I want to hear what Left Lane has to say. He usually has good responses about this kind of thing.
I'm gonna draw out a diagram later, maybe.
All I know is there's a lot of Glober kids this year that won't get trains for Christmas.
They won't get what for Christmas?
Trains.
Oh, okay.
A 10-year-old child can reconcile this train thing. Maybe 13. I mean, according to Kosho, the guy, if you can't use the ground, then the guy on the train with his clock, you could go at 1,000 miles an hour and you're not moving. Is that how reality works? No, dude, that's fucking dumb. Like you can't if you're on a train and you want to use your clock, you have to say you're not moving, basically. You can't be moving. I mean, come on, man.
What's so good about relativity anyway? They just need it for gravity and orbits and 90 other thousand bullshit things.
Wits had sent me some video about some guy debunking it, and I like the way this guy phrased it. He said relativity is a mental shackle Einstein put on us.
I don't know, man. Maybe they just don't want people messing around with technology. They want to leave it to the few weird mutants that can figure it out, and they'll only get so far. There'll only be so many of them. And at large, like, people just generally don't have to fucking understand anything about it. Yeah. Because it messes up all this designed obsolescence if people understand shit. Doesn't it, Jeremy? Like, people just modify the things that they have, or they'd make them better already. That would just about fuck up the Industrial Revolution, man. I don't know.
What are we gonna do?
I'm just saying, it's like there is a some kind of tie here between Einstein being in a patent office and then Einstein kind of perhaps like screwing up people's understanding of how things actually do work, throwing all this fuzzy-haired nonsense in there. You know what I mean?
Yeah, he's got people gassed up thinking there's a speed limit on light.
It just jumbles people's understanding up to where now everything's compartmentalized, like all these different things today are all like different fields where they may have been the same thing. You know, he's trying to get to like unified field theory, it sounded like, but maybe in a way that's just a clever way of saying, hey, we're dividing everything up so that you can't fucking understand anything. Which would be smarter, you know, if you want control over intelligentsia, right? Science and shit. It's got to be controlled by the universities. They have to codify it in such a way that the average person doesn't have access to it. Not the same way. Or even scientists themselves get screwed up because they're like, oh, I got to do this. Oh, wait. But that's why so many of the great like discoveries happen through sort of accidents in a way, you know, something that they don't do that they were told to do. Oh, guess what? Oh, now it works. Now what? Go back to Lorentz. Figure that maybe Lorentz had some stuff right, and it was influenced by Einstein. And we just try to like understand what was the butterfly effect thing. You know, this whole like thing with Lorentz too that got scrummed. due to a computer bug. That's what we call the butterfly effect. We wouldn't even know what the fucking the real story is with it. The real story is he was trying to map atmospheric data to be able to like predict it, to do accurate, like super accurate projections of the atmosphere. And there was like, he had all these computer systems going, and then they somebody fucked up the computer. Somebody sabotaged his shit, and then the digit register was shifted off, and then all of the conclusions were off after that. And so that's the idea that just a little bit of off can alter the path of a storm, or just the butterfly in there is what can push the storm off. But somebody sabotaged his work so that he didn't have like atmospheric science like proven, basically. I think he was right about a lot of other things, man. Pretty smart guy.
Also, take the Lorenz, system like GPS. And if radio waves can be shot out and nothing stops them, they go over a globe, right? There's no limit. Then why would they need any other system to triangulate than ground-based sending out? You can't have it both ways, man.
Different guys. Rocky, I think they're two different guys. The Lorenz system is from Edward Lorenz, and Lorentz is the scientist guy, butterfly effect fella.
No, I'm talking about the tracking system. They claim GPS is some magical satellite tracking system. Well, if you have a Lorentz system that triangulates and tracks you, can give you your position, and by sending out frequency from ground-based towers, why would you need anything else if there's no limit on that? You wouldn't. You don't need satellites. Even if you incorporated any type of technology that used satellites, like under balloons or whatever satellite system you want, you still don't get rid of the ground-based systems, which they didn't, right? Your cell phone tracks you not through satellite. It tracks you through the cell towers, and it's gotten really accurate because of how many cell towers there are. They're everywhere. Go walk up to a guy that works for the city or whoever you see that's using a GPS surveying system, and go get them to pull up the 5 or 6 or 7 satellites that they're using on their screen. They give the coordinates to them and ask them where those are. They're going to tell you tops of buildings. Satellites. They call them satellites. People don't listen. Like, I've been saying this for years. They just transfer these words, and had Ruhif last night say that you cannot establish a straight line segment, a horizontal line, and then extend that horizontal line. Now, a child can figure out how to do that. You take a ruler, draw a mark, right? Draw a line on the top of that ruler. That's a straight line. Now put the ruler halfway on that line and extend it out, right?
Mm-hmm.
Hello? So you can make it a yard, you can make it a mile, you can make it 10 miles, whatever you want. You take your time and do it right. It's a straight line segment, not curving. Ruhip doesn't think that's possible.
Why doesn't he think it's possible?
Because he knows that's what I did over static water, and there was no water curving. And he knows that everybody in here can go do that themselves. He knows, he's smart enough. And oh, by the way, at the exact same time when we were having this conversation between me, Ruhif, and him, like 3 other Globers jumped in to distract. And, you know, it's amazing, dude. You tell me in 2023 that a surveyor can't extend a straight line segment that he's already established? That's a lie, man. That's just a bold-faced deception in a group of people. But I mean, most people can figure it out now. They know that. They can go look up the books or talk to a surveyor, you know, online or on the street. They're everywhere.
Is there a difference between establishing that and extending that, and establishing and extending, like where Bacon's like, okay, I'm here, and then I've got this azimuth, and I'm just going to draw a line to the star. He's extending that plane there too, as well, right?
What do you think's more accurate? Taking an angle measurement to an apparent position in the sky that's light years away, or basically putting a ruler on a page, putting the ruler halfway down the line that you've already marked and marking a new one? That's basically what you're doing with like a theodolite or whatever. You're just doing it you know, in the atmosphere. You know, you're doing it outside instead of inside on a piece of paper. You understand what I'm saying with the ruler, right? Take any straight edge that creates a horizontal line and draw a horizontal line. And then take that same straight edge and go 3/4 of the way back or a half a way back, and then extend the horizontal line out. Make it longer. That's what extending the straight line segment is. You're only doing it with, you're just doing it with tools that are created to do it with.
Right.
And these tools they're using are created to establish horizontal lines. That's it. The horizontal line on a theodolite is 0, right? There's no angle. It's horizontal. So if you then take, this is what Jesse said last night. This is how I know there's earth curve. I took my theodolite and I measured over a mile over water, and I put a light down there, and the light was below my horizontal. But on this other day, the light was above my horizontal, but that's refraction. But when it's below, that's earth curve. He didn't measure anything. He just viewed a light in the distance being below the crosshairs. But on another day, he viewed the light basically, you see what I'm saying, being above the crosshair. It's no different. That's not measuring anything. Now, you can measure the angle to that light. The one that's above the crosshair, you can say that's 10 degrees above the crosshair. And the one that's below it, you can say that's 10 degrees below it. Yeah, that's measuring an angle to it. But that's not giving you anything but a measured angle to an apparent position.
Gotcha. Yeah. It's interesting.
Jeremy, you here?
Yeah, what's up?
Look at what I just posted. That's Jesse's horizon above the crosshair. It's so rare that everybody we press on it has a picture of it. After years, bro, I used to go to Jose's and show this picture that I took over Lake Pontchartrain, which I've lost. I can't find it anywhere, but that's no big deal. I mean, like, that's why I pressed George to give me his, because I couldn't find mine. But I had one, and they called me a liar. They said I manipulated the picture, and for a year, bro, they were just hounding me about that, you know. And then all of a sudden, George posted his, and everything quieted down. But now Jesse's gone out, you know. And how long has he been here? He got one too. Ruhif went to the Salton Sea. He got the Salton Sea being above the crosshair, or wherever he went, the Salt Flats, or I forget where he was. Wasn't it Ruhif? They all have them. They all know that the object in the distance can be higher than the crosshair.
Wow, that's way over, bro. Way over. Holy
Yeah,
shit.
that's a huge one, bro. I've never seen one that drastic. That don't look that far
Yeah.
away either. And he blamed it on the hot air, but conditions, right? It doesn't matter if it's hot or cold or, if there's whatever. It's just the conditions are right for that to happen. So then you just change those conditions around, and guess what? You got the same object, right? The horizon, the beach, or whatever it may be, the light being below the crosshair. And I think, see, he told me that picture on the right, he told me not to use that, disregard it. I think he told me that because that's basically showing us crosshairs exactly where it would be on where the conditions aren't affected. You understand what I'm saying? Like, that looks like that's where the crosshair would be on a flat earth, or theoretical, You would never measure this way to prove the shape of anything. You're only observing where the distant horizon or distant building or boat or light or whatever is in reference to the crosshair, but the crosshair is really close, right, to your eyes. So it's not being affected by all these conditions. That's the whole point. That's why you take measurements 200 feet and not 200 miles. We get off these trains one day, we might get people out there measuring water. Maybe we could take a train to local water.
Dude, they're done with this train thing. Kosher said we can't use the fucking clock on the train and figure out how far we traveled on the ground because it's a different reference frame. It's so ridiculous.
I heard him stumbling and fumbling. I'll give you one guess what I'm fixing to get out of the truck and do. That's right, boys and girls. Establish a horizontal plane.
Yeah, but anyway, Rakia, that whole like the so just trying to do like the straight line from like the ground to some kind of imaginary point in the sky. That whole thing is yeah. What are those? Wow, man. Give me a minute. I'm sorry. I'll be right back.